Welcome everyone, this is another Chris Course with your host Chris, and today we're going to be coding a Pokemon-styled game. So to create this game in our browser, there are a few things we have to do. Well, maybe not a few, but quite a lot. So I grouped these into sections to help us better proceed with development of this project. The first section is going to be map creation with the tiled map editor. So the very first thing we need to do is actually create this map we see in the background. Make sure that we lay it out correctly so that when our player goes ahead and runs into things such as the side over here, we can't do that. We need to go ahead and make sure that this looks cohesive, put all of these elements in the right spot, make sure that our player can move behind objects like this house right here. So there are a few things we need to do to make sure that our map is laid out correctly, and in order to do this we're going to be using the tiled map editor. Then later on we're going to proceed into the player and map development section. What do I mean by this? Well, we need to actually take the images we generate from the tiled map editor and put them inside of some sort of programmatical game like we have right here with JavaScript and Canvas. Then finally we are going to be activating some battle sequences. So when we go ahead and walk in the grass over here, our battle sequence engages and then we can go ahead and fight an enemy. Now there is so much that goes into a battle sequence like this. I try to keep it as minimal as possible. So really we're only going to have 2 attacks, but you can actually go ahead and scale this up to have as many attacks as you would like. But you see right here, we have an animation for fireball, and we have animation for tackle, and right now the enemy only has 1 animation as well. As much as I'd love to add things such as player levels, the amount of times you can use an ability, being able to capture these Pokemon style creatures, well, it's really just not feasible within the amount of time we have for this tutorial. I already expect this one to be anywhere from 3 to 8 hours long, so this is the minimum of what we're going to do to start. But you'll see eventually when I go ahead and finally eliminate this enemy, Draggle right here, the enemy faints, and then we are moved back to the scene. Background music starts playing. Wasn't playing it by default, just not to annoy the camera. But that is the gist of what we are going to be doing. Now, like always with all my tutorials, if you want to go ahead and take this to the next level, there will be tons of bonus content over on chriscourses.com. Some things I thought about adding into this game were conversations with other characters, entering buildings, traveling to other lands, item collections, health bars, healing, and gym battles. That is honestly a ton of content. This could honestly go on for over 80 hours worth of course content. So forget all that stuff, let's just focus on the main thing, that we need to make our very first Pokemon styled game. So the very first thing we need to do is create our map, and we're going to be using the tiled map editor to do this. So what is the tiled map editor? Well, it's going to be an app that's available on both Windows and Mac. And you'll see if I open this up, this is how I created this map. Basically, this allows you to place tiles in certain portions of a gridded area. If I turn that grid on, it looks just like this. So each of these are just little tiles that fit into these areas right here. And what this allows us to do is place boundaries all along the edges of our map where we want our character to move. So what we can do here is we can export our background images without the collisions. So if I turn the collisions off, it's going to look something like this. We're going to export this whole background image as one large image, and then we can go ahead and export these collisions separately so that when our player moves throughout the map, we can track collision between our player and these collisions right here. They're not going to be visible within our game, but they will work. They will not allow our player to move past these red boundaries. And the reason we're making this within a tiled map editor is, well, it's going to allow for a lot more detail than if you were to go ahead and generate out a map using just pure JavaScript. What do I mean by generate out a map using pure JavaScript? Well, I did this within the last tutorial on Pac-Man actually. So if I go ahead and check out Pac-Man, this map right here is completely generated using an array. And this works for Pac-Man because we don't have that much detail here within this game. You'll see we have a few pipes, we have these little pellets, we have our ghosts. That is totally fine for a low detail game like this. But if we go back to tiled, you're going to see there is so much detail within this map. Imagine having to lay this out with an array, and you might be wondering, well, what am I even saying with lay this out with an array? Well, let me bring up the code for Pac-Man real quick. So if we look at the code for Pac-Man, this map over here is completely generated by this array. So if we look at things, this little one right here refers to a top left corner piece within our Pac-Man game. So this guy right here in the top left corner is just referring to this one right here. And each of these little pipes up top, these little dashes, is just referring to one portion of the pipe. So these are actually little grids, and they're drawn all throughout our Pac-Man map. You'll see the dots are pellets. One of these dots refers to pellets. And then we have different symbols to represent different things within our game, such as side pieces, caps, corners, and so forth. So this is how the Pac-Man game was generated. Now imagine trying to generate, not a Pac-Man game, but our Pokemon game over here. Imagine how big the array for this game would be if we were to use the same style we'd use on Pac-Man over here. It would be absolutely massive, and would just make our game a pain in the butt to actually develop, especially if we want to go ahead and layer pieces on top of each other for our game. So it's very important that we use some sort of tiling editor. Tiled is free, and it's probably one of the easier ones to use from what I've actually experienced. So that is what we're going to use. So before we even download Tiled, the very first thing we're going to do is find assets for our game, because we need those in order for Tiled to be able to build out our maps. So where would I go to download any free game assets? Well, I would actually go to itch.io. So this is going to be an indie game community, basically a marketplace for both free and paid assets for your games. If I go all the way over here to the left-hand side of the website, you're going to see some text that says game assets. We're going to click on that. And then you can go ahead and select a top-down tag, because if we look at our game, the Pokemon game is basically a top-down game. We're looking up from the top down at our player. So we want to go ahead and click top game assets. And now that we have that tag on here, we can go ahead and see what is available to us. So you'll see some of these are paid, and it'll be notified by a tag right here, but some of these are going to be completely free. And if I look at the most popular tag right here, these are some of the most popular ones available. I looked through a few of these, and honestly, the Ninja Adventure one is probably the best free asset pack you could ever get. Really incredible work by that artist over there, and we actually will be using some of it. That is by Pixel Boy, but in order to generate our map, we're actually going to keep on scrolling down until we get to the 12x12 RPG tileset. So this is free to use for both commercial and personal use, and it's perfect for our type of game, a Pokemon style game in which we can go ahead and travel some sort of unique world. So this is what it looks like. It comes with a tile grid that looks just like this and allows us to produce worlds that look like this. So how do I actually download this? Well, we can go ahead and click the download now button, and then we can go ahead and donate to the author, which I really recommend doing because they for sure put a lot of effort into this project. But if you would just like to get the free version, you can go ahead and click no thanks, just take me to the downloads. And then it's going to allow you to download everything you need. So we do need the full asset pack, and we do need the character walking, but that might come in the full asset pack. So let's go ahead and download the full asset pack. Now, if for whatever reason this is no longer available on itch.io, this will be available within a Google Drive link within the description, just to make sure that everything is safe and sound for future use of this tutorial. So if I go ahead and open up my Finder, check out my downloads folder, and look inside of that, you're going to see this is what I downloaded. It's going to be our asset pack, and this is laid out perfectly with a 12x12 grid format so that we can import it into the tiled editor. You'll learn a little bit more about that and understand it as we go, but you'll see the character isn't actually here. Let's go ahead and make sure our character is downloaded as well. We just need to make sure that we download these 4 items too, so I'll click download on those 4 as well, and let's go ahead and check those out. Now we have our character walking in different directions. This is how we're going to animate our characters. We need these little sprite sheets right here. But something I do want to note about this asset pack is there is one issue, especially with this PNG right here where everything is being displayed. If I go ahead and open this up, and I zoom in on this one building right here. Let's go ahead and zoom in on that. If I zoom in on this building, you'll see it is off by a pixel. These just don't line up, and that is pretty unfortunate. Just a small mistake, obviously, when this was exported. So what I did was I fixed this behind the scenes. If you want to go ahead and get the fixed up house, which we're going to use, you just need to make sure that you download the link within Google, but I still highly recommend going ahead and supporting the author who made these in the first place. So you'll see right here, within Tiled, I created a tile set, and that goes ahead and fixes that one issue for this house. If we zoom in on it, well, now these are lined up a bit better. Not even on perfect, I kind of messed up here, but we should be good to go with this instead. So what I'm going to do is I'm going to go ahead and create a new folder. I already have one called Pokemon Assets. I'll go ahead and create another called My Game Assets, just to differentiate the two. And then I'm going to go ahead and pull, well, I'm going to go ahead and pull our character sprites into that. But I'm not going to go ahead and pull in the first asset pack that we downloaded from itch.io, simply because the house is a little off. Instead, I'm going to go inside the Pokemon Assets folder, and this is available within a Google Drive link. And then I'm going to grab the tile set within here. I'm going to copy this with Command C, go back to My Game Assets, and then I'm going to go ahead and paste that in. So that is going to act as a tile set for when we are using tiles rather than the one that came directly from itch.io. So definitely go ahead and check out more of itch.io. For any game assets you might want to use, you'll see there are a ton of different styles, and these are really, really great assets, and you get a ton of them for free. But now that we actually have this tile set, well now, if we go back to our to-do list, what do we need to do? Well, we can check out Find Assets. Now we need to go ahead and download Tiled. So that is going to be the map editor app in which we can actually go ahead and place these tiles and create a map. So how do we go ahead and download Tiled? Well, a simple Google search will suffice, and the download link will also be available within the description if you want to go ahead and speed things up a bit. So I'm going to go ahead and type in Tiled Map Editor. We're going to go ahead to the very first link. Then we can click download on itch.io. You'll see these two work in tandem pretty well together. So here it is. All we need to do is download now. And like I said, this is completely free. Even though this is going to show a price right here, this is basically just a suggestion for a donation. I really recommend donating to them as well because this stuff would not be available without their hard work. But if you want to go ahead and get this for free, like always, you can just go ahead and press no thanks. Just take me to the downloads. And then you can install Tiled for the platform of your choice. So I'm on Mac OS, so I downloaded that right here. If you're on Linux, you can click this one. If you're on Windows, just make sure you're selecting the right bit, and then you can go ahead and install that from there. So I'm not going to go through the whole installation process of actually showing that install, but once you go ahead and install this, make sure that you open it on up. I'm going to close my Tiled so we can start from the very beginning of what Tiled should look like when you open it. So when we open up Tiled, it should look something like this. It's not the most intuitive platform, but it's easy to get around once you actually import your tile set. So to import our tile set, that image that we just downloaded, we want to go ahead and click New Tile Set right here. So what is a new tile set? Well, if we look at this tile set right here, this is indeed a tile set, but what does it even mean to be a tile set, I guess is what I'm asking. Well, a tile set is basically going to be this image right here that is perfectly laid out in some sort of grid format. So when we downloaded this was a tile set at 12 by 12 pixels, which means each of these was laid out perfectly on a 12 by 12 pixel grid. So since these were laid out perfectly on a grid, like so, each piece, and apologize for my poor writing here, each little piece of one of these grids is going to be able to be plopped on top of the tiled map editor. And when we combine all these little pieces together, they're going to be laid out perfectly so that we can begin adding in those collision blocks. It's really important that we place those collision blocks in just so our player can't go off the screen where we don't want them to go. But allowing us to have some sort of tile format like this is going to allow us to really make our course look great and connect all these little small pieces together to make something that looks really good. So that is why we're using tiled and some sort of tile set like this. And thankfully the artist of this set already laid everything out perfectly so we can go ahead and grab it and place it on top of some sort of map. So what we're going to do is we're going to go back over here and call this tile set what? Well, we can go ahead and call this Pokemon style game. Type, we can go ahead and keep this as based on tileset image because we know we're going to be using a tileset image. Now, what is the source? This is just going to be the image that we want to use as our tileset. So we're going to go over to downloads, and we know this is in My Game Assets, and it's going to be called tileset.png. This is what we want to select. So we'll go ahead and open this up, and then for our tile width and tile height, we want to make sure that this is 12 pixels because that is what this tile set was meant to be at. If you go to the homepage of this tile set, you'll see that it was meant to be at 12 by 12 pixels. So we need to make sure that this is exact to the actual tiles for the tile set we're using. So with this is all we need to get started. So we'll go ahead and click Save As after that, and then we just need to save this in some sort of location. So this is going to be the project file for tiled. We just go on over to My Game Assets and save it directly in here. You'll see this is going to be saved as Pokemon style game. Great, that works for me, and we can go ahead and select the tiled tile set files. So I'm going to go ahead and save it. So you'll see that I'll go ahead and open up, and this is what it's going to look like. So you'll see, since the author went ahead and laid this out perfectly, all these assets are divided up into 12 by 12 grids. So we can either go ahead and glob a blob of grids, or we can go ahead and just grab one little individual square and copy it out onto some map. So next thing we need to do is start creating that map. This is just the laid out tile set that we're going to be using to basically copy and paste these images into our map to create something that looks really good. So in order to create a new map, we're going to go up here to File, New, and then hit new map. So most of this you can go ahead and leave it alone, but we really want to focus on our map size. How big should this be? Well, I know I want our game rendered out at about 1024 by 576 pixels, and I already did a little testing with this, so I think the ideal width and height is going to be 70 tiles wide multiplied by 40 tiles tall. So if we look at this, our map is going to be 840 pixels by 480 pixels wide. This can be rendered out on a larger screen, which we're going to need to do anyways because our tile width and height is so small to begin with. Ideally, it would be something like 24, 32, 64 pixels wide for these, but this is what we're given, so we're going to go ahead and work with it to make sure we get exactly what we want. But you'll see right here, the total width and height of our project is just going to be the 70 tiles times the actual width of one of these tiles, and same thing for the height. 40 times a height of 12 is going to be 480. So that's what's going to determine the actual width and height of our map. So once we go ahead and change our width and height right here, we can go ahead and hit save as, and then we want to go back to my game assets. We're going to save this here as well. And I'm going to go ahead and say this is going to be called Pokemon Style Game Map. So once we go ahead and put that in, we can save this as a separate map. So now we have two things open right now. We have our map, which is just going to be this blank grid right here, and we have our assets on the right hand side. This is basically going to be our copy paste section. So we can go ahead and grab one of these and begin drawing out our map with that. We don't really need this project sidebar right here, so I'm going to go ahead and exit out of it. But now we can go ahead and begin using the tile map editor to actually draw tiles onto this grid right here. So how do we want our map to look? Well, I know I want to go ahead and make sure that this is some sort of island map. So I want the whole thing filled up with water first. And when you go ahead and develop these maps, you want to go ahead and think of this from a layer standpoint. You'll see over here we have a layer bar, and this is very similar to things you'll see in like Photoshop, Illustrator, and XD. These are going to be layers for actual tiles. So let's think. If we want to go ahead and build an island, what do we have to build the island on? Well, an island needs water, so that'll be the first layer. What comes after the water? Well, we're going to need some sort of island base. We'll go ahead and grab material like this. Then what comes on top of the island? We're going to need things like grass, plants, houses, and then we might even want to build a plane on top of that. So it's very important that we go ahead and lay these out in layers, because later on, if we want to go ahead and turn things on and off, make sure we get a different view of things, such as how does our island look with flowers, without flowers, with trees, without trees. It's going to be very useful to be able to toggle these on and off. So let's go ahead and start with tile layer 1. How do we begin actually posting tiles onto our grid right here? Well, we're going to want to make sure that we have this layer selected, and then we're going to go ahead and select this brush tool right here. Then finally, in the bottom right corner in our tile set that we imported initially, we're going to go ahead and click the tile we want to begin drawing. So I'm just going to start by zooming in on my trackpad. I'm going to start with this one little tile in the center right here. So if I go ahead and select this, and then I'll zoom in on this grid right here. So I'm doing it on the trackpad by expanding my fingers. You can go ahead and do it with your mouse by using the scroll wheel. Let's just go ahead and expand inwards. You're going to see now I have this little icon right here getting ready to be drawn on top of the grid, and all I have to do to draw this is just hold down and pull across the grid squares that I want to draw this on. So that's pretty cool, right? We're going to go ahead and draw out this map just by dragging and clicking. But obviously, this is going to take a very long time to fill up. And in addition, this isn't very randomized. This isn't going to look very good if we just go ahead and keep drawing out this tile exactly like we are right now. So one, we need a method to fill up this whole grid a lot quicker. This is going to be our island water. And then two, we need a way to actually randomize this so we don't get some sort of boring pattern like we see right here. So let's start with just filling up blank sections of a grid. So let's say we want to fill up the whole thing with water. What we can do is we can select this paint bucket tool right here. This is going to be the bucket fill tool. You can either just click on it or hit F. And you'll see once I select that and I make sure I have a tile selected right here and I hover over our grid, it's going to go ahead and highlight the empty areas that have not been filled in with a tile yet. That is great. That is exactly what we want. So if I were to go ahead and just click, you're going to see our entire grid, the area that hasn't been filled up yet, now has this little tile that we have in the center right here. But that doesn't solve the issue of adding some sort of randomness to this actual grid. So if I wanted to go ahead and make this a little more randomized, the very first thing I could do is I could select not just one of these squares over here, I could select multiple of them. So if I click and drag and select the whole thing, now if I hit the paint bucket again, and I hover over our area, even without clicking, if I hover over this, you're going to see exactly what it would look like if we were to go ahead and paste this in. So I could go ahead and just paste that like so. And that is already looking a lot better. I don't think we'd actually ever be able to tell that this is some sort of pattern in the first place. So that's going to go ahead and lay things out like you see right here. And I think that honestly looks really good. But if you want to go ahead and randomize this even further, you can go ahead and click on this dice button over here. And what this does is it's automatically going to select a random square from what you have selected. So see right here, when I try to use the fill tool, well, it's only selecting one square because the fill tool is going to select all like squares that are around one. And so right now all of these are going to be different because we actually filled it in with all of these 9 squares that we have. So if we want to go ahead and test out this randomization tool, we can go ahead and click this little square selector right here, and just go ahead and drag over our whole map and then hit delete. And that's going to delete everything that we just put in. But now we can go ahead and use our fill bucket again, making sure that we have the dice selected, which I do, and make sure over here that we selected all the squares we want to have randomized. And now you'll see when I hover over the whole thing, all these squares are alike, so I can fill in the whole grid. And then I click, and now if I look very closely, these are going to be completely randomized thanks to the tool we used over here for complete randomization. And we can see how this looks by hitting Command G or Control G for Windows to see this is a truly randomized grid that we just created. So that is looking great for our water. We are creating that initial base image in which we want to use for moving our character around a map. So now that I have this layer created, I want to go ahead and rename it to something a little more descriptive so that when I come back to this, I know exactly what this layer is. So I'm just going to go ahead and call this water. You can call it ocean. Doesn't really matter. Both are descriptive of what we just put on. So now we know we need to create some sort of landmass. And if I zoom out on our tile set over here, you'll see we have a bunch of options for creating a specific landmass on top of this. So the very first thing I want to do is create a new layer. So I'm going to right click on the section right here, head over to new, and then I want to create a new tile layer to begin layering new tiles on top of our water. Because if I were to select our water and I were to select some grass and use our brush tool to just start coloring on top of this, you're going to see, even if I turn off our water layer right here, it also turns off the grass. We just did some destructive editing to our water by covering it with grass. We don't want that. Rather, we go ahead and select our tile layer 2, which is going to be our island layer, begin drawing on top of this, and then when I turn this off, just turns off that layer. We can turn off the water to just view this. Looking really good. Just a nice and easy way for non-destructive editing for our map. So tile sets are usually designed in a specific way. And what I mean by that is if we zoom in on one of these elements, or I guess these two land masses down below, you're going to see a little bit of differentiation. The very first thing I notice is that this right here has a border bottom that is green. It has this greenish shadow covering the very bottom of the landmass. But over here we have a watery blue shadow. So if we think about this landmass right here was meant to be the island landmass, while this was meant to be on top of grass. So if we were to go ahead and create some sort of landmass on top of our water right here, we would want to use this bottom landmass to begin creating that. So a very quick way to just get started with everything is first I'm going to go ahead and erase what I have right here by using the rectangle tool, selecting that area and making sure I have that layer selected, hitting delete. Now we're good to go to actually begin using what we have over here. So I'm actually going to go ahead and select the brush tool, and I know I want this one landmass right here because it's supposed to go on top of water. What I'm going to do is I'm going to select from the top right hand corner all the way to the bottom left. I'm going to select that whole thing right there by clicking and dragging. And then I want to make sure, before I actually paste this in, that I have this randomization button turned off, because otherwise it's just going to give us one square to randomize between. I'll go ahead and turn that off, and now you'll see with the brush tool, we actually have that exact landmass, and if we zoom out, we can plop this right in the middle of our map. So cool, we have our very first island for our game. And if you go ahead and select a little too much, like I did right there, you can simply take this eraser tool, click on that, hover over the spot in which you accidentally drew something, click, and now it's gone. That easy. So this is our very first island. We can turn it off with the layering over here. But now that we have this island, I want to go ahead, call this the island layer. Cool. So if I want to begin extending our island, well, obviously we just place this big chunk landmass right here, but how do I actually make this island bigger? Well, now it's going to be up to you to begin extending this using pieces of this landmass. So you'll see right here, if I zoom in on this one little square I selected, this is just a bare green square. That is perfect for extending the island landmass we have right here. So if I go ahead and select that, make sure we have our brush tool selected, and I'm going to turn our grid back on with Command G just so I can see exactly where I'm going to be placing things. You'll see if I begin drawing on top of these little edges right here of our island, that it gets filled in with a green square, and we need to be pretty precise because some of these have such small details on them to really bring out the reality of your game that we want to make sure that we cover these little edges up as well. So I'm just going to go ahead and start drawing over all these nice little edges that we had previously to where I want to extend this landmass. So I'll go ahead and add a couple more rows on top, and I always want to make sure I'm really looking at these detailed pieces right here. Get rid of those. We might even need to fill those in with a new detailed piece that only faces to the side, but let's just keep extending this. I'll go ahead up 3 or 4 rows or so. So our island just got expanded by 4 rows, but obviously this over here looked way better than what we have right here. This just doesn't look realistic at all. So I want to go ahead and expand this. What I can do is I can go ahead and select our side pieces right here. So I want to make sure that I select these top 2 because this bottom one right here, if I zoom in on that, you're going to see that this side piece is meant to connect to some corner piece. So I don't want to use that one, but I know these 2 side pieces right here, well, these can definitely function as side pieces for our map. So if I select those 2, and I go ahead and place a new piece right here, I can zoom in, and actually that looks a little bit off. So we might even need to use just this top piece. Why does this look off? Well, you'll see right about here, we're missing some blue pixels that are supposed to extend from this portion and this portion onto this bottom square right here. So these 2 tiles don't actually connect. So we want to make sure that we go ahead and use the correct pieces here. So we're no longer going to use both of these pieces. Instead, we're just going to use this middle piece because I think we can go ahead and connect that to everything else on the side. So if I go ahead and replace this top piece right here, which corresponds to this one right here, I can go ahead and click. And you'll see, actually, yeah, that it connects pretty well to the other middle pieces. So I just want to use this middle piece to begin creating my sides. I'll go ahead and drag that on up to when we get to right about here. And now I want to do the same thing for the right side of the screen. So I'll move on over to the right of our island. I'll select the middle side piece, and then I'll just begin drawing upwards with that middle side piece, making sure I have the brush selected. So I want you to go ahead and pause the video and try doing this on your own because it's really important for you to actually execute this stuff to get it really ingrained in your memory. Go ahead and try adding the top portion of our island right here by selecting the correct tiled piece from over here in our tile set. So once you think you have that down, this is how I would go ahead and do it. I would go ahead and look and say, well, I just came from this right side over here. What is the very first top piece I might want to add into this? Well, I would go ahead and say probably this one. And I just want to go ahead and make sure that it would connect if I were to place it right next to itself. So if I go ahead and create this right here, and then also create this right here, I honestly think these connect pretty well, and that should be good enough to create a whole top side of our island. So I can go ahead and just drag that on out, and now we can really get down to detailing out this island. So this is looking a lot better than we had previously, but now we want to fill in the little details that come with our tiled map editor. So one of the little details is going to be for our corner pieces, for where we have this corner right here on the top right of our island. The first thing I want to do is select this inner piece, because this inner piece is going to have detail right up here and right on the side. That's going to make this top piece and this side piece look more realistic. So if I go ahead and select this corner piece and click right there, well, now this top piece definitely meshes in better. But you'll notice over here, for our corner piece on the side, we used this middle piece right here instead of this top one. Whenever we create some sort of corner, we want to make sure for the very last piece we are selecting, well, the very last piece. Right now we're only selecting the middle. So I'll select that very last piece, and then say, for our last piece, I want to add that in. And now that is looking really darn good. Everything connects very well. It's looking very realistic compared to what we had before. No jagged edges. And now I just want to make sure I keep adding detail for these inner portions of our grass. So what I'll do is I'll go ahead and select this middle portion right here, because I know that's going to be the detail for our middle portions on the side. And then I can just drag on down that middle portion. And now I see we have detail all along the right side of our island. Let's go ahead and do detail for the top of our island. Well, we know if we want to go ahead and add detail right here, well, we could try adding this corner piece that we used for this top one, but you'll notice it has detail on the right side. We don't want that. We just want detail on the top side. So we can go one over, and if we go ahead and add that in, well, maybe it does work out. That's pretty close. It's just a different color, but if we want to be even more realistic, we can go ahead and select this second top piece, and say, hey, I don't want to use just the corner piece for this anymore, even though it does mesh pretty well. I want to use this top piece instead. Draw over it, and now that is supposed to be the one that actually meshes in better with what we have right here. When it's this close, it's kind of up for interpretation. You'll see if I go ahead and swap between what we just had, well, this isn't much different, and it doesn't mesh in any better than it did before. So we could honestly just go ahead and leave this as we had it, and just say we want to go ahead and select this top detail piece, and just fill in the rest of these blocks with that detail. So we'll go ahead and do the same thing for our left side over here. Once again, I want to challenge you to pause the video and fix this corner right here and add in all the detail from the top of our island to the very bottom on the left-hand side. So once you think you've gotten that down, this is how I would do it. I would go ahead and add in the corner right here, a corner detail piece, and then I know this doesn't mesh really well on the top left-hand side, so I'll go ahead and select the top left-hand side of the island within our tile set, overwrite this piece right here, and now that looks a lot better. And now I can go ahead and grab this middle piece and just begin dragging down to add that detail to the left side of our island. And now we created our very own island using this island set that we had over here. We basically just morphed this island piece to create something that looks really cool. So you can really take this to the next level by adding these little pieces right here and begin extending your island as you wish to create something that's more diagonal and something that's even bigger than what you had it. I'm going to keep this as is for now, just for time's sake, but definitely go ahead and try creating more of this island on your own, because in the end, this is going to be your game, and you want to make it as cool as humanly possible. So just checking up on to-do, let's go ahead and check off what we finished already. We downloaded Tiled, we imported that into our project, so we can go ahead and mark off downloads and setup. We were already creating our map, and now we went ahead and finished tile layering for ocean and land masses. So I'll go ahead and check that off as well. And now I'm going to go ahead and edit this a little bit as needed. I know next up, I want to go ahead and show you guys how to create another landmass on top of this, which our character can move up to another level. So I'm going to go ahead and say this task should be tile layering for a plateau. If my third grade geography and science does me right, I believe this is called a plateau. So let's go ahead and create a plateau. So what do I mean by a plateau? Well, I want to build a landmass on top of this little island right here. And the perfect way to begin building a landmass is using the second landmass piece that we have above our water landmass. So once again, we know this is meant to be placed on top of landmass layers because its shadow on the bottom right here is going to be a greenish shadow rather than the blue shadow. So we know this is meant to be placed on top of islands or land masses to begin adding extra depth. So if I were to add this in, I would want to make sure definitely to create a new layer. So I'll right click and hit new layer, and I'll call this plateau. And now I can begin building this. How do I want to start building this? Well, we only have so much real estate, or at least I do, for a small tutorial map right here. So what I'm going to do is I'm going to select just this portion right here with this little striped section, which is going to act as stairs in which our player can actually go up from. So if I go ahead and select that, and then drag it over our game, you'll see this is actually a little bigger than you might have figured. So I can just go ahead and place this in a location that I think is good. And I actually want to place this a little higher to the top of our map rather than lower, because we need a little bit of area in which our player can move and actually get up this. So I'm going to go ahead and place this right here. Just click that to make sure I have the plateau layer selected when I do that. And you'll see, just like that, now we have some sort of plateau on top of our island, although it doesn't look that great. Let's just say for tutorial purposes, I want to make this little plateau very small. Maybe it's just an altar or something like that that we want to go up. And if I want to make this as small as possible, well, I'll go ahead and get rid of this angled portion right here by selecting with our rectangle tool. And I'm going to go ahead, hit delete. And now this is starting to look a little better, but you'll see the top of the plateau meshes into the actual bottom of it. So I know I need some side pieces to fill this in. So to get some side pieces, I can go over to the tile set over here, grab some of these side pieces. I'll go ahead and grab these 3, and then I can just go ahead and paste those on in. Now you'll see I'm just missing a corner piece, so I can select that corner piece, paste that on in, and I might want some detail right here for these tiles. So in order to get some detail, I can select the corner piece detail, paste that in right there, get the side piece detail, put that on in. If I really want to be exact, I can get this bottom corner piece detail. And now that looks really good for our little plateau right there. And same deal as before, if you'd like to extend this plateau based on your map, you can begin selecting the front of this plateau, and then just make sure you move this to the correct location to actually begin creating something that actually matches up and expands together. That's really all you have to do, but I'm going to go ahead and keep this as is for time's sake on this tutorial, but we definitely want the water, we want the island, and we want the plateau, but we're going to keep adding more and more onto this island just to show you exactly how to get those very detailed effects using this map editor. So I'm going to check off tile layering for a plateau. That is great. I'm going to add in another piece right here. It's going to be tile layering for a house. So if I really want to start adding detail in, well, maybe we want some sort of house. Maybe this is our player's house or another character's house. How do we add that in? Well, I know I want to create a new layer. So I'm going to right click, hit new tile layer. This is going to be my house layer. So it can either hold one house, multiple houses, probably going to hold all the houses within my game. So if I wanted to create a house, I would go ahead and select from the edges of our house right here, a small little box, and I'm going to go ahead and add one more row just so I make sure I have all the detail of this house. And with that, you'll see now we have a pretty house in which we can just go ahead, click, and plop onto our screen as long as we have our brush object right here selected and our house layer over here selected too. So that is already looking like a very cozy, nice island for our player to be in. And that's pretty much all we have to do to get started with our house. But you'll definitely want to make sure that when placing this house, well, you give your character enough room in the front right here in which they can actually walk around. That's always going to be very important. We wouldn't want to place our house right up here in the front, because otherwise, if we wanted our player to walk into this building, well, it just wouldn't be possible. So we're going to go ahead and make sure our house is in the back, and that is simply how we're going to go ahead and layer a tile for a house. Simple enough, right? So let's go ahead and start working on trees. And I went ahead and made this a separate task for trees because they can get a little tricky when we want to go ahead and place trees in front of each other, behind each other, and so forth. So I wanted to show you how to do that as well. So in order to go ahead and create some trees, well, I'm really running out of real estate right here on our island. If you're running out of real estate on your island, what do? You just simply buy a new one or expand it. So we have the money to do that, right? So here's what we're going to do. We're going to select our island right here. And then I'm going to select this rectangle tool. And then I can go ahead and cut out a portion of the island I want to expand. Basically, I'm going to be copying a piece of the island, pasting it somewhere else to really expand it outwards. So I'm just going to go ahead and create a whole new backyard for our house. And to do that, I'm going to go ahead and click right up above here and start expanding this downwards. And I want to make sure that I'm not selecting any part of this ridge on the very bottom because I want to expand the side. So I'm going to go ahead and select that area, and then I'll hit Command C. And then if I hit Command V, you're going to see on the brush tool, we have a new portion of our map selected, which we can just simply brush onto our island. So I go ahead and move this up. We can see a little bit of what this would look like. Now that we have island selected, I can just go ahead and click. And you'll see once I move to the side, we have a whole new backyard for our island. That simple when you know how to use the right tools within the tiled map editor. So we have this new island, but we know we want trees in our backyard. So I'll go ahead and right click, hit new tile layer, and we're going to go ahead and call this trees. So I move this up above our house. Now we have a section for trees. And the reason I'm moving this up above house is because I know my trees should go behind the house. So now that we have this new layer for trees, we'll go ahead, zoom out of our tile set right here and look for some trees, and they're going to be right here. I really like these big trees right here, so I'm going to go ahead and select one of these, make sure that I cover the whole thing, and then with my brush tool selected, you'll see now I can start drawing trees. So I want these in the back of our island. So in the very top right corner, I'll draw one. I'll move on over to the side. You'll see I can't really draw these on top of each other on the same layer. If I were to place one right here, well, that just goes ahead and cuts out the other portion of the tree right there, and that just looks terrible. So we want to make sure that we're giving it enough space to create some new trees all the way over here. We'll just cover the whole back row with some trees, and that honestly looks pretty good. We could go ahead and call this done, but if we want to add a little bit of realism to our map right here using tree design, we can go ahead and create another layer specifically for trees. So we know we have this trees layer right here, but if I want to go ahead and create a new tile layer, we'll just go ahead and call this trees 1. Now I can go ahead and draw some trees in front of those other ones, and when I do that within the trees 1 layer, well, now I can overlap these on top of each other because they're not going to destructively take out the artwork that was on the previous tree that we just put in there. So I can go ahead and toggle these on and off, and you'll see how these are layered on top of each other. It's very important that when you want to layer similar tiles on top of each other, that you create these new layers to create the effect you want. So if you wanted even more layers of trees, well, I couldn't go ahead and place this within trees 1. You'll see that just goes ahead and takes those out. I would want to go ahead and create a new tile layer call it trees 2 for the second layer, and then when I place this right here, you'll see now we have this nice little triangle of trees. I actually liked it better before, but you can go ahead and either keep or delete this trees 2 layer to create the island as you wish, with as many trees as you wish to. So that takes care of layering and placement for trees. Now we want to go ahead and add in some landscape details. Honestly, this one is pretty easy for the most part when it comes to flowers and grass. We just need to know a little bit of randomization, but I think it's more important to take care of the pathways over here because it can get a little tricky to make sure that we lay this out correctly. So for the details, let's go ahead and create a path from the beginning of our house over to our little plateau over here. So the first thing I would do is determine, well, where would a path go? Would we go ahead and create a new layer for it? Would we go ahead and draw on top of our island layer right here? Honestly, we could do either or. I think it makes more sense to create a layer. That way we can always turn this off as needed and not destroy the old artwork that we did. So instead of drawing this directly on top of our island layer, I'm going to go ahead and right click, hit new tile layer, and we're going to call this paths. So now I know I want to draw a path from our house over here. What I could do is just go ahead and select all of our sand paths right here. And I know if I want to go ahead and make these randomized, I can just select these little dice. And it's going to go ahead and make sure that each tile that I go ahead and draw on here is going to be a different tile. So really cool stuff right there. And if I want to go ahead and make sure that this little area before our plateau is filled in too, all I need to do is draw on top of it, and that already looks pretty darn perfect right here just because we layered everything correctly to where our plateau is placed on top of our paths right here. So it's automatically going to give us that really cool effect. So that takes care of one path, but this could be a lot better. How? Well, we could go ahead and extend our path and make sure that it connects to our grass using these tiles right here. So you'll see if I zoom in on these tiles that they have edges for our grass that connect to the actual sand path. So now if I zoom in on our map, you'll see our grass right here does not connect very well to our actual sand. So what I could do is get the piece where the sand is on the bottom, select that. And I really want to make sure I turn off this randomization tool so I don't get any weird effects with other tiles coming in. And then I can just go ahead and draw on the pieces where this tile right here should have some sand on the bottom and put that in every location and where I want sand. And just like that, we really made our piece look even better than it did before. So now I want you to go ahead and pause this and try filling in the bottom row right here with some connectors on our tile set that make sure that the sand connects to the grass below. When you think you have that done, let's go ahead and see how I would do it. I would go ahead and select this top piece right here, and then I would simply draw that onto our paths layer, like so, but we have an issue right here. If I try drawing onto this paths layer right about here, you'll see it's covering part of our island and it just ruins the look. So what I want to do is I want to extend our island at least 1 or 2 rows downwards. How do I extend our island? Well, same way we extended our island on the top. We want to make sure that we select the island and then go into our rectangle tool, which is going to be this guy right here. And then let's say I want to extend this by 3 rows. I'll go 3 rows up from this one right here. So 1, 2, 3. Select from right here everything that I want to copy and make sure that I get this bottom piece right here that has some detail on it. I'm going to hit Command C, then hit Command V. It's automatically going to put me in the brush tool with this big piece selected. And now I just need to cover the correct portion in which I want to expand this. I know I don't want this right here because we might have this little piece showing where my mouse is. So I'll go ahead and cover that and then just click. And now we have more real estate on our island. So what we can do is we can go ahead and add more sand pieces. So I'll go ahead and find our sand pieces. They're going to be right about here. And now I know I want sand on the top. So I'll grab that top sand piece and begin filling in those other pieces to make sure I have a nice sand path. Well, this might be a good sand path for someone who's really small, right? But what if we want this bottom row filled up too? What is a quicker way to do this? Well, one thing I could do is I could just go ahead, go back down to our sand piece, select all these, and randomize a huge row right here. But that's a little tiresome. I like doing things fast. So instead, I'm going to select our rectangle tool, make sure that I select these 2 rows right here, hit Command C, hit Command V, and we actually have an issue here. What happened? Well, this is something that can really catch you. What did I just copy? Well, I copied, it looks like, some green, and some sand pieces. Well, look what I have selected right here. I have our island selected. This isn't really where we should be drawing our paths because we have a completely separate layer for that. Our island should just consist of the green and the edges around it. So what I want to do is, one, I'll turn off our paths to see what I actually drew on our island right here. Now I don't want these path pieces on our island, so I'm going to actually erase them with the eraser. So 1, 2, 3, 4. And now you'll see while we just erased our island, we actually want that green in there too. So what I could do is, I could go ahead, select our rectangle tool, and just select another piece right here that's already on our island. Hit Command C to copy that exact piece. And then I can use our fill bucket on this area that's exposed right here, but you'll see I still have this one piece selected. If I want to go ahead and deselect this, I can hit Command Shift A. That should be Control Shift A for you Windows users, and now I can go ahead and select something else that I want to fill in with what we just copied. So if I want to go ahead and fill this in, what I can do is, with this rectangle tool, select a square, hit Command C, then hit Command V, and now you'll see I have that exact piece selected down here. You can just begin brushing that in because it automatically selects the brush tool. And now our island is back to normal. But let's go back to our paths. So I'll go ahead and show our paths again by clicking the eye tool. And now you'll see I want to make sure I have paths selected this time. So I can begin filling in this bottom portion right here. So what's a quick way to do this? I can go ahead and hit R. It's going to select this select tool right there. Select these bottom 4. Hit Command C. Hit Command V. Paste it on in. Looking a lot better, but remember, we wanted to expand this one row down, which is the whole point of why we expanded our island downwards. So let's just go ahead and select our rectangle tool with R, or by clicking this right here, hit Command C, hit Command V, paste that on in, and now we have one more row added to our path, looking pretty good, but still could use some detailed touch-ups. What could we do over here on the left-hand side? Well, we could add some sand detail over here. We always need to make sure we're being really precise with these detailed pieces. So we know sand is on the right here. I can go ahead and add that in on the left side. And if I go one over to the right, we have some edge pieces which we could use for the corners as well if we want to be super precise. So this one edge piece has sand on the top right hand corner, as you can see right there. I can select that, paste it on in, and just make sure that I'm filling in the correct spots in which I want a realistic path. I'll do the same thing on the right side, make sure I have some sand connecting pieces over here, and that I fill in all of the corners. And I think the very last thing I'd want to do is make sure that this is all randomized because we can see a pattern that's pretty obvious and it just throws off the look of our game. So we want to go ahead and randomize that whole path. So what I would do here is select a rectangle tool, select everything that I want randomized. I want to start with a clean slate. So I'm going to go ahead and delete these. And then I want to select the tiles I want in this location right here. So I'll select these 3. And then I'm going to use the fill bucket with our randomization dice over here selected. So now when I go ahead and I try filling in all this area in between all these other guys that I just drew, you'll see when I begin moving my mouse over a different tile, we get a different randomization effect. So we can keep on going until we get one that we really like. And I think I'm going to go with this one right here. I think that's good enough for me. And you can go ahead and tailor this as you need to if you want to get rid of any jagged circles or anything that might be off the edge. But that looks really good for our path. I really love how this is looking. So that's how you're going to want to start creating paths for your game. And you can do the same thing with these little dark green patches over here. If you notice within the preview, I use these little dark green patches as an area in which our player needs to walk through in order to create some sort of battle. So if I wanted to create some sort of battle patch, I could just go ahead and select this grid of squares right here. And then I want to make sure I don't have the fill tool selected because it's just going to go ahead and throw things way off. I'm selecting pretty much everything else in our map that isn't a path. If we were to fill that in, well, now we have a huge land map. We don't want that. We want an island. So we want to make sure we have our brush selected. And if you ever have multiple things over here selected with your brush selected and it's only showing one tile, that just means you have your randomization dice turned on. We want to turn those off. And now you can see we can draw in a new battle patch. So I'm not going to call this a path. I'm actually going to create a new layer called battle patch, because this is where I want to activate some actual code in the game to make sure that our player is able to go into some sort of battle. So now I just need a good area to put this. And honestly, I think I'm just going to put this right behind our plateau. It shouldn't matter too much, but you'll see that's how you want to add some sort of battle patch. If you're not happy with how that looks behind the plateau, well, you can go ahead and just draw it somewhere else, such as behind the house. It shouldn't really matter. This is just for example purposes to show you how to begin drawing paths, battle patches, and details. So that is how we're going to add a battle patch And then finally, we want to begin adding in details. So these are going to be our details. They're going to be flowers, additional trees, fences, and so forth. So let me show you how to begin adding in randomized details. You might already know a little bit using the randomization tool. So let's say we want to begin adding grass onto our map. What am I going to do? First thing, as always, I'm going to go ahead and create a new layer. I'm going to go ahead and call this grass and flowers. So I'm going to go ahead and combine these two together. And then I know I want to begin creating grass on our map. So I'll select all these grass icons, make sure I have our brush selected. Obviously, I don't want these drawn out in this grid-like format, so I'll select our randomization dice. And then I can begin clicking in random spots with all this selected to get randomized grass from this grid right here. And I can just begin clicking all these different locations to create some really cool details on top of our map. And if you want to see how this looks as you go, you can just hit Command G, get rid of your grid, and now you can go ahead and create all these cool pieces of grass within it. So next up, let's do our flowers. If we want to go ahead and do our flowers next, we just select the flowers, and then we can begin clicking. And it's going to go ahead and randomize different flowers for us in which we can begin placing on our map. Really, really cool stuff using that randomization dice and this tile set that was given to us. If you want to begin adding fences, well, what we could do is we could select all the fence right here. And we always want to make sure we turn this randomization dice off when we select multiple things, but now you see I have our fence selected. We do not want to draw this on grass and flowers, otherwise it's going to overwrite the tiles we just put on. So as always, we'll create a new tile layer. Say this is going to be our fence layer. We can begin placing this in the right location. So I think it looks pretty good right here. We could even place one right next to that if we want. That looks pretty good, but what if we want this fence connected? How would we do that? Well, what I would do is I'd select a rectangle tool and start from the middle of this side piece right there. And I want to go all the way towards the end of our fence. So I'll go ahead and select that, hit Command C, hit Command V, and now you'll see since I started from the middle of that left-hand piece, if I move over to the side and begin clicking, it begins extending our fence perfectly because the artist of all these sprites was so good that they were able to make sure that everything combines perfectly using a tile editor. It's pretty much all we need to know for fences within our game. So the very last detail I want to show you how to add is going to be this dock right here. If I want to go ahead and add this dock in, well, obviously I need to connect it to our water and also our island. So it kind of makes sense, as always, to create a new tile layer. This is going to be our dock. And then I can simply select our dock right here. And then just find the right spot to overlay this on. So if I want to go ahead and make sure that at the end of our path, we have a dock in which we can get on a boat, and just go ahead and make sure that this dock is above our island layer. Otherwise, we're going to see these little island pieces on the side. So it's above our island layer, and just click, it's drawn on top. Now we have a dock for our game. That's really all there is to it. So simple enough, but that pretty much shows you how to add all these details you see within this tile set and how to arrange them in a smart format in which you can create really, really detailed designs for your island. So before we move on, I highly encourage you to create your own island using all the techniques we just went over. But I do want to forewarn you, in the end, I will be using an island that I created myself, and I used all the same techniques that we saw right here. But I'm using this little island simply to show you all the basics in which we need to know to begin creating maps using the tiled editor. So I'm going to continue using this island we have right here to show you more things like collision, but in the end I'm going to show you the end piece that I created, and you'll be able to download it yourself if you just want to use that for your game or for the rest of your tutorial. So next up, if I go back to to-dos, I can check off landscape details, and now we're going to go on to collisions and map boundaries. So what do I even mean by collisions and map boundaries in the first place? Well, eventually, when our player is placed on the screen, we're going to need locations in which our player cannot go. For instance, our player probably shouldn't be able to walk anywhere on our house. They probably shouldn't be able to walk anywhere on the sides of our island, probably not in the water either. So what we're going to do is we're going to create these little tiled squares, and they're going to be placed in the exact locations right on top of each other so that we can run rectangular collision detection between these squares and, let's say, our player, if they were somewhere on our map. So we're going to detect whether or not our player is touching any of these squares over here, and if they are about to touch, we're going to stop our player's movement altogether. They're not going to be able to go off into the ocean or some other location, such as into the trees. So all the locations in which our player should not go, including the trees, we're going to have these little squares drawn out in all the exact spots in which our player cannot travel. And eventually these are just going to fill up the whole boundaries of our map and every location in which our player cannot go, so we create the correct effect of collision detection, an actual realism within our game. So this should be the exact collision in which we're going to create, but using collision blocks. So how do we actually import or create collision blocks into our game in the first place? Well, some tile sets will actually come with these collision blocks, and you'll see right here we don't actually have a collision block. You're probably wondering, well, what do I even mean by collision block? What does it look like? What kind of tile is it? Well, it's simply just going to be a red block. That's pretty standard to use a red block for all the collisions in which we're going to be placing on our map. So I don't have a red block within this tile set, so I made my own. And you'll see this is going to be available within the Google Drive link. It's just a small red square called collision.png. I want to make sure that I import this in to our project right here. So the way I'm familiar with doing this is going to new, file, and then new tile set. So we're going to create a new tile set for that one little square. There's probably a better way to do this, but this is one that I've always done. So the name for this is just going to be collision. This is going to be based on the tile set image, one image we're going to use, which is exported as 12 by 12. Now I just need to go ahead and find the source for this. So I'll hit browse. And I know this is within, not my game assets. This is actually going to be within the Google Drive link, which you can go ahead and drag into my game assets if you'd like. But this is going to be within the Google Drive link of Pokemon assets. And then inside of tiled, there's going to be collision.png. This is what we want to select for our new tile set. So go ahead and open that on up. That's all we need to do here. Just hit save as. And now I can go ahead and save this within my game assets. I'll go ahead and call this collision tile set, like so, and then I'll hit save, and there is our one tile set. But now, if we go ahead back to our Pokemon game map right here, you're going to see, since we just imported that tile set, now it's available within our project, we can click this tab right here. Now we can select this one tile, and this is going to act as our collision tile. So let's go ahead and select it and begin drawing out our collisions. So I'm just going to go ahead and create a new tile layer and call this collisions. And I can go ahead and move this up above all of our other layers. Shouldn't really matter too much, honestly, but let's go ahead and move it to the top so we can see it on top of pretty much everything. And now we just need to determine where should our player go and where should they not go. Let's start easy. Let's start with the left side of our island. I know I don't want our player to be able to move past these squares over here. So I'll turn back on our grid, and then I'll just simply begin drawing on top of these left squares the boundaries in which our player should not be able to travel. So it's going to be all along this left side. Where else should our player not travel? Well, we know they shouldn't be able to go off the front of our island. So I'm going to cover in this square, and I'm just going to move diagonally as needed, because you don't need to fill in these corner squares if your player can't move down or to the left right here, because they're always going to get caught by these two connecting ones. So we can just go ahead and draw out, by connecting corners of these squares, all the boundaries in which our player should not be able to travel on the bottom side of our map. So that's pretty much all we need to get started. Our player can move all around here, but we need to make sure that we continue drawing these boundaries. So I want you to go ahead, pause the video, and try this on your own for the right side of the map. Just don't forget while you're over here that you need to take into account the dock and potentially the boat. So go ahead and give that a go, and then continue the video when you're ready. So in order to add these collisions on the right side of our island, I'm just going to start off down here like normal, and then I kind of need to determine, well, should our player be able to stand on this one little dock piece right here? I think that is okay. Gives our player a little more room to move, so I'm going to go ahead and draw our collisions right beneath this instead. And then should our player be able to stand on this far piece over here? I think that is okay as well. So what I can do is connect to these corners, and then I'm okay with the player standing on the top of the dock too. At least I think I am. We'll find out as we actually begin inserting this into our game. But let's just go ahead and draw that around our dock like so. And I'm simply just going to drag up for the top of our island. So now it's beginning to get a little tricky because we have our trees right here. Obviously, we don't want our player going off the top of the island, but we don't actually need to draw these squares because these squares are actually going to be drawn in front of that island piece. There's no point of drawing these collision blocks right here because these will be programmatically moved within our game along with our map. So the less collision blocks we have, the better for our game performance. So we don't want to add collision blocks back here in which we're not actually going to use them for collision. We actually want to begin drawing in a diagonal motion in which our player should not move. So our player should be able to go right here, but not into the trees really. So I'm going to go ahead and draw blocks in front of all the stumps on the trees. And now we have a much more optimized block system because we're not adding these additional blocks up here that our player would never actually reach in the first place. So that is going to be the boundary for our island, but we also have boundaries for things such as our fence. Should our player be able to walk directly over a fence? I definitely don't think so. So I'm going to go ahead and add boundaries in front of the bottom portion of the fence. Our player should be able to walk on the path right here, and so it's important that we keep these little top pieces of fence intact without any boundaries above it. So we're going to leave those. We're going to take care of those on the next step, and you'll see exactly what I mean by that. But this is good for the time being. And if this is frustrating you, as in you can't really see what's behind some of these boundaries, we can use this opacity bar right here, select our layer of collisions, start dragging this down so we can see exactly what is behind these. I like having it about 30-25%, so I can still see the artwork behind the squares while still seeing a good amount of redness. So that takes care of the fence, but we still need to do our house as well. So I'm just going to go ahead and outline the edges of our house, but once I get to the top, and if this is hard to see, we can always increase that opacity layer. Once I get to the top, we need to really think, is it okay if our player walks right here, right here, right here, and right here, while on top of the house? No, obviously not. Our player shouldn't be able to walk from the ground to on top of the house. But behind the house, yes, they definitely should be able to walk. The house is just going to cover our player. So what I want to do is not place our collision block right here, because these are going to stop our player's movement altogether. Instead, I want to go ahead and place our collision block right below the house so that our player can actually walk beneath this section right here. So I'll go ahead, make sure that I take that into account, but still draw a little square around our house in the area in which our player should not be able to move. So finally, we just need to take care of our plane. So we'll just start drawing around the edges, like so. We know our player shouldn't be able to go off the plane in any direction. So unfortunately, our player won't be able to go up the sides directly right here and right here. But if we wanted them to be able to do that, we could go ahead and expand our island to the right, and then we could create some pathway in which they can move up. But really, based on the way this tile set is designed currently, well, we can't really go up on the side. But now, our player can walk up this tile and give off the illusion as if they are on top of the platform, and we're going to stop as soon as we hit the top, the left, or the right of this plateau. And that's pretty much all we need to do for our collision blocks. So the process is, first, we would go ahead and export our whole map right here as one singular image, because it's going to be a lot more performant if we export this all as one image rather than just multiple layers on top of each other. We're only doing the layering so that we can edit things much easier if we were to come back to this at a later point in time. Two, we're going to go ahead and export all of our collisions. So this is going to be exported as a data file, and based off of that data file, like I showed you for Pac-Man, this is going to generate an array for us, in which we can generate a bunch of blocks, place them into our game programmatically, and then monitor collision detection between our player and every single block we have right here. We're going to be moving these blocks as we begin moving our map and our player. But the last thing we need to do in regards to our map is drawing the foreground layers. So we can go ahead and check off collisions and map boundaries, but now we need to draw these foreground layers. What do I mean by that? Well, the top of the house, objects in which our player should be able to travel behind, we need to make sure that we create one singular layer, which is going to contain just the top pieces of where our player should be able to travel. So to show you what I mean by this, I'm going to create a new tile layer. This is going to be called Foreground Objects, and I'm just going to group all of these together in one layer, no matter what they are. So now what I can begin doing is I can begin selecting pieces that I want placed on top of each other, which our player should be able to travel behind. So one instance is our house right here. If I want to go ahead and copy these squares, which the top of our house is in, I need to make sure first I select our house layer, select our rectangle tool, and then select all the tiles associated with that top portion of the house. I'll hit Command C, go back to Foreground Objects, hit Command V, and now we have just the top portion of our house. And what we're going to do is we're actually going to draw this directly on top of the same place we got it from. So I'm just going to click, and now you'll see if I turn off our house layer, well, that part is gone, but we still have this top portion. So what this means is now we can go ahead and draw these foreground objects on top of our player, because when we import these into our game, we're going to be drawing these in layers on top of each other. and our player object is going to be placed behind this layer that contains all of our foreground objects. It's going to make a lot more sense as we actually get our player into this game and begin programming everything, but for the time being, just go ahead and bear with me on this a little bit. But you're going to want to go ahead and do that for the house and any other objects in which your player should be able to travel behind. So you might have some trees in which your player should travel behind. You'll probably need to go ahead and grab the top portion of those trees, but you'll see right here, for a small little map, we have this fence right here. And we know we want our player to be drawn behind these little tops of the fence posts. So in order to make sure we draw these on the foreground layer, we're going to want to select a rectangle tool, select those pieces on the top, go ahead and find our fence, which is going to be right here, hit Command C, go with the foreground objects, hit Command V, and then we can just simply click. And if we remove our fence right here, you'll see now we only have the tops of those fence on the foreground objects layer. That is perfect. We can go ahead and turn our fence back on. And if we turn our house back on, I think we are good to go with our map right here. So this is how we go ahead and lay out a full map using the tiled map editor. You want to make sure that you draw all these within the correct layers because it's going to be easier for editing. But in the end, it's very important to understand there are three things we want to export. It's going to be our base layer, which is just a giant image. It's going to be our collisions, which is going to be all these little blocks right here. We're going to export those as data objects. And then finally, we're going to export one more large image, which is just going to contain all the foreground objects in which our player should be able to travel behind. Those are the three necessary things we need in order to create some sort of top-down Pokemon style game. So that brings us to checking off foreground layers. So now we can move on to exporting layers for project import. Now, as I mentioned, I do have a bigger version of this map which I would like to use because it allows for more player movement. The only reason I didn't go ahead and create it right here is simply because it would have taken way too long for this tutorial. It took me actually about like 2 to 3 hours to make on my own time. So to proceed with the tutorial, what you can do here is you can use what we have right here. You can use your own map with all the collisions in place, or you can go ahead and download the map I'm about to import to continue on with this. The map I'm about to import is exactly what we see right here, just on a larger scale. So don't get worried if you see a lot of stuff that you might have missed out on. Really, there's not much different in regards to technique, and it might even give you some ideas in regards to how you can style your island. So if you would like to use the map that I created, here's how we're going to do it. Within the Google Drive link, I want to make sure that you have the Pokemon assets, and inside of the tiled folder, there's going to be a TMX file called Plateau. That is going to be the name of the area in which we're going to be starting out in, and all we have to do here, once you download it, is double click, and you're going to see this opens on up within tiled. Now here you're going to want to make sure that next to Plateau you have the collision tile set, and the Pokemon style game tile set as well. You could even rename this to something better. Let's go ahead and do that. Let's just go ahead and call this Pokemon style. Make sure we're using camel casing here, and then call this tile set. That's a much better name compared to what we had prior, so I'm going to change that. Then I just need to make sure I save, and everything should be referenced correctly. So once you have this open, this is what the map should look like. You'll see not too much different here, just a lot larger map, but this uses all the same techniques that we used building up that smaller island that we just did. So how do we go ahead and export this large map? Well, we wanted to go ahead and export the island portion separate from the collisions and separate from the foreground objects. So you'll see up here, I have those foreground objects, I have the battle zones, which we'll cover later, and I have the collisions. I'm going to turn these three off, and this is what I want to begin exporting for our game. So in order to export just this, what I can do is I can go to File, and then Export as Image, and then I want to make sure that I only have this one checkbox right here checked. Only include visible layers. So we turned off foreground objects, battle zones, and collisions. Those are not going to be included within this final image right here. So I'm going to save this as peloton.png. I can also browse the location I want to save this at. This is just going to go directly within my game assets. So I'll go ahead and hit save. But you'll see by default tiled as a .bmp file to this. I don't want that. I just want this as a PNG. So just make sure that right here you type .png, or else it'll be saved as a BMP. And then I want to make sure that using current zoom level is checked off. We're going to use this later on, but right now I just want to show you why we're going to use it. So we're going to export this as is. I'm going to hit export. And that's going to go ahead and send that on over to Finder. So now you see within Finder, I have our peloton.png, and if I go ahead and full screen this, this is what our map looks like. So looking really, really cool. All we're going to do is we're going to import this into our game, place our player right about here or so, and then we're going to actually move the map, not our player, but it's going to give off the illusion as if our player is moving through this whole little island right here. So if we go over to To-Do, we exported our layers for project import. So that is going to be the end of the very first module, map creation with the tiled map editor. We learned all that stuff such as where to find assets, how to download tiled, how to actually layer all of your assets together, use randomization, and add those collision barriers in place so we create a map that's going to set us up for success when we actually begin programming our game. So up next, we're going directly into that. We're going to go ahead and program the player and map development for our Pokemon styled game. So let's go ahead and get our project set up. How would I actually go about creating the file structure for our game? Well, the first thing I would do is open up Finder, and then I want to go inside of a directory I am comfortable with creating web projects in. So you'll see over here, I have a folder called web. You can put this wherever you'd like, documents, downloads, it really doesn't matter, but this is where I store all my web projects. And inside of here, I want to create a new folder to represent a new project. What is that project going to be called? I'm going to hit Command-Shift-N since I'm on Mac. I believe for Windows, it should be Control-Shift-N, but that is going to create an untitled folder for me. And now I can double click it and I can create a new name for this. I'm going to call this Pokemon-Game. Simple enough. And that is going to be where I'm storing all my project files. What project files do I need to add into here? Well, I'm going to open up a new Finder window. And in downloads, I know I have some assets that I want to use within this game, specifically within my game assets. What did we just export? Well, we just exported pelletown.png. This is going to be our game map. So I want to drag this on over into our Pokemon game. But before I do that, I might have multiple images within my game, so it makes sense to be organized and create a new folder inside of this called either IMG or images. It doesn't really matter. I'm just going to go with IMG because it's a little shorter and I know what IMG stands for. So I'm going to go with that. And then I just need to make sure that I drag in pelletown.png inside of that folder. And now I can begin using this within my game. So if I want to go ahead and open this up within a text editor, I can simply grab this folder right here, go on down, and hold this on top of Sublime Text. Now, this only works for Mac, unfortunately. I have tried for Windows, so if you want to go ahead and open this up within Windows, just go to File, and then Open, and then select the folder in which your project is located, and you'll be up to date to where I am right now. So we're within our project, Pokemon-Game, but now we need some sort of an index.html file to actually be read by the browser. So in order to do this, I'm just going to go to File, New File, and then I'm going to hit Command-S to save this as no other than index.html. This is going to be the main HTML file which we run our project from. So I'm going to go ahead and make sure I'm saving this within our web directory and within Pokemon-Game, and this isn't going to go in anything other than Pokemon-Game. It's going to be the root of our project. So I'll hit save, and now we have an index.html file. So what else do we need? Well, we need a JavaScript file, but the very first thing we need within an index.html file is going to be a canvas element. It looks just like this because this is what our game is going to be rendered on top of. So now we just want to make sure that this is being rendered out onto our screen. So what we can do is I can right click in our little project folder over here, and then I want to hit reveal in Finder. This is just going to open up our Finder directory. Looks exactly like we had it open earlier. So I'm going to go ahead and double click index.html. And this is what our game looks like currently. So if I want to see that our canvas element that we just put within index.html opens up over here, I can inspect by right-clicking and hitting inspect right here at the bottom within Chrome. And then I can look around for a canvas element. I don't see anything when I hover over, so I'm going to go ahead and look inside of our body tag by double clicking right here, and you'll see our canvas element is right there. We have it rendered out onto the screen. And if you're wondering where these tags right here are coming from, Chrome places them within our HTML file by default. A really nice handy thing that Chrome does for us if we just want to go ahead and keep our index.html as clean as possible to start. So we'll keep it like this for now and just include a canvas element. But now we need to write some programmatic code. One, to make sure that our canvas element is resized correctly so it can actually fit a full game inside of it. And two, to make sure we can actually render out our image onto our game using Canvas. So in order to do that, we want to create one more file. I'll go to File, New File, and I'm going to hit Command-S. And then I want to save this as index.js. It's going to be the main location in which we run all of our programmatic code. So if I save with that, now we have an index.js file. I can console log out some text, and this will be a string of hello world, so classic. But now, if I go ahead and refresh in our browser over here, by hitting Command R and going over to our console tab, not going to see that text being logged out within index.js. So what I want to do is make sure that I create a script tag that references the file that we want read within JavaScript. So the source is going to be index.js. It's going to be right here. Now if I refresh, you're going to see that console log be outputted. So now our JavaScript file is connected to our index.html file. Next up, let's go ahead and get this canvas resized to be something a little bigger. So in order to select an element from our HTML and put it within JavaScript, we want to go ahead and call the document object. And this document object has a method called query selector. Basically inside is we can just reference any element within our HTML over here, and it's going to grab it and put it inside of a JavaScript object. So what is the element we want to reference? It's going to be our canvas element. And now this is going to grab the canvas element, but we want to put it inside of a constant called canvas. Let's set that equal to that. So now when I save and I console log out our canvas object right here and refresh, go to our console tab, you're going to see we are logging out our canvas element. Perfect. So now that we have this selected, we can go ahead and resize it directly within our JavaScript. Some people like doing this within CSS. I do not. I always like doing it within JavaScript because this is where I'm always working with all my main canvas details. So I'm going to go ahead and continue doing this right here. And if I want to go ahead and affect our canvas width, I can select our canvas and then just reference its width property and say, what do I want to set this equal to? Well, typically to make sure a game fits on any desktop screen, it's a good practice to go ahead and say our canvas width should be 1024 pixels, that our canvas height should be 576, and this is going to give us a perfect 16:9 aspect ratio. Basically, it looks like we're using either a computer monitor or a TV screen, but it's going to make sure that it fits across all desktop sizes with this width and height. So now if I go ahead and save and refresh that, now we have a canvas width and a height associated with our element. And if I go ahead and inspect our canvas, you'll see, I need to even full screen this, that our canvas is taking up this much width. If I go ahead and push our console to the side, taking up that much height. So we might even want to go ahead and close out of our console to see where our canvas is. But once we do that, well, the canvas is the same color as our background of our index.html file. So we can begin styling that with some CSS and some style tags within index.html. So if I want to go ahead and start using CSS within index.html, I can simply create a style tag and begin writing CSS inside of this. So what is some basic CSS? Well, let's say I want to select our body tag. I can go ahead and reference our body, create some opening and closing curly brackets, and then I can reference a background-color property and set that equal to black. This is the most basic CSS we can write. So if I save that and refresh, now you'll see our background is going to be black for our body. Now, if you'd like to learn a little bit more about CSS, I do have a masterclass on that. You can check it out right here. But otherwise, let's go ahead and continue onwards with this tutorial. So now we have a black background, but our canvas is still the same color. How do we change the color of our canvas? Well, we can do this directly within JavaScript, and this is how we're going to be doing it once we create an animation loop, so it kind of makes sense to do this now anyways. So what I need to do first is reference our canvas context, and this is just going to be one giant object that gives us the whole API for canvas. It's going to allow us to do things such as draw rectangles, arcs, images, whatever we need to create our game. This canvas context is what's going to allow us to do it. So to grab this canvas context, we need to create a constant called context, but I actually like calling this something really short because I use it so much throughout my games that I really don't like referencing something so long like context, and I know I'm always going to call this something small. I'm consistent with it, so I just call this C instead. I'm going to set C, that stands for context, equal to our canvas dot get context method. And now what kind of context do we want to get? Do we want to get a 2D context or a 3D context? Basically, do we want to get a 2D API or a 3D API? Well, we want the 2D version. So I'm just going to type 2D into here. And now we can replace our console log of canvas with console log C. Open up our console, refresh. Now you'll see we have a giant object which is going to be responsible for drawing out everything we need for our game. This is the canvas context right here. So how do we actually draw something out with this canvas context? Well, the most simple thing we can draw is going to be rectangle, and we're just going to go ahead and do this so we can differentiate our canvas from our background of our HTML element. So I'm going to go ahead and draw out a rectangle with C.fillRect, and then I need to specify 4 arguments for this method. The first one's going to be X position. So if I want this on the very top left-hand corner of our canvas, I'll go ahead and say X should be equal to 0. And then our Y should also be equal to 0. That's going to place this in the top left-hand corner. And then how wide should this rectangle be? Well, I want this the full width of our rectangle. So I'll go ahead and reference our canvas width, which we just set right here. And then how tall do we want this to be? Well, no other than our canvas dot height. So if we do that, save and refresh, not going to see anything because fill rect by default is going to be a black color. Not very intuitive when our background is black over here, and especially since we just changed it to that. So in order to change the color of this rectangle, we can set a c.fillStyle to a color like white. We save and refresh, and now you're going to see this is the full width and height of our canvas. Now something you might notice is we have some borders along the edges of our canvas on the top and on the left. There's a little bit of black space there. I'm actually going to keep that as is just so we can see exactly what is our HTML element and what is our canvas element. But that border is coming from our body tag. By default, it has margin laid on top of it because browsers said, hey, by default, body tag should have around 8 pixels worth of margin on the sides. I don't know why they did that, but that is what they did by default. So it's there, and we can always override it by setting our margin equal to 0, and that gets rid of it, but we don't want to do that, so we're not going to affect that within our code. That's just some temporary browser code, by the way. We're just going to leave this as is, but now we are actually completely set up to begin and continue creating the rest of our game. So with player and map development, we can go ahead and check off project setup. Alright, so now it is time to import and render our map onto our actual canvas game. So if we go back to our code, you'll see right here, we just put Plateau inside of our image folder, and there it is. This is what our image looks like, but we want to make sure that we can get this over to our actual game over here, which is just a white background currently. So how do we actually get this rendered out on the screen? Well, we're going to want to head on over to Sublime Text, specifically within index.js, and we're going to want to use a canvas context method. So remember, the C right here refers to our canvas context. We're just referring to it as C because it is short, it is very easy to use. Like I said, we're going to be using this all throughout our game. So in this one case, it makes sense to call it something shorter rather than be more descriptive, although it kind of is up to you in the end which you want to choose. Nevertheless, how do we draw an image? So we're going to call c.draw image like so. So this method right here is how we draw something onto the screen. Now what is the first argument of c.drawImage? Well, it's going to be an HTML image object, which means we can't just put a source in here. So if we wanted to reference Peloton, this image right here, you might be thinking, well, can't we just put a source in here with a string and then go into our image folder with ./image and then reference pellet space town.png. Well, this would be the smart way to do things. Maybe DrawImage could handle this for us, but unfortunately it does not. We can't just pass a string through like this. We actually have to pass through an HTML image object. And we can create that within our JavaScript, thankfully, so we don't have to go back over to index.html to do this. So how do we actually create this HTML image object? Well, we're going to go ahead and create a const, call that image, and this is going to be equal to a new image. So new image right here comes from the native JavaScript API. Thankfully, they provide this for us. So when we actually create this, well, we're just creating an HTML image, but we're putting it inside of a JavaScript const called image. So now that we have this image right here, well, you might be thinking to yourself, well, can't we just take this string and put it into our new image like so, and then that's going to give us everything we need to draw out this image that we're trying to get on our screen. Yes, that would be the smart way to do things, but unfortunately the API does not allow you to put the string directly within the image constructor, so we can't do things like this. We have to reference our const of image and then say what its source is equal to. So its source is equal to this right here. We go inside of our image folder, and then we reference Peloton PNG. So this is how we create an HTML image within JavaScript, and I can go ahead and console log this image object out, and I'm going to comment out c.drawImage just to show you what this looks like. We go back to Chrome, we can right click, hit inspect, going to open up our console. So if we click this console tab and then refresh, now you're going to see we have an HTML image object. So this is something that you would place within your HTML, but thankfully we don't really need to do that. We can just create this directly within JavaScript and then reference this as needed to render onto our canvas. So now that we have this available to us within c.drawImage, remember we can't reference a string like we are right now. We just want to get rid of that and then reference image, which remember is just this HTML element right here. So the drawImage method requires 3 arguments. The first one is always going to be the HTML image, which we have, and the second is going to be the X position in which we want this image drawn on. So if we just want this drawn from the top left corner of our screen, we want to say for our X coordinate, we're going to put a 0 in right here. And then the third argument is going to be our Y coordinate, so we also want to say that this is equal to 0 as well. And once we have this in place, if we save, go back to Chrome, and refresh, well, we don't have any errors, but you'll see our image is not being drawn. Why is that? Well, let's analyze our code. You'll see right here we are drawing an image as soon as we load this index.js file. And this index.js file is being loaded right here. So all this code is just being called immediately when we go ahead and load index.html directly within the browser. But the thing is, this image right here, it might be something like 100 to 200 kilobytes large. It takes a little more time for this to load than rather just load instantly as soon as we call this code right here. So what's happening is we're trying to draw out our image before it's actually loaded on the screen. We're calling this one statement right here before we actually load it in pellettown.png, and that is an issue because if this image isn't loaded when we call this method, well, it's just not going to show on the screen, especially if we don't have an animation loop running. So the way we can fix this is this image object comes with another method, and the method is going to be called onLoad. So it looks like this, image.onLoad. And this is going to be equal to an arrow function, or just a regular function, does not matter. But basically what this says is when this image right here actually loads inside of this image object, well, we are going to fire whatever code is inside of this arrow function. So it makes sense to only call c.drawImage whenever our image actually loads. So we'll go ahead and paste that on in there. So now when our image loads, we're going to call c.drawImage. So now if we save and refresh and go back to our code, you'll see now our image is being drawn out on the screen because we waited for our image to load before we actually called that method. So looking at this, yes, we have our image imported into our game, but one of the big issues is, well, this is just way too small. Imagine if we drew a player onto here, they'd probably be the size of this door. It'd be very hard to see what our player is actually doing. Maybe this is actually the kind of game we want, where we're super far zoomed out. But in our case, for a Pokemon-styled game, that is not what we want. We want to zoom in on this. So we could zoom in on our image in a few ways. One, we could go ahead and set the scale of the c.drawImage function, but I've always found it easier to export the image at the exact size we want it at. That way we don't have any issues with our image's positioning, which we're going to be editing later on. So in order to export our image at the actual size we want it at, we're going to go back on over to our tiled map editor. And once we're over here, what we want to do is on the bottom right corner of tiled, you're going to see this percentage right here. What this percentage determines is how far zoomed in or zoomed out we are from our map. So right now, if we're looking at this, we are 136% zoomed in. And what I want to do is I actually want to zoom in on my map, and here I'm using a trackpad, so I'm just expanding 2 fingers to zoom in. If you have a mouse, you can use a scroll wheel to zoom in, but I'm just going to keep zooming in until I find something that I think I want to play my game at. So this is a pretty close representation of how zoomed in our image will be when we're playing our game, and I just want to keep zooming in or zooming out until I find something I'm happy with. So you'll see we're around 382. Why not go ahead and just make this a straight interval at 400? I think when we're 400% zoomed in, I think this is what I want to export our image at. This looks great for starting off our game. So how do I export our image at 400% zoomed in? Well, once I actually set this to 400%, I can go on over to File, and then Export as Image. I'm going to want to click that, similar to like we did before. And I want to make sure this time that I click this one option right here, Use Current Zoom Level. So this option right here, Use Current Zoom Level, refers to this percentage right down there. So we want to make sure that that is completely checked off, and then we just need to determine where we actually want to save this image. So I'm going to go ahead and go inside of my web folder where I actually created this project. It's going to be right here for me. Here is our Pokemon game, and then I want to go inside of our image folder. And basically what I want to do is overwrite this Pellettown image right here. You'll see if I try clicking on it though, it's not automatically giving me that extension. So I want to make sure that I'm saving this as pellet space town.png within my project's image folder. And once I do that, hit save. Now I can go ahead and hit replace, because I definitely want to replace that smaller version of the image. And once I make sure that I have this checked to use current zoom level, I can export it, make sure that I'm replacing the current image, hit yes. And now if I go back to Chrome and I refresh, you're going to see that it's much more zoomed in. That is looking a lot better than I had previously, but obviously this just isn't positioned correctly. We want to make sure that our player starts off where that house is, not the top left corner of our image. So all we're going to be doing now is moving our image start location so that the house is the center focal point. So the easiest way to offset our image is to deal with the c.drawImage method right here. Remember, the second and third arguments determine our x and y position of this actual image. So if we wanted to offset our image, we could set our x equal to some sort of negative value, because let's say we want to offset it by negative 300 pixels. All that means is we're going to take this image right here and move it 300 pixels to the left. So what we can do is say, for our x-coordinate, when we draw out this image, we want to push it over 300 pixels to the left. We probably want to go ahead and push this upwards as well, so this third argument is going to be our y-coordinate. We can go ahead and say our y-coordinate is also equal to negative 300. That'll go ahead and draw it 300 pixels upwards. And now when we save and refresh, you'll see we are getting closer to where that house is in the middle. And now we just kind of want to eye things until we can get this house directly within the middle of our screen. So let's go ahead and change our x-coordinate to be negative 600. We'll go ahead and double that. Save and refresh, getting a little closer. Let's change it to 700, save and refresh. That looks near the middle of the screen. We'll keep it at that for now, but obviously we want to move this upwards as well. So we go on back to our code and say we want to push this up by 500 pixels on the y-axis. Looking a lot better. Let's go ahead and make this 550, and then 750 for our x-coordinate. So I really like how this looks for the start of our game. You can fine tune this as needed. I'll go ahead and keep this as is for now. But technically this is all we need to do in order to export our image and import it into our game at the correct size. So to briefly recap, if you want to go ahead and export your image at a different size from tiled, you just need to go on over there and make sure that you select the correct zoom amount right here on the bottom right. Go ahead and export this at that current zoom level, import it into your game, creating a new image, and then using the c.drawImage function, make sure you have on load and you should be good to go. But that is what's going to allow us to check off over on to do, import and render our map. So now let's go ahead and create a player so that we can get moving around our world. So how would we actually create a player? Well, within our game, it makes sense to import a different image for our player because our player and the background right here are going to be moving independent from one another. So we need to make sure that we just import something separate from our background image. So within our Finder, we have our My Game Assets folder. And this, remember, is where we downloaded our sprite sheets right here, which represent how our character looks if they were to be moving in a certain direction. Here we have our character moving up, here we have our character moving to the left, here down, and here to the right. So to import a character, we're going to be using one of these images right here. Now, why do these images show 4 versions of our player? Well, this is what we call a sprite sheet. It's basically just one image that shows different frames of an animation. So basically what we're going to do is we're going to import one of these images into our game, and then we're only going to load one section of this at a time. So we'll only load this very first image right here. And then eventually, as we go on to later lessons, what we're going to do is over time, we're going to change which of these images is being rendered. So although we'll go ahead and load this very first one for the first frame, as time goes on, we're going to load this one, and then we're going to load this one, and then finally we're going to load this one. And then when we load all of these in sequence together over time, we're going to create the illusion of a player that's actually animated and walking through our scene. We're going to be covering that later on within this tutorial, but the very first thing we want to do is actually just get one section of this image rendered out onto our screen. So what we could do is we could go ahead and copy and paste these 4 sprite sheets right here into our game. But one issue I have with these sprite sheets is they are placed in a square format, which just means we would have to go from this one image to this one, and then we'd have to go down a row and over to the right to another one. I don't really like transitioning between different images within a sprite sheet using that square format, because it's a lot easier to create this animation if these sprites were placed right next to each other from left to right. So if we really wanted to, we could go ahead and use these 4 sprite sheets right here and drag them directly into our project. But since they use that square format, we're not going to be using these ones. We're actually going to be using some custom ones that I edited myself. So within the Google Drive link, I want you to go inside of the images folder. And inside here, you're going to see 4 images are going to be player down, player left, player right, and player up. So as you can see, these are just placed directly next to each other to create the same animation effect as we would have using the square format. But this is a lot easier to work with within JavaScript, so we're going to be using this format instead of the square one. So from the Google Drive link, I want you to go ahead and select those 4 images. So all I'm doing here is selecting player down, I'm holding shift, and then I'm clicking on player up. I have those 4 images selected. I can right click, hit copy right here, and then I want to go ahead and find my project folder. So I know that's under web. This is my Pokemon game right here, and I want to go inside of our image folder, and then I want to right click and paste in those 4 items. So now we have player down, player left, player right, and player up all available within our game. We can double check this by going on over to Sublime Text, and you'll see within our image folder we have those 4 sprites loaded in. So we drew out our image for our background. Let's go ahead and draw out our image for our player. So the first thing I'm going to do is just get rid of this console log. We no longer need that. And then beneath image.onload, I can go ahead and create a new const called player image. And this is going to be equal to a new image object. We're just doing the exact same thing as we did up here. So now that we have this player image constant, we can go ahead and say that our player image.source is equal to what? Well, we have 4 options to choose from, but let's go ahead and start with the easiest one, with our player facing down. I'm going to go ahead and select this player down image right here, so I can go into our image folder, and then reference player down.png. And now I just need to make sure that this draws out on the screen whenever it actually loads. So I can either write this out manually, or I can go ahead and copy this onload method right here. I'm going to go ahead and copy this by selecting it, hitting Command C, and then beneath line 18, I'll paste that on in. But remember, we're not waiting for our image to load because that is actually our background image. We want to wait for our player image to load instead. So once our player image loads, we want to call c.drawImage, our player image function, and then we need to determine where should our player be drawn out on the screen. So I typically find it easiest whenever we add a new image to a project to draw that image out at an x coordinate of 0 and a y coordinate of 0. That just means they should be placed on the top left hand corner of the screen. So if I go ahead and save, go back to Google Chrome and refresh, well, something is up here. Our player should be drawn right here in the top left-hand corner, but they are not. What is actually happening? Well, I can guarantee you right here that our player down image is quite small. This image right here is being loaded much quicker than our palette down image is being loaded over here. So as a result, this player image onload function is being called before our background image actually draws out. So if this draw image function right here for our background takes place after our player image is drawn out, what's happening is our background image is being drawn on top of our player. That is not what we want. So since I know our background image is larger than our player image, what I could do is I could just call c.drawImage for our player image within our background image onload function. If I paste that on in there and get rid of this player image onload right here, and then I want to make sure that I'm creating this constant above this onload function, because that way I declare our player image before we actually use it. Just makes more sense reading from the top down. If I go ahead and place this directly within the background image onload function, you're going to see that our image is now drawn out correctly. We waited for our background image to load, we drew that out first, and then we drew our player image. So now that we have our player drawn out, let's go ahead and move our player to the center of our screen, and then we can even move our background image to be in the correct position even more. So how do we move our player to the center of the screen? Well, it's going to be within these 2 coordinates right here for x and y. So for our player image, the x coordinate, what should it be? Well, it should be half the size of our canvas width. Our canvas width extends all the way from the left side of our canvas to the right side of the canvas. So right here, we want to go and say we want to spawn our player directly in the middle right here. How do we get this one coordinate? Well, to get that middle coordinate, we want to go ahead and select our canvas width, which we set up here to be 1024. So what we can do is we can grab our canvas width for our player image's x coordinate and just simply divide that by 2. And now, when we save and refresh, you'll see our player is placed pretty much directly within the center of the canvas. The left of our player right here is actually going to be the center of our canvas. So this is a good start. It's not perfect even on the x-axis, but let's go ahead and move our player downwards so that they are placed directly within the center on the y-axis as well. To get our player centered on the y-axis, we're going to select our y-coordinate where we're drawing our player out. We're also going to reference our canvas that we pulled in from our HTML. You can see we're getting that right here. We set the canvas height equal to 576, so we can go ahead and reference our canvas height, divide that by 2, save, refresh, and now that is pretty close to the center of our screen. But what we really want to do is get our player moved from where it is right now to the center point right in the middle. So using canvas width and height is great for getting your player placed near the center of the screen, but we need to add a little more code to get our player placed perfectly in the middle. So starting with the x-axis, how do we move this image over to the left so that's perfectly centered within this vertical line? Well, what we'd want to do is grab the width of our actual image right here, and then divide it by 2. So when we divide this by 2 and move this on over to the left by the size of one of these squares right here, it should place this center line directly within the center line of our canvas, giving us the effect we want. So for our x-coordinate, we know we need to get the width of our actual image. And in order to get that width, we can go ahead and select our player image and say we want to go ahead and from our canvas width divided by 2, subtract our player image dot width divided by 2. So player image dot width refers to this whole width right here of our player image, and then when we divide that by 2, we're just going to cut that in the middle. You'll see we're dividing by 2 right there. That is going to give us the distance of this right here, which will allow us to move this over to the left by the perfect amount based on our image width. So if we save and then refresh in Chrome, you'll see now our image is placed perfectly within the center of our vertical line. We just need to make sure we do the same thing for the Y coordinate of our player. So we're going to move our player up by half the height of this image right here. Same exact thing we did for our width. So here for canvas height divided by 2, we'll go ahead and subtract our player image dot height and then divide that by 2, save and refresh. And you'll see that it's placed perfectly within the center of our game. So our player is within the exact spot we want them at, but obviously our background image is not placed correctly, so all we have to do to reposition our background image is going to be just move this coordinate right here for where we are drawing that background image out. So it looks like we need to move this over by about 25 to 50 pixels on the x-axis, so I can just go ahead and say negative 770 for x. That is getting closer. Let's go ahead and make this negative 780. And maybe even 785, and that looks to be right in the center of our player right there. I think that is good enough. Now let's go ahead and make sure that we do the same thing on the Y coordinate. We want to go ahead and move our house up so it's placed right beneath our player. We'll go ahead and select our Y coordinate right here, subtract about another 100 from that, make this negative 650, save and refresh, and I think that looks really good. So it looks a little silly right now, simply because we have our whole sprite sheet being loaded in the game with 4 instances of our player, but in regards to positioning, this is absolutely perfect because our player is placed in the center of the screen, and our image is lined up pretty well to give off the effect as if our player is coming out of this house. So the very next thing I want to do is make sure that we're only rendering out one of these images. So we're not going to render out all 4 of these guys at the same time. We're just going to render out one of them, even though we're going to be loading all 4 within our original image. We're going to only be rendering out just this one portion right here, and we can do so with the draw image function. So to get just one of those images rendered out, we're going to go ahead and focus in on c.drawImage specifically for our player image. So this right here, we'll go ahead and select our image and put it at the x and Y coordinate that we specify right here. But the thing is, if we want to go ahead and start cropping this image so we can use sprite sheets per se, we need to add a couple more arguments to this function in order to make that work. So in order to add cropping to c.drawImage, we need to add 4 additional arguments right after player image. It's going to change how this whole method works. So right after player image, we need 4 arguments. For all of them, I'm just going to write 0 for now. So 1, 2, 3, 4. These are the 4 arguments we need to begin cropping things. So let's focus in on this first argument right here of 0. What does this represent? Well, this represents the x coordinate in which we want to begin cropping from. So if we look at our image over here, we know the x coordinate starts off on the left-hand side of the image. I think that makes sense for where we want to begin cropping from. So our x coordinate is going to be 0, which is equal to this point right here. This is where we're going to begin cropping from on the left-hand side. So we can leave this as 0 for the x coordinate on the crop. Now for the y coordinate on the crop, what does this represent? Well, where from the y-axis do we want to begin cropping from? This is also going to be 0. We want to start cropping from the very top of our image right here. So thankfully, we can leave our x crop and our y crop equal to 0. We're going to begin cropping from the top left-hand corner of our image. Now, how far do we want to crop to? If we were to keep 0 right here, we wouldn't actually be showing anything. This is going to be the crop width. What does our crop width need to be? Well, the crop width needs to be the full width of just one of these images. So what we need to do is get the full width of this image right here, and then if we divide that by 4, we have equal widths for each of these images. We can just go ahead and reference the width of this full image divided by 4 to give us the crop width we want, because we only want to show one section of this image at a time. So for our crop width, the 4th argument within draw image, this is going to be our player image dot width divided by 4. That means we're going to crop one section of our image, just that 1/4 of the image. Now the argument after that, this 0 right here, is going to be our crop height. So how far do we want to crop from the top of our image? Well, we want to crop the full height of our image. We don't need to divide this by anything, because if we were to divide this by 2 or something like that, well, we'd only be rendering out either a top or a bottom of the image. We want to render out this full thing because that is the way our sprite sheet is arranged. So for our crop height, we're going to reference our player image.height, and we don't need to divide this by anything, thankfully, so we can just leave that as is. And now our 6 and 7 arguments right here, these are going to be the location in which our image is actually placed on the canvas. We can leave this as is. We already know this is going to be the center of our canvas, but now we just need to add 2 more arguments that declare the actual width and height in which our image should be rendered out at. So really what we can do right here is we can just copy these 2 lines right here, which declare our width and height, and say we want to use the same things for our last arguments on which these are actually rendered out at. So if we save and go back to our game over here, make this full screen, refresh, now you're going to see we perfectly cropped our player by adding in all these arguments. So the most important thing to note is if you want to add cropping to an image, you need to add in these 4 additional arguments right here, which determine the crop position and the crop width and height. And then you need to make sure that you have these other 4 arguments down here, and these represent the actual coordinates and the actual width and height of the image being rendered out on the screen. So you just need to differentiate between the cropping and the actual position and the actual width and height, and that's how you're going to get a sprite sheet cropped correctly onto your screen. So this is rendered out correctly, but since we basically changed the width of the image actually being rendered out on the screen, it's not rendered out in the correct spot anymore. So we know our player right here is actually 1/4 of our original image. So if we go back on over to our code, this right here is going to be the X position of our player. We're not going to subtract our player image width divided by 2 anymore. We're going to subtract our player image width divided by 4 to start. So if we save and refresh that, we're getting a little closer to the center, but we want to make sure that our player is moved over to the right. So by subtracting 1/4 of our image now, we're getting a little closer, but we need to make sure that our player is placed over to the right just by a little bit. So what we're getting right here, we actually need to divide this by 2. So all we're saying is subtract this width right here divided by 2, and when we only subtract by this amount, it should get our player placed perfectly within the center on the x-axis. So if we save that, and then refresh, now our player is placed perfectly again within the center of our house, and we should be good to go to begin adding player movement into this. So looking back at to-do, we can go ahead and check off player creation. We created a player, imported them into our game using a sprite sheet, and then we positioned them correctly using a little bit of canvas width and canvas height math. So now let's go ahead and get our player moving through our map whenever we press down on one of our keys. So the very first thing we're going to want to do in order to move our player is we're going to want to start listening for events. So within JavaScript, to listen for events, such as when someone presses down on their keyboard, we can go ahead and call our window object. This is going to be available within JavaScript at all times for us, as long as we're writing code directly for the browser, which we are. So we can go ahead and reference this window object, and on top of this call, add event listener. So this is going to take an argument, and the first argument is going to be what event do we want to listen for. Now there are a number of events you can use within JavaScript on the browser, such as click, mouse down, touch, keydown. We are going to be using keydown because we want to listen for whenever a user presses down on one of our keys on the keyboard. So that event is going to be called keydown, all lowercase, and then whenever we key down, we're going to add a second argument right here that references an arrow function. So basically what we're saying right here is whenever we key down, we want to call whatever code is within this function right here. We can test that this works by console logging out some sort of text within this arrow function, and you save, go back to your game, refresh, right click, open up the browser, go on over to console, and then you begin keying down. Make sure you select your canvas right here. So I'm clicking, and then I want to key down. I'm pressing A, S, D, W. For any key that we press right now, we are console logging out that text, so we know this works, which is perfect. But now we only want to listen for particular keys, specifically WASD, because those are the keys most often used for moving a character within a game. So to listen for specific keys, within this arrow function right here, we want to go ahead and add an event argument into it. So this is going to be passed through by default whenever we key down. This is a pre-populated object. It stands for event, but most of the time developers will just call it E because they are used so often. So we're going to go ahead and call this E, stands for event. And if we were to console log this out, save, and then refresh, and then key down with our canvas selected, you'll see that this is what the E object consists of. This is a keyboard event. If I open this on up, we have a bunch of different details related to the event of me pressing down on a particular key, and the one we want to focus on within this object is going to be this key property. So right there, I pressed down the S key. So now what we can say is, when we press down this S key right here, we want to activate some specific portion of code. So if we want to grab this key property right here, within our code we can console log out e.key, If we save that, go back to our game and refresh and begin keying down, I'm going to press A, S, D. You see it's logging out the exact key we're pressing down on within our game. I can press a bunch of them. It just logs out all those keys based on whatever we actually pressed. So with this, we can create certain events that only occur when we press down on specific keys. So what we can do is we can write a switch case statement. We're going to switch out e.key. And inside of this, we want to write a case that basically says whenever the case is W, add a colon to the end of that, and then at the end of this, we're going to add a break. What this is basically saying is whenever e.key is equal to W, then we want to call whatever code is between case and break. So inside of this, I can console log out, pressed W key, and this is only going to activate whenever I press W. Let's get rid of this initial console log. I'll delete that, save, and then refresh. And now I'm going to press A, I'm going to press S, I'm going to press D, nothing being console logged, but as soon as I press W, you're going to see that we pressed down the W key. So this is when we'd activate code, which pushes our character up. We want to listen for not just W, but also ASD. So a quick way to listen for those keys as well is to just copy these 3 lines right here. I'm going to copy those with Command C, create a new line, and paste in 3 different instances of case. So now all I need to do is switch out W right here with another key. I also want to listen for our A key. I want to listen for our S key right here. And I want to listen for our D key right here. And now if I want to test this out, I just need to make sure within our console log that I'm logging out the correct key that we're pressing. So for A, we press the A key. For S, we press the S key. And then for D, we're going to press the D key. So I save and refresh, and then press W, A, S, D, and I try pressing any other key such as J, K, L, I, U, O. Well, none of those are going to show. We're only listening for W, A, S, D, which is exactly what we want to begin moving our player within our game. So how do we use this event listener and the switch case statement to actually move our player? What we need to do is add an animation loop in which we can change our image coordinates. And each time we change our image coordinates, we're going to go through a new iteration of a loop. And whenever we go to a new frame, if our images have different coordinates, well, it's going to give off the illusion as if our player or our background image is moving. So it'll make a little more sense as we actually code it. So let's go ahead and add in an animation loop now. In order to add in an animation loop, right above window.add event listener, I'm going to create a function called animate. So this is arbitrarily named. Does not matter what you name this, but since this is going to be our animation loop, it makes sense to call this animate. Now, in order to get this running in a loop, you'll see right now, if I were to go ahead and call this animate, like so, then console log out some text inside of it, such as animate, save and refresh. Well, this is only being called once. We want this to be called over and over and over again until we tell it to stop. And in order to do that, we need to use a window.request animation frame method. So this takes one argument, and it's going to be the function that you want to call recursively. What function do we want to loop through over and over and over again to begin editing our object properties? Well, it's going to be no other than animate. So if we were to call animate inside of this, animate right here is going to go back and call this animate function. So basically what we're doing is we're just creating an infinite loop. And there's nothing wrong with an infinite loop when we're trying to create an animation. This is totally okay. But when we request the animation frame of the function in which we want to loop through, we're just going to create that infinite loop to give us the exact effect we want. So by calling this right here, if we save, go back to Chrome and refresh, you're going to see now we're looping through that function over and over again, and we can begin editing our game's properties over time to create the illusion of movement. So in order to begin moving our player, it's really important that we move these C.draw images inside of our animation loop. Because right now, if we're just rendering these onto our screen once, well, whenever we go ahead and try to move things within Animate, these aren't actually going to move because we're not telling them that these should be drawn out continuously. We want to make sure that we're calling draw image for each frame of our animation loop. So we're going to go ahead and take these 2 lines right here. We can go ahead and take them out of image.onload. Because eventually these are going to be drawn no matter what because our animation loop is being called so many times. So we can just go ahead and paste these in directly within Animate. I'll get rid of this console log right here, save, and then refresh, and everything should still look the same. But now, in order to actually move our player or move our map, we need to edit the coordinates of C.draw image for either a background image or a player image whenever we key down. But in order to change the X or Y coordinates that we have right here for our background image, well, the issue is these aren't stored inside of a let in which we can actually change. These need to be stored inside of some sort of variable. So what we could do is we could create a let above our animation loop that says background image x coordinate, and then set it equal to -785. But why would I recommend against this? Well, eventually we might need to do the same thing for other instances of images, such as our player. So if we wanted to move our player image, we would have to create a new let right here, call this player image x, and then set that equal to whatever. And it's just going to make things really messy. It's really hard to keep track of what belongs to our player, what belongs to our background, and what belongs to any other images that we might use in our game. So if you ever find yourself creating some sort of variable where you select something such as a background, and then you select some sort of property on top of that, such as image or just your x coordinate, it makes sense to create some sort of class for that image. It's going to make your code a lot cleaner and much easier to manage in the long run. So this is a good instance in which we want to go ahead and convert these c.draw images into classes. So above animate, I'm actually going to delete these two lines right here, and I'm going to create a class called sprite. Uppercase S, because whenever you use a class within JavaScript, you should uppercase the actual name. So now that I have a class of sprite, I want to go ahead and call a constructor method inside of this. So if you're new to constructor methods, basically what this says is, whenever you create a new instance of a sprite, we're automatically going to call whatever code is within this constructor function. And within here, we can begin setting properties that describe what a sprite should look like, how it should move, what color it should be, and so forth. So each sprite is going to have a property independent from another sprite, and here is where we want to declare those properties whenever we actually create a sprite. So to declare a property within a sprite class, within this constructor function, we want to go ahead and reference a property with this, and then we want to declare the property name with dot, and then what is the property? So this first property is going to be equal to position, and I'm going to set this equal to a position that we're going to pass through this constructor method. So here, I never like passing my arguments through bare. So if I were to pass it through bare, I just reference position right here, because if I need to add on additional properties, well, I need to add a comma and then add on another property like velocity. And the issue with this is you need to remember the order in which you pass these through. I really don't like remembering the order, so instead I like passing through just one singular object, and then within this object I can just reference particular properties, such as position or velocity. And now when I go ahead and create a new sprite, it does not matter the order in which I pass these through, and it just makes our code a little cleaner in the long run. So to get you acquainted with this class, if you're new to it, let's go ahead and just immediately begin creating a new sprite. So now that we have this class created, I can create a new const, and this is going to be equal to our background sprite. So this should be equal to a new sprite. So basically we're saying create a new sprite from this class right here. And now whenever we create a new sprite, what are the properties in which a sprite can take? Well, it's going to be whatever is within this constructor method right here. We're just passing through one singular object, so we can reference that one singular object. Say we want to pass through what? An object with a property of position or velocity. Well, right now we're only assigning position within this, so I want to reference a position, and I know I want to set this equal to an object with an x and a y property. So for x, I'm going to say by default should be equal to 0. For y, this should be equal to 0 as well. And now we have a new sprite created within this background constant. So if we wanted to link this background constant up with our actual background we're drawing out on our map, this is where we're drawing out our background right here, and we know its x coordinate is actually -785. So for x right here, we could say our position by default should be -785, and for y this should be -650. So this right here. We're beginning to link this up. We just created a position and stored it within this position property right here. And now that we have this position property stored, we can use it to begin drawing out an image directly within this sprite class. So beneath constructor, if I go ahead and add some break lines right here, I can create a new method. And for all the classes I draw out on my screen, I like creating a method called draw. This is also arbitrarily named, but this is going to determine what we're actually drawing out on the screen using Canvas. What code do I want to use to draw something out? Well, this code right here for drawing out our background image. I'm going to go ahead and cut this out of place with Command X and paste it in to draw right here. So we're calling c.drawImage. But you'll notice right here, we're referencing a constant that we don't actually have access to within our sprite class. Although this might be global, this is not good code quality, especially because all of our sprites are going to need different images associated with them. So since each sprite should have a different image associated with it, that is a perfect instance in which I know I want to create a new property for the sprite class. So here, underneath position, I'm going to add in another property called this.image, and I want this equal to whatever image I pass through within our sprite constructor. So we need to pass it through new sprite right here. But now, since I'm referencing image, I need to add this in as a property within our constructor method. So I'm going to go ahead and add a comma. So we want to pass through an image. And now that this is available to pass through within the constructor, here I can go ahead and add a comma right beneath our position property and say, what should our image for the sprite be equal to? Well, I want this image equal to the image we created up here for our background. This is going to be the pelttown.png. So if I go ahead and say image should be equal to the image constant we created above, basically this right here is being passed through into the constructor. This right here is going into this.image. And now that we have this.image available to us, we can use it within our draw function, but we just need to make sure that we change image right here to actually reference this.image. So in order to do that, here we just need to say we want to draw out an image of this.image, and now we're going to go through this whole loop process and call c.drawImage with the image we passed through for our background. So we have our background created. Now all we need to do is actually call the draw method within our animation loop. So right beneath where we're drawing out our player, I'll call background.draw. So when we call background.draw, we're going to call this right here, which populates the image through this whole process we just went through. And now when we save, go back to our game, and refresh, our background is still being drawn. This might not seem like a lot, but this is exactly what we need to do to begin animating our background to create the illusion of movement. It's very important that you don't skip this step, so make sure you go through the process of creating the sprite class so you can begin moving your background along with me. So now that we classified our background, we can begin changing its properties over time within our animation loop. So actually what we want to do is listen for when we are pressing down a W key, an A key, an S key, or a D key from within our animation loop, and based on which one we're pressing down currently, we're going to move our map in a particular direction, which is going to give us the illusion of movement. So within here, within animate, I want to go ahead and listen for if we are pressing down the W key. So how would I actually do that? Well, I need some sort of object to actually set W, A, S, and D properties to on whether or not they are pressed down currently. So above animate, I'm actually going to create a new const. This is going to be equal to keys. And I'm going to set this equal to an object, and inside of this I can begin referencing the keys I want to listen for. So the first key I want to listen for is just going to be W, and I'm going to set this also equal to an object, and inside of this I'm going to add a property called pressed. And I'm going to set this equal to false, and this just means our W key is not pressed down by default. And I want to do the same thing for our A, S, and D keys. So I'll go ahead and copy this one object I just created for W, make sure I add a comma to the end of it, paste in another, add a comma, paste in another, add a comma, and paste in another. So now I have 4 properties in here, but I want to make sure that they're all different from each other. I also want to listen for our A key, our S key, and our D key. So none of these are going to be pressed down by default. But now, whenever we do press one of these down within our Keydown event listener, we can begin setting these equal to true. So whenever we press down the W key right here, we no longer want to console log out this. Rather, we want to select our keys object. What do we want to select? Well, the W property right here. So I'll go ahead and say keys.w. Is it pressed down right now? Yes, it is. We're going to set that equal to true whenever we press down on our W key. We want to do the exact same thing for A, S, and D. So we can just copy this line right here, get rid of the console log, and then say for our keys A, is it pressed down when we press A? Yes, it is. Let's do the same thing for S. We'll paste that in. Change keys, .s.pressed equal to true, and then we'll get rid of D. Paste in keys, .d.pressed. That is also going to be equal to true. So now within our event listener, right beneath our switch statement, if we console log out our keys object that we just created, let's go ahead and save, refresh, and open up our console to see what this looks like. So over in our console, if we click on our canvas and we begin pressing ASDW, watch what happens. I'm going to press A. I look inside of this object right here, and you're going to see A is now equal to true. If I press S, open this, S is now equal to true as well. D, that's going to set D equal to true. And then eventually when I do W, that's going to set all of them equal to true. So I did those in sequence from one another. That means I lifted up on one of the keys as I went to the next one, which means technically the key I left it up on should not have pressed equal to true. So whenever we lift up on a key, we need to make sure that is set to false. How do we set these to false whenever we lift up? Well, we're going to want to listen for a different event, specifically for key up, not key down. So a quick and easy way to do this is just copy this add event listener right here, and beneath it, paste in another event listener, but we don't want to listen for key down. We want to listen for key up instead. So all this code is going to function exactly the same. The only difference being is this code right here is going to fire whenever we lift up on one of our keys on the keyboard, not key down onto it. So we know whenever we key up, whenever we release one of the keys we press down, we want to set that pressed value equal to false. So these 4 values right here for key up, I'm going to select those 4 with Command D on Sublime Text, and then I'm going to change these equal to false. So whenever we lift up on one of these keys, we're going to say it should no longer be pressed down. So now that we have an object which tracks which key is currently pressed down at any particular point in time, we can go back to animate right here in this if statement that we were creating. We can go ahead and say something like, if keys.w is pressed down, we can begin moving the properties of our background sprite that we created. What property do we want to move? Well, no other than the position property, specifically its x and its y. So what I'm going to say is, if keys.w is pressed, I'm going to go ahead and select our background object, and I know this has a property of position on top of it. Whenever I press W, I want to make sure that our background moves down. That's going to give off the illusion as if our player is moving up. So I'm going to select our Y position right here, and I'm going to say, whenever our W key is pressed over time, I want to take that background position Y and set it equal to background.position.y, so the current position it's at, and I want to subtract from it over time a value of something like, let's just say 3. So right now we're only going to be editing our current background position on the y-axis if W is currently pressed. So if I were to save this, go back and refresh, and I hit W, well, nothing is moving. What is going on here? Well, let's go ahead and inspect our class for sprite. If we look within our draw method, which remember is being called within our animation loop over and over and over again, we're drawing out our image at a location of -785 and -650. These are static values. So although we might be editing our background's position over time, using this code right here, well, it's not actually going to change anything with the rendering because we're not using this .position within our actual draw image code right here. So we know when we create a new sprite for our background that we're setting its position equal to these 2 coordinates already. So what we can do is we can get rid of within c.drawImage this -785 and reference this .position.x. That's going to go ahead and say that this should be equal to this right here. And then we want to do the same thing for our y coordinate. So we just need to make sure that this 650 right here is being referenced from our position rather than just some static value like we have right here. So for our y coordinate, we can reference this .position.y. That's going to give us this right here, -650. We're going to go through the constructor process. If we go ahead and save, refresh, and then hit W, you're going to see that our background moves. Although it definitely looks like we are moving in the wrong direction, because whenever we press W, we should be moving upwards. So in order to fix this, we just need to go back down to our animation loop right here, and say we want to add on 3 to background.position.y, save, and refresh. Now when we hit W, our background moves in the correct direction. And to illustrate how this is working over time, I think it makes a lot of sense to console log out background.position.y. If I go ahead and save, refresh, and open up our console, and then I begin holding W, you're going to see this is the y coordinate of our background over time as we hold W. So we started off actually at -650. We added 3 onto that. That's going to give us 647. And then as we keep moving up, while we keep subtracting 3 from this value, and it renders out our background at a different position in time, which is giving off the illusion of movement. So we just need to make sure we do the same thing for when our other keys are pressed. So to clean this up a bit, we'll get rid of the console log, and since we're only calling one line right here within our if statement, we don't actually need curly brackets. We can go ahead and get rid of these because we're only calling one statement, and now our code is 1 line instead of about 3 to 4. So here, we can just go ahead and copy this line, paste it below, and then add in an else if instead that says else if the keys.a is pressed, we want to go ahead and move our background position on the x-axis instead of the y, because when we press A, well, our player should be moving to the left, which means for background position.x, we should be adding 3 onto this. If I go ahead and save and refresh, and then I hold down A, you'll see now we are moving to the left, but really it's just our background image moving to the right, which gives off the illusion as if our player is moving to the left. So something else we can do here to clean up our code is we can use a shorthand syntax for these statements right here. This right here is going to be the exact same thing as +=3. So all this means is we're taking our current background position on the y-axis and we're adding on 3 to it at any point in time. So if we were to go ahead and change this out, we go ahead and get rid of this right here, and say that background position.x should be plus equal to 3. That is the exact same thing as what we just had previously. It's just a little cleaner. So we save and refresh. We can still go up when we hit W. We can still go to the left when we hold down A. So now let's take care of S and D. We'll go ahead and copy this else if, paste it in 2 more times. Now for S, we don't want to listen for keys.A, but rather keys.S, and say whenever we are going down, we want to select our Y, and then instead of adding on 3 to our Y position, we want to subtract 3 instead. So that's going to take care of going down, but now we need a D, so we'll listen for keys.D.pressed, and whenever we hold down D, our background on the X position should be moving to the left, so we want to subtract 3 from that. So now if we save, we go back and we refresh. If we hit S, we go down. If we hit D, we go to the right. If we hit W, we go up. And if we hit A, we go to the left. So this is honestly looking great for our player movement, but we can touch this up just a little bit more, and I think this is important to make sure that our game is working as optimally as possible. So I'm going to narrate this out as I do it. If I hold down S and then press D, well, I'm not actually moving to the right, even though D was the last key pressed. I want to make sure that whatever last key was pressed, even if I'm holding 2 down at the same time, that I start moving in that direction. And in order to get this effect, we can't just listen for which key is being pressed, we also need to listen for what was the last key pressed. And based off of that last key and what is actually being held down as we're tracking right here, that is when we're actually going to move one of these position coordinates. So within our event listener, specifically for key down, we want to go ahead and listen for a let of last key. This is going to be equal to an empty string by default, but whenever we press down something like W, we want to set last key equal to a string of W. We want to make sure we're doing this also for A, S, and D. So I'm going to copy this line and say our last key for A should be equal to A when we press down A. Our last key for S should be equal to S. And then our last key for D should be equal to D. So we're never going to set this back to a blank state. We're not going to call this within key up at all, which means this is always going to track whatever the last key we pressed down was, specifically for W, A, S, and D. So now that we have this last key property, we can listen for what key is currently being pressed down, but also whether or not that current key that is pressed down was the last key being pressed. So here I want to add an AND statement that says, if our W key is currently being pressed and our last key is equal to W, meaning this is the very last key we pressed. It wasn't A, it wasn't S, it wasn't D, even though these might be equal to true, then we want to call this line of code right here. We want to do the exact same thing for our other else ifs, so I'll copy this AND statement and paste it into each location like so. So now when we press A, we want to go ahead and move our background to the right, but only when our last key was equal to A. And then we want to do the same thing for S, and the same thing for D. So this is going to basically allow us to switch direction even though we might have multiple keys down at the same time. So if I save and I refresh with that, let me narrate this. I'm going to go ahead and hold down S. Now, when I go ahead and press D while S is down, you'll see I am moving to the right even though I have 2 keys down pressed at the same time. I can do the same thing by pressing W. And then finally, I'm holding 3 keys down when I go ahead and press A. You'll see that just overrides the last action, and that gives us accurate movement in regards to what key we are currently pressing down at any point in time. So now we can go ahead and check off Move Player Through Map on Keydown. So now let's go ahead and add Player to Map boundary collisions. So obviously on our island over here, we want to make sure that our player can't go into the water. They shouldn't be able to go past or on top of our house like you see right here. We want to make sure that we add those boundaries in that we actually created within Tiled. So how do we actually go about doing that? Well, in order to add those collisions, we're going to want to head back on over to Tiled. And over here, you'll see that we have a layer for collisions. Now, you might be thinking, can't we just turn off all of our other layers and export our collisions as needed? Well, unfortunately, with Tiled, they don't allow you to do that. You pretty much have to export all these layers into one file, and then take out the data you want as needed. So that's what we're going to do. We don't have to zoom in or anything like that. All we need to do is go to File, and then we're going to click Export As. So once we're over here, you'll see that we have a few file types in which we can export this file as. It's going to be a JSON map file, JavaScript map files, Lua CSV. We're going to want to go ahead and export this as a JSON map file because I found that easiest to grab exactly what we need. So I'll go ahead and select this option right here, and then we can call this whatever we'd like. If we want to go ahead and camel case this, we'll go ahead and call it Pellet Town with a capital T. And then it doesn't really matter where I save this. I can even just save this within our downloads root. So I'll go ahead and do that. I'll hit save. And now, within Finder, you're going to see within my downloads folder that now I have pellettown.json. So this is what we just exported. And if I go ahead and preview this, you're going to see that it basically contains an array full of all these different numbers. And if I scroll down, well, we're going to have a new array full of numbers. So what this represents is basically our game map. Each number represents a different tile on our map related to a specific layer within Tiled. So you'll see right here, this first object, all this data right here refers to our ocean layer. So every symbol inside of here represents an ocean tile. So let's go ahead and open this on up. I'm going to go ahead and drag this onto Sublime Text to open it. And then I'm going to open these two up side by side so I can show you exactly how this map was exported into this data over here. So we know this data over here, this array, represents our ocean layer, as we can tell right here with this name indicator. So all this data is related to our ocean. And this very first data point right here is going to say, draw a specific tile at this very first point where our map starts. If we want to continue, the second point right here is saying draw a different ocean tile right next to that first one. We're just going to keep going until we go through 70 tiles, because that is how large our map actually is. It's 70 tiles wide, so as soon as we hit the 70th tile, we're going to go down a row, and then we're going to go right about here and say that this tile right here should be equal to the first tile on that second row. And we're just going to keep going through this whole data set until we fill up our entire map with all the ocean tiles. So that would take care of the ocean layer, but you're going to see inside of this exported file, we don't just have an ocean layer, we also have things such as an island layer. We're also going to have, if I keep scrolling down, a trees layer. So all these layers right here are one-to-one representations of every layer we actually created within Tiled. Ideally, we could just go ahead and export our collisions layer as needed, but unfortunately Tiled doesn't support that functionality as of yet, at least that I'm aware of. So in order to go ahead and grab our collisions data that we need to actually prevent our player from going off the map, within this pellettown.json file, we're going to need to do a Command F or Control F for you Windows users, and go ahead and search for collisions. So up here, this is all the data related to our collisions layer, and you'll basically see everywhere where there is a 1025, this is where we are drawing out a collision within our map. It's kind of hard to see how these actually form the exact structure we have over here with these red blocks, but everywhere where there is a 1025, it's going to be a one-to-one representation of where we should be placing a collision block within our game. So we're going to want to go ahead and copy our whole collisions array. So I'm going to go ahead and scroll down until I hit the end of it. It's going to be right about here. I'm going to hit Command C to copy it. And now that I have that, I can pretty much just minimize our pellettown.json file. When it comes to data, all we really need right now is going to be the data related to our collisions. So I'll minimize that. And then within our project, I'm going to want to create a new file. So go to File, New File, and here I'm going to paste in all that data. So at the very top, I want to go ahead and assign this to a constant. So I'll create a const called collisions, set it equal to this array. So now I'm going to hit Command S to save this. And I want to go ahead and save this within our project so I know that's within web. This is going to be Pokemon-game, and I could save this within our project root, but I think it makes a little more sense to be organized and save this within a folder in case we need to import any more data. So I'm going to go ahead and create a new folder right here, and I'm just going to call this data. And now I want to call this file collisions.js. So basically we took the array from the JSON file, and we created a const which is equal to our collisions array, which we need to import into our game. So we basically transferred it over to a JS file so we can import it into our game quite easily. So I'm going to go ahead and save it as collisions.js within our data folder. Now you'll see we have a data folder within our project, so now we can begin using this within index.js. So if I wanted to go ahead and reference this const right here of collisions within index.js, the first thing I need to do is make sure that this collisions.js file is imported into index.html. So to import this JS file, I can simply copy the script tag right here, paste it above, and then I'm going to swap out index.js with collisions.js. But first, I need to make sure I go inside of our data folder, so I'll go ahead and type data/collisions.js. So since this file right here comes before index.js, now I can use whatever data is inside of it within index.js. So within index.js, I'm going to console out what? Well, collisions, because that was stored as a const within collisions.js, which we imported right here. So now we should have it available to us. So now if I save, go back to our game, open up our console, and then refresh, you're going to see that is the array that we exported from within Tiled. So if we look back within our collisions.js array, you're going to notice that these are all just comma-separated values. There are no arrays within this array. That's going to be the next step, is we want to go ahead and transform this data into a 2D array. And once we transform that into a 2D array, it's going to allow us to loop through it correctly so we can create canvas objects on our game. So we're going to create little squares based on whatever data we have within that collisions file. And they're basically going to line up perfectly so that they recreate the collisions that we actually created within tiled over here. And since we're going to be drawing canvas squares for our tiles, well, we can use programming to determine whether or not these tiles are colliding with our player. And if they are about to collide with our player, we're going to stop our player movement to give off the effect as if we cannot move past these in any direction where they are drawn. So how does this whole 2D array parsing and implementation work? Well, essentially what's going to happen is we're going to have our root array. So this root array right here is basically representative of what we have over here stored within collisions. We have one root array currently, but we need to go ahead and parse these values into arrays within this root array. So if we were to parse these into arrays, this root array right here would have subarrays inside of it. So there's one subarray. We'll draw another subarray. And then we're going to draw a third one right here, and this can go on for however many tiles we have for the height of our map. So basically we want to go ahead and transform our root array's data into subarrays. So for this first subarray, we would have something like 0, 1, 0. And then for the second one, we might have something like 1, 0, 1. And then finally for this third subarray, we might have 0, 1, 0. So what does this even mean? Well, basically, we're going to go ahead and loop through this array, and we're going to go ahead and draw out onto a game map. So this is going to be our game map right here. As we loop through this array, each of these subarrays is going to represent one row within our game map. So if we were to go ahead and loop over a 0 just means we don't want to draw anything out on our game map. So we loop over the 0, we go over to our game map. Do we want to draw anything within the first 1/3 up here? No, we don't, because we know we have a 0 that we're looping over. But if the second symbol we're looping over is a 1, that means we do indeed want to draw something. What are we going to draw? We're going to go ahead and draw some sort of boundary. So I'll draw a boundary where there is a 1, and now I know I have a 0 right here. I do not want to draw anything next to that. So if we loop through our second array right here, we have a 1. That means within the middle of our map, since this is the second row, I want to draw a boundary where there is a 1. We loop over to 0, nothing going to be right here. But eventually we do hit a 1 as well, so we're going to draw a boundary over here as well. Finally, we have our last row, so we have a 0, not going to draw anything right here. We get a 1, we're going to draw a 1 right here for our boundary. And then finally we have 0, not going to draw anything right there. So based off this array, we're going to draw collisions onto our map, and everywhere where there is not a collision, that's going to be free area in which our player can actually move around in. So everywhere where I'm coloring over, this is where our player can move, but as soon as we hit one of these collisions, we're not going to be able to based on our programming. But the first thing we need to do is actually render these blocks out using canvas objects. And once we render these out as canvas objects, well, we're going to be able to program that effect where a player cannot run into these. So how would we go ahead and parse this array right here into something like this? Well, within index.js, we're going to want to go ahead and create a traditional for loop. So I'll go ahead and delete some code that we no longer need. We no longer need this fill style or fill rect that we used to originally separate our canvas from the background. And right there where I deleted that code, I'm going to start creating a traditional for loop by declaring for, adding some parentheses. Then I'm going to declare a let I equal to 0. This is going to be our loop's index. And I want to say I want to go ahead and run through this loop for as long as I is less than our collisions dot length. And then over here for our iterator, if I were to go ahead and do I++, that just means we're going to loop through this for however many items are within our collisions array right here. So there are probably about, I would guess, 1,000 items within this array. So basically we're saying loop through this loop 1,000 times. But we don't want to loop through this 1,000 times because that's going to be a little inefficient. We basically want to go ahead and loop through this at increments of 70. So we want to go ahead and start off at 0 right here, and then go up about 70 elements, and select everything between this and this. And then within our loop, we're going to want to go ahead, start off at this element we ended at previously, go up about 70 elements, and then select everything within there. So this is how we're going to be creating our rows. We're basically selecting every 70 items, incrementing onto the next 70 items, and pushing those 70 items into an array to create the same subarray structure that we had right here. So rather than loop through this for every item, here for I, we can say we want to iterate through this for every 70th item. And how do we know to use 70 right here? Well, like I said, 70 is just going to be the width of our map based on the tiles we're using. So if I go back to tiled, and I full screen this map right here is 70 tiles wide. How do I double check that? Well, I can go up to map, and then hit this resize map tab right here. When I select that, you'll see the size of our map is 70 tiles wide by 40 tiles tall. So this is really useful for us to use in order to parse our data into a format that's more usable for our JavaScript game. So that 70 tiles right there is going to go right here, and then we're going to want to go ahead and select every element from 0 to 70. So we can do this by selecting our collisions array, and then calling an array slice method on top of it. So the first argument for slice is going to be the first index in which you want to slice out items at, which for us is going to be 0. And then the second argument is going to be how far do you want to slice elements to? It's going to be 70 because we know we want 0 to 70 elements from collisions. So if I were to go ahead and console log collisions.slice, go back to our game, open up our console, and then refresh, you're going to see we're slicing out the first 70 elements. And we're doing this exactly 40 times because we're looping through collisions.length by adding on 70 for every iteration. But we know we want more than just items 0 to 70 from within our collisions array. We also want all the other rows, all the other items associated with collisions.js over here. So rather than just use a static value of 0 to 70, what we want to do is go ahead and replace 0 with I, because we know I by default is equal to 0. And now we know we're going to get 0 to 70 right here, but as we begin to increase I over time, well, I is going to be 70 on the next iteration of this loop. But now the issue is, if we slice out the items of 70 to 70, well, we're not actually going to be grabbing anything right here. As we increase I, we also need to increase this value right here by an additional 70. So instead of just referencing 70 right here, what we could do is we could add I onto this. So for our first iteration, I is going to be equal to 0, so we're slicing out 0 to 70, because when we add 0 onto 70, well, we get 70. For the second iteration, we're going to have I equal to 70 because we're adding 70 onto I. So here, I is going to be equal to 70, I is going to be equal to 70 here. As a result, we're going to be slicing out 70 to 140 based on the evaluation of this equation right here. And this is just going to keep going until we loop through our map's height. So if I save this, go back to Google Chrome, and refresh, some of these arrays should be different. And you see if I start scrolling up, now we have some 1025s within these arrays. That means our collisions are being added to the correct rows. So we know we're creating rows based off of this collision slice right here, but now we need to actually store them within a new array. So to store them within a new array, I'm going to create a const, and I'm going to call this collisions map. So that's equal to an array. And now within this for loop, I can select collisions map, and then I can push in this collision slice code that we just created. So I'll go ahead and grab that, push in collision slice, and beneath this for loop, I can console log out collisions map. I'll save and then I'll refresh. And now you'll see this format that we have right here, we have one root array, but within this root array, we also have a bunch of subarrays. So for every row where there is a 0 within these subarrays, we're not going to draw anything, but everywhere where there is a 1025, that is where we're going to go ahead and draw out a collision. And you'll see right over here, this formation of 1025s is pretty darn close to what we have in tiled. You can definitely see the shape over here matches up with what we have over here. Those are pretty darn similar. So now that we have this array parsed out correctly, we're going to want to go ahead and create canvas objects placed in their exact positioning based on how they're parsed out into this array. It's going to make a little more sense as we continue. So first thing first, let's go ahead and create the object we actually want to render out. So in order to create an object, I'm going to go ahead and create a class, and I'm going to call this boundary just to separate it a little bit from our collisions keyword over here. Now that I have a class of boundary, I'm going to create a constructor method. And now I need to decide what defines a boundary. Well, I know each of our boundaries is going to have a position associated with it, and this position is going to vary, so I want to make sure that I'm passing through a position within our constructor right here. I'm going to assign that as a property within a singular object, and then I'm going to say I want this dot position equal to the position we pass through. I know each boundary is also going to have a width, and then a height associated with it as well. So how big do I want these boundaries to be? Well, within our map, our boundaries were created using a dimension of 12 pixels wide by 12 pixels tall. But remember, we actually exported our map 4 times zoomed in using this down here. So we zoomed in at 400%, which means our tiles were actually increased from 12 by 12 to 48 by 48. If we multiply 12 by 4, we're going to get 48. So the actual width and height we want to assign to our boundaries right here is just going to be a static value of 48, because we know we're using that 4 times multiplier for every tile within our map. So with an XY position of width and height, we know we can draw a square, but now we just need to define how we actually draw that square. So we're going to go ahead and add an arbitrarily named draw method. And within this, I can select our canvas context with a C dot and use fill rect. So this takes 4 arguments. The first is going to be the X position. So we'll go ahead and reference the position we're passing through as this dot position dot X. The second argument is going to be our Y position. So we'll go ahead and grab this dot position dot Y. Our third argument is going to be our width. So we'll reference the boundary's width. And then finally, we're going to reference our boundary's height with this dot height. Now that'll draw out a black rectangle when we call draw, but we want to go ahead and make this red to match up more closely with what we actually drew out in tiled. So we'll go ahead and select C dot fill style and set that equal to red. That's really all we need to get started with some sort of traditional boundary. So we know we're going to have multiple boundaries laid out on our map, so it kind of makes sense to create boundaries const like so and set it equal to an array. This is going to store all of our boundaries, which we can later use to render all these out within our animation loop. So now that we have this boundaries array, we want to go ahead and populate it with instantiated boundaries using this boundary class, but we want to go ahead and make sure that the position for each of these boundaries is positioned precisely based off of this collisions map. So everywhere where there's a 1025, we're going to push in a new boundary into our boundaries array. So how do we begin doing that? Well, we're going to want to go ahead and select collisions map like so. Then we can go ahead and call a for each method on top of it. And we want to say for each row within our collisions map, we'll call an arrow function. And now that we have a row, we can also call a for each on top of this, which grabs the symbol associated with each row. So we'll go ahead and reference a symbol. And these 2 arguments right here, by the way, are arbitrarily named. I'm just naming them in regards to what they actually represent for each item we're looping over. So if I were to go ahead and console log out the symbol we're currently looping over, go back to Chrome, you're going to see we're basically just going through our whole array within collisions.js. But since we're actually looping through a 2D array, we're going to be able to place our boundaries precisely in their exact locations in which we want them at. So within the second for each loop right here, I'm going to want to go ahead and select our boundaries array and push in a new boundary using this boundary class we just created. So we know this takes an object as a constructor, and then it's going to have a position property inside of it. And I want position to have an X and a Y property because that's what I'm using right here. And also right here, so I'm going to go ahead and assign position equal to an X. And then also a Y property like so. And now I just need to make sure that these are assigned in the exact spots I want these boundaries placed. So I'll go ahead and add a 0 for both of these by default. And I'm going to want to place these based on the indices associated with our rows and also our symbols. So right here for our first for each, next to row, we can add a comma, and then add in a second argument, which I'm going to call I. This is the index of the current row we're currently looping over. And then I'm going to want to do the same thing for a row for each, where we're looping over each symbol, add a comma, and then I'm going to call this J to represent the index of whatever symbol we're looping over within each row. So when we loop over each row, we're going to be looping over each row at a time. So we'll go 1, 2, 3. This I right here represents the index of the row we're currently looping over. So when we loop over the first row, the index is going to be 0. When we loop over the second row, index is going to be 1. When we loop over the third, the index is going to be 2. So I is equal to 0, 1, 2. These are our I's. And then within each of our rows, we're going to be looping over each symbol. These right here are going to be our symbols. So in this case, J is going to be the index associated with each symbol within the row. So our index in this case for 0 is going to be 0. For 1, it's going to be 1. And then for this last 0, it's going to be 2. So these are indices associated with the symbol within the row we're currently looping over. These are our J's. So we know our I's are associated with Y positioning. They go downwards. So what we can do is for our Y on the boundaries is we can go ahead and grab the index we're currently looping over, which we'll do right now. We'll go ahead and say Y should be equal to I. And then if we multiply that by the height of our actual boundary, which is going to be 48, well, we're going to be placing tiles on top of each other so that they're laid out in a perfect row format. And now we can do the same thing for our X position. We know our X position is based on J right here. So what we can do is say for X, we want to grab our J index and multiply that by the width associated with our boundary. So we can go ahead and reference this as 48. And now each of our tiles is going to be laid out on the X axis in perfect format right next to each other. Now, when you come back to this code at a later point in time, you might forget what 48 represents, so it makes sense to actually create some sort of const for this value right here. You might be trying to reference your boundary's width and height directly, but you can only grab these two properties when a boundary actually exists. we actually haven't created a boundary until we loop through this whole thing and actually call new boundary right here. So instead, what we can do is, within our boundary class, is we can create a static property by using a static keyword and call the static property width and set it equal to the same width we're using down here within our actual boundary property. So now we have a width equal to 48. We can also create a static height equal to 48. And now what we can do is call boundary directly right here where 48 is. We're just going to call the class with an uppercase B. And then we can just reference boundary.width. That's going to give us 48. But now we know exactly what 48 represents. It's going to be our boundary width. We can do the same thing for this 48 down here. This is going to be our boundary height. So this is a lot more descriptive than what we had previously by just referencing 48 as a static value. So we come back to this at a later point in time. Now we know what these two represent. So if we console log out our boundaries array with everything pushed into it, and we refresh in Chrome, you're going to see we have all these boundaries in place for every single value within our collisions array. There were 2,800 values within our collisions array, and now we have 2,800 boundaries, but that is not correct, because we don't want to go ahead and draw a boundary on every single location within our tiled map. We only want these boundaries drawn out in whichever location there is 1025 within our original collisions array. So as we're looping through our 2D array right here, within our row.forEach, we actually only want to push through a boundary if the symbol we're currently looping over is equal to 1025. So whenever we go ahead and pass over 1025 right here, we're going to be pushing in that new boundary into our boundaries array. So if we do that, save, go back to Google Chrome, you're going to see now we only have 185 boundaries. That is the exact amount that we actually created within tiled over here. And that is exactly what we want, because when we open these boundaries, you're going to see that their position varies for every single one. And they're all laid out correctly because we use this method over here, referencing our I indices and our J indices. So our boundaries are created pretty much perfectly. Now we can go ahead and render them out onto our scene. So to render these out, we're going to want to go into our animate loop right here and determine where do we want our boundaries drawn. Well, I do want them drawn after our background is drawn because I don't want any boundaries placed behind our background. If that's the case, we're just never going to see them. So I want to draw this after background, but I also want to draw this before a player because when I test things, I think it just looks a little better for a player to travel over the boundaries rather than behind them. So between background.draw and where we're drawing out our player, I'm going to go ahead and call boundaries.forEach, and then I'm going to go ahead and select the boundary we're currently looping over, and then say, within this arrow function, I want to go ahead and call boundary.draw. So this draw method right here is just calling this draw method right here, which just creates a rectangle. So if I save that and refresh over here, you're going to see we have boundaries drawn out on our screen, but they're only in the bottom right-hand corner. They're not actually laid out correctly in regards to where they should be placed on our map. The reason for this is because when we actually created our map sprite right here, where we assigned sprite to background, we offset its position by a little bit. We went ahead and set its x to -785, and we set its y equal to -650. That same offset is not being applied to these collision blocks right here, so we want to make sure that we apply this to where we are creating our collision blocks as well. So if we're going to go ahead and use this value in another spot, it makes sense to create a const. I'm going to go ahead and call this offset set equal to an object with an x and a y. So our x by default is going to be offset by -785 pixels. For y, our offset's going to be -650. So now that I have this offset const created, right here I can replace -785 with offset.x, and I can do the same thing for y, offset.y. If I save and refresh this, everything's going to be offset correctly for our background. We need to make sure that we're applying this offset x and y to our boundaries as well. So I'll go ahead and cut this offset right here, and I'm going to paste it right above where we're actually storing our boundaries. So right here I'm going to add offset, and now I can use this constant within this code right here. So this is where we're pushing in new boundaries and setting their position. I want to keep this code the same, but I also want to go ahead and add onto it our offset.x. That's going to subtract -785. Want to do the same thing for our height. Add on offset.y. Save and then go back to Chrome. And you're going to notice, well, this is a lot closer than what we had before, though it's still not placed in the exact position we want. So if this is the effect you get, well, it's very likely that your collision blocks are in the correct spot, but more so that your background is not. So why would our background not be in the correct spot along with our collision blocks right here. Well, within Tiled, there are going to be properties associated with each layer called horizontal and vertical offset. So what these do is they go ahead and offset items by a certain amount. So for our foreground layer, if I were to go ahead and offset this by something like 20, you'll see that our foreground layers are offset by 20. Now what this does is, unfortunately, when you export your map, it also adds around 20 pixels onto your width if you were to go ahead and add some horizontal offset. That is not good, that is not what we want, and unfortunately when I exported this the first time, I had a little bit of horizontal offset on one of my layers. So in order to make sure that your map is as perfect as possible lined up with your collisions, you want to make sure for every single layer you have, horizontal and vertical offset are 0. So if I go ahead and swipe through these quickly, you'll see now every single layer I have has a 0, 0 for horizontal and vertical offset. So if that's the case, all we need to do is make sure we export a background image without that horizontal or vertical offset. So in order to export this, I'll turn off our foreground layers, our battle zones, and then our collisions. So this is what I want to export. I just need to make sure that I zoom in by 400 pixels. So I'll do that now. Then I'll go over to File, Export as Image one more time. Save this within our project directory as pellettown.png. Make sure I am using the current zoom level, and then I just want to hit export. And then I'm going to replace the last version with this new one I'm exporting without any of that offset. So if I go ahead and replace that, and I go back to our game and I simply refresh, well, now our background image lines up with our collisions perfectly. We just need to change our offset a little bit more so that our player is placed directly in the center of our house. So we'll go ahead and make that quick fix, and we can do it pretty easily by referencing our offset object right here. We'll go ahead and add 20 onto this value right here, negative 765, save and refresh. Getting a little closer, let's go ahead and say negative 735. Save and refresh, and that seems to be directly in the center. We can go ahead and say that our player is going to start out right here. So now we need to start detecting for collision. So we have about 185 collision blocks placed within our map, but in order to detect for collision and show you how this works, I think it's better to just focus on one singular block. So we're going to want to go ahead and create one boundary instead of all these boundaries within our boundaries array. And in order to do this, right above animate, we can create a const called test boundary and set this equal to a new boundary. And remember, our boundary takes one argument, which is going to be an object, and it has a property inside of this of position, with an X and a Y. For X, where do I want to place this? I'll just go ahead and say about 400 pixels. And then for Y, I'll place this at about 400 pixels. So now that I have a test boundary created, I just need to make sure that I render it out onto our scene. So what I can do is I can comment out the boundaries for each. That's drawing out 185 boundaries, just for now. And then I'll go ahead and reference test boundary and call out draw. So if I save and refresh that, now we just have one boundary in which we can focus on. So the goal right here is to get our player on top of this boundary, and whenever the two are intersecting, we want to go ahead and console log out some code saying that the two are colliding. But the first thing is, if I begin moving, you're going to see that the boundary moves along with our player. So in order to get the boundary staying still, or at least giving off the illusion as if it's staying still, we're going to want to go ahead down to where we're pressing our keys and make sure we're not moving just our background, but that we're also moving our test boundary along with it. So what I could do is I could go ahead and wrap background position Y plus equal to 3 within some parentheses. That way I can add a new line here. And then I could go ahead and call test boundary, call position dot Y, and then add on to this 3 over time. And if I save, refresh, and hit W, you'll see that stays in place when I go up. But the issue is now I just added this extra line of code, which is pretty similar to the top line of code. So we can go ahead and refactor this a little bit to make adding movable items a lot easier. So right beneath test boundary, what I'm going to do is I'm going to create a const called movables. And this is going to be an array that consists of all the items I want to be able to move on our map. So I know I want our background to be able to move. I'll go ahead and add our background in here. And I also want our test boundary move. I'll go ahead and add that as well. So now what I can do is I can call movables within keys.w.pressed movables, and then call for each on top of that. So for each movable within our array, I can go ahead and call movable.position.y should have 3 added onto it over time. That way I can delete these 2 lines right here. And I know it seems a little counterintuitive because we just created 3 lines of code right here when we had 2 prior. But when we want to add more and more items that should be moved around on our map, well, these lines right here within keys.w.press would just grow and grow. So now we know we're never going to have more than 3 lines right here. All we need to do to add movable objects into our game is add the objects within this array. It's going to be really helpful when we add all of our boundaries into this, rather than trying to loop through them directly within our key event listeners. So now what we can do is we can say for A, S, and D, we want to do the same thing. We're just going to replace these lines with the movables code right here. So I'll copy this movables code, and then I'm going to add curly brackets to each of these statements so I can add more than one line of code within it. And then I'm going to paste in that movables for each. So for each movable, when I hit A, I want to reference position X. And I want to add 3 onto that, and now I can get rid of background position X plus 3. When we go ahead and hold down S, I want to go ahead and reference movable position Y, but in this case, I want to go ahead and subtract 3. I can get rid of background position Y minus 3, and then when I go ahead and hold down D, I want to call movables for each, reference the X position, and subtract 3 from it. And I can delete this last line right here. And now when I save and refresh, no matter which direction I go in, this little square right here is always going to stay in place. So how do we detect for collision now? Well, within our animation loop, right beneath where we're drawing our player, I could call an if statement. What is this if statement going to say? Well, what I want to do is select the right side of our player right here. How would I get the right side of our player? Well, we know the left side of our player, on this side, is going to be our position X coordinate. And if I add on our player width right here, what does that give us? Well, it gives us the right side of our player. We want to say if the right side of the player is greater than the left side of our box right here, then we know the two are colliding from the right side of the player and the left side of our box. We'd want to start off our if statement with player.position.x. That would give us the left side of our player. And then we want to go ahead and get the right side, so we would reference player.width. That would give us the right side of our player, but the issue is we don't actually have a player object. We never actually created a player sprite. We're just drawing out our player directly using the c.drawImage code. So in this case, it makes sense to refactor our sprite class to take into account the c.drawImage method. So what I'll do is I'll comment out this if statement we began writing, and then the c.drawImage right here. I'm going to cut that out. And where we created our sprite class, it's going to be right here. I'm going to paste that in. So to refactor this into a class format, I can no longer reference player image. I want to go ahead and reference the image that was passed through as we instantiated a sprite. So I can get that with this .image. So instead of referencing player image right here for all of these different instances, I'll delete that and say I want to reference this .image instead. So we can go ahead and delete this first c.drawImage right here. We save, we go back to our game, we refresh, and things are all out of sort. Well, one, we lost our player because we never actually created a player sprite in the first place, and our background image is just way off because we affected the sprite code that we used to create our background image in the first place. So one of the reasons our background image is off is because these arguments right here are deciding the crop of the image we're trying to draw out. Our background image should not have any crop associated with it at all. So what we want to say is we don't want to crop it by 1/4 the width. We actually want to crop it by the full width and the full height. So for our background image, this 4 right here should actually be equal to 1. But how do we make this variable so that when we create our player sprite, we include 4 right here as well? Well, this 4 right here represents how many frames are within one of our sprites. So if 4 represents the maximum amount of sprites, that is what we're going to want to add as a property within our sprite class. So as an argument, I'll also add in a frames property and say this .frames should be equal to frames. And when I pass frames through right here, I want it to be an object with different properties associated with it. So now within c.drawImage, I want to say instead of referencing 4, I want to go ahead and reference this .frames.max. This is the max amount of frames we should have within any image we're trying to draw out. But by default, this .frames.max should be equal to 1, so that if we're not using a sprite sheet, well, we shouldn't be cropping anything in the first place. So what we can do is, by default, say our frames argument should be equal to an object with a max property equal to 1. Then we can override this as we pass through a new frames object when we create our player sprite. So now we're cropping the full width of the image by default. If I go back to Chrome, this is what it looks like right now. Because these last 4 arguments right here determine the X and Y position of the image within our canvas map, and then the actual width and height of the image as well. So by default, the position of our image should be whatever position we actually pass through within our constructor function. So these 2 arguments right here are actually only for our player sprite. I'm going to cut these out, paste it beneath our sprite class, and then comment the 2 out for use later. But to replace those 2, I know I want to reference this .position.x. That's going to determine where our sprite is placed on the x-axis. And then I want to reference this .position.y. This is going to determine where it's placed on the y-axis. So for our background, we're saying that our position x should be the offset value of x and y, and those were those -700 and about -400 values. But this will always be different for when we create our player sprite. We do that, save, and refresh. We're getting a little closer, but now the actual width of our image is being divided by 4. We want to make sure this is the full width of our image based on whether we're using a sprite sheet or a singular image. So right here, for our sprite sheet, we need to divide that by 4 because we know we have a max of 4 frames. Instead of referencing 4 for our background image, we want to reference this .frames.max. That's going to make max equal to 1, give us the full width of the image. Save and refresh that. Now our background image is back to normal. But now this sprite class is set up for success to actually draw our player out using the sprite sheet, but still crop everything correctly. So now what we can do is we can go ahead and create a new const of player, set it equal to a new sprite, which takes an object as an argument. And then we're going to have a position with an x, and then also a y. What is x going to be equal to? Well, it's going to be this value right here. This was the x position of our player. We're going to go ahead and cut that out, paste it with x right there, and then for y, I'm going to cut that out and paste it for y. We can get rid of these two comments right here, and now we need to go ahead and add an image for our player sprite. So go ahead and declare I want an image property, and where is the HTML image we created for our player? It's going to be right here. It's assigned to player image. I'll go ahead and copy that, assign it to image, and now we should be able to render this out on our screen. So I'll select our player, go down to our animation loop. Where do I want our player drawn out? Well, I want it drawn out right after our test boundaries. Our player should always be on top, so I'll call player.draw, save, go back to Chrome. And if we refresh, well, something's definitely broken. Let's go ahead and open our console. We can click index.js to see what's going on here. So you'll see when we created our player sprite, we're trying to reference this .image.width, but the thing is, this .image is not available within our main init code. This .image is only going to be available within our sprite class. So we need to take that into account. Where we are creating our player, we can no longer reference this .image.width. We could try to reference player image.width, but now that this is being called right away whenever we run our file, this probably isn't going to be available to us because the image isn't going to be loaded in time. If this is the case, well, it probably just makes more sense to reference a static value. It's just going to be a lot easier, a lot quicker than trying to wait for this image to actually load. So to find the static value of your image, you're going to want to open up your Finder, select your image, and then you can scroll down within Mac and see the dimensions right here. This is 192 by 68. So for our width, I'll replace that with 192. And then for this .image.height, I'll replace that with 68. Save, go back to Chrome, refresh, open this up in full screen. And now our player is rendered out correctly without any errors. But there is the issue where our player is not cropped correctly, even though we just added all that crop code. Why is that? Well, when we created our player sprite, remember, we never added through this new frames property. We want to go ahead and make sure that we add that through, specifically for our player, because we know we're using a 4-frame sprite. So we'll go ahead and reference frames when we create our player, and set this equal to an object with a property of max equal to 4 instead of 1. So that's going to take place within this equation right here where we go ahead and draw out our image. It's going to make sure it crops things correctly. So now if I go ahead and add that in, save, and refresh, now our player is back to normal, exactly where we want them at, but we refactored them into a sprite in which we can easily use to detect for collision. So remember, we were detecting for collision right here within this if statement. We grabbed the right side of our player using our new sprite class, and then we wanted to say if this is greater than or equal to the left side of our box right here, which is going to be test boundary.position.x. We know the two are colliding. So we'll go ahead and console log out, colliding. When that is the case, we'll go ahead and open up our console and then refresh. And we're not getting anything logged out, even though the right side of our player is definitely past the left side of our box. So if we look at this code a little more closely, we have a player.width, but we never actually created that within our sprite class. So that'd be a helpful property to add into this. And you might be thinking, well, can't we use this .image.width? Well, no, we can't really, because remember, our main image is the full width of our sprite sheet. We need to get the width of just one of these guys right here. So it makes more sense to just add a width property within our constructor and set it equal to this .image.width divided by this .frames.max. And now it's important to note that this should only be called when our image is actually loaded. So when we pass through an image, it's going to be stored within this .image, and then we can call this .image .onLoad, which is going to call a function whenever the image fully loads. So whenever this function is called, then we can go ahead and set this property of this.width to make sure that this.image.width is available to us. We can also go ahead and set height in here as well. And we know that our sprite sheet doesn't have any images laid on top of each other or beneath them. So in this case, we can just reference this.image.height, and we don't need to divide this by anything. So if we console log out this.width and also this.height, we should get the height and width of both our background and our player image. So I save, then I refresh, and now we have the cropped width of our player, and we have the full width and height of our background image. And you'll see now our collision code is working. We are indeed colliding, because the right side of our player is greater than the left side of our boundary. But once I move over to the left a little bit, you'll see that's no longer being logged out. But as soon as the two touch again from this side, we're logging this out. So basically, we just need to do the same thing for the three other sides of our box. Now we need to say is the left side of our player greater than the right side of our box, which we can get with the left side of our box position.x plus its width to get the right side. So I'll delete these console logs, scroll on down to where we're detecting for collision. Right here, I want to add an AND statement that says is the left side of our player, player.position.x, if this is less than or equal to the right side of our box. So test boundary.position.x plus test boundary.width, then the two are colliding. If I save, go back to our game, refresh, now by default we're no longer colliding. But if I start moving to the left inside of the box, we start logging out that code, and as soon as I go off to the left side of the box, it's no longer logging. But now the issue is, this is still going to be logged, even though I'm not touching it, but I am in between the left and right side of the box. We need to add that additional collision detection code for the top, and also the bottom of the box as well. So we'll add in an additional AND statement that says, if our player.position.y, that is going to give us the top of our player right here, if this is less than or equal to our test boundary.position.y plus our test boundary.height, then the two are colliding from the bottom of the box and the top of our player. So I save, I refresh, and now when I go down here, that should not be logged, which it is not, but as soon as I touch, it is being logged. Now we just need to add one more side. So we'll go ahead and add one more AND statement that says, if our player.position.y plus the player height, that gives us the bottom of our player right here, is greater than or equal to our test boundary.position.y, then the two are colliding from the top of the box and the bottom of the player. So now that's no longer being logged out, and it's only going to be logged out when the two actually touch. Now it's being logged, it stops when I go off the bottom of the box, and in each direction I go around the box, it's no longer going to be logged until I actually touch the actual box. So that is how we're going to add collision detection. But if we look at our code over here, if we were to come back to this at a later point in time, well, we might not actually know what this represents. So it makes sense in this case to refactor this into some sort of readable function. So what I'm going to do is, beneath movables, I'm going to create a new function called rectangular collision. And this is going to take one argument, just an empty object for now, and we can leave this as is. So within this empty object, I want to pass through two properties. It's going to be rectangle 1, the first rectangle we want to detect for collision with, and then we also want to pass through a second one, which I'm going to call rectangle 2. And then I want to return parentheses, which are going to evaluate this conditional right here. So I copy and paste that into that return statement. Now this is going to return true or false based on whether or not this condition is true. We just need to refactor a little bit based on the properties we're passing through this actual function. So I'm going to select all instances of player and replace it with rectangle 1. Rectangle 1 is going to be representative of our player. And then for test boundary, I'll select all instances within our function right here and reference rectangle 2 instead. So now with this function, we can go ahead and get rid of this if statement down here within our implementation and say if rectangular collision between two objects, what are they going to be? Rectangle 1 is going to be equal to our player object. That is our first rectangle. And then rectangle 2 is going to be equal to our test boundary. If this is true, then we're going to log out colliding. This is a lot easier to read. So if I save that, go back to our game, this works exactly as it did before. It's just a lot more legible within our code and easier to understand. So now that we know this is working with this one singular test boundary, we can go ahead and add the rest of the boundaries into our game. So I'll go ahead and uncomment those, and then I can go ahead and get rid of our test boundary right here. I'll delete where we're drawing it. I'll delete it from within our movables array, and I'll delete where we actually created it. So now I know I'm going to be drawing out all these boundaries. I want to make sure that these are movable boundaries. So I'm going to take our boundaries array and place it within our movables array right here. But I can't really place an array inside of an array for movables to work. I just want all the items within boundaries placed within movables. So if I want all the items placed within movables, I can call the spread operator with ... That's just going to take all the items and place them directly within this array. So we don't have any 2D array stuff going on. And then finally, in order to detect for collision with all of our boundaries, we need to make sure that this if statement is within this boundaries for each, where we are grabbing each individual boundary. So I'll go ahead and paste that in. And then for rectangle 2, I want to make sure I replace this with the boundary we're currently looping over. And now we're only going to log colliding if our player is colliding with the boundary we're looping over. So if I go ahead and save and refresh, all of our boundaries are back. And if I begin moving around our map, you'll see that's only going to log out if I'm actually on top of any of the boundaries in any direction. So we have our collision detection code in place, but now we just need to activate it so that when we're about to collide with a boundary, well, our player is not able to move onwards. So in order to do this, we need to basically predict into the future whether or not our player is about to collide with a boundary. This is saying in the current moment, are we colliding? We need to edit this a little bit to predict whether or not we're about to. So we know when we're holding down W, we're adding 3 onto our movables position, which basically creates the illusion as if our player is going upwards. So if we were to detect for collision between a boundary where 3 is added onto that boundary's position.y, then we would know if we are about to collide with a boundary. So we want to grab the current boundary we're looping over, but we also want to add 3 onto the y position to detect whether or not we're about to collide into it from the bottom of the boundary. So we only want to activate this code when we're actually pressing W on the keyboard. So we're not going to be detecting for collision by default within our animation loop. We want to detect for collision when we hold down W. So we could go ahead and loop through all of our boundaries whenever our W key is pressed. But the thing is, eventually we're going to need to call a break statement that gets us out of the loop altogether. And we can't call a break statement within a dot for each. It just doesn't work. So we need to create a traditional for loop in this case. I'll go ahead and create that with for, create a let of I, set it equal to 0, and then say I want to loop through this as long as I is less than our boundaries dot length. And I want to loop through every boundary, so I'll go ahead and say I plus plus. Now I'm looping through every boundary whenever W is pressed. Now within this is where I want to detect for collision. So I'll go ahead and take this if statement up here, cut it out, and paste it into this new for loop. And now I don't have boundary available to us like I did up here within for each. So I need to go ahead and say within this for loop, I want to go ahead and select the boundary I'm looping over by creating a const called boundary and setting it equal to our boundaries array, which I can grab based on the index we're currently looping over. So I'll add I inside of here, and this is the exact same thing as this for loop. It's just arranged a little differently. And now we can call a break statement to break out of this when needed. So whenever we press W, this is still detecting whether or not our player is currently overlapping with the boundary. We need to predict into the future whether or not we are about to be overlapping based on when our movables are moved by 3 pixels. So to do this, I can say rectangle 2 should indeed be equal to boundary, but I'm going to go ahead and wrap this in an object like so, and then call the spread operator on top of it. What this does is it basically creates a clone of the boundary object, but without overriding the original right here. So I'm creating a new clone of it like this. What I can do is I can go ahead and overwrite the position property by adding this in right here and setting position equal to an x of the boundary's current x position, so reference boundary dot position dot x. And then for y, I also want to reference boundary dot position dot y, but in this case, I want to predict into the future by 3 pixels. So I'll add 3 onto this. So now this rectangular collision function is going to work exactly the same. The only difference being is we're now detecting into the future whether or not we're about to collide because we created a copy of boundary and set its y position should be equal to the current position plus 3. This is how we're going to detect into the future whether or not we're colliding. So if I save this, refresh, and I go up and hold down W, you're going to see right about there, we went ahead and logged out this code. This code is only going to log when I hold down W anyways, but there were 10 instances in which I was about to collide with this boundary right here. So when we call this for loop right here, we're looping through every single boundary within our map, yet we're only really colliding with this one boundary right here. So we know when we collide with any boundary, we want to stop our background movement altogether. We do not want to detect for collision with any other boundary that might be remaining. including these boundaries over here, because if we detect whether or not our player is colliding with these boundaries, well, it's going to return false. We don't want that. We want to break out of this loop as soon as we detect we're colliding with something. So as soon as we are indeed colliding with something, we're going to go ahead and call break. And I also want some sort of let that changes within this, so I can use an if statement right here that says if we collided with something, we do not want to move our background. We don't want to move any of our movables. So for each frame of our animation loop, I'm going to create a let called moving. By default, I'm just going to set this equal to true. And then what I want to say is if we're about to collide with something, moving should be equal to false. So for the movables down here, I only want our movables moved if moving is true. So we hold W, we're about to collide with something, we set moving equal to false, we break out of the loop because there's no point in detecting for collision with any extra blocks. Then based off this value, we're going to decide whether or not our movables should actually move. So if we save and refresh, and we try colliding with the bottom of one of these blocks by holding down W, you're going to see we can no longer go past it. I'm holding down W, you'll see we are logging this out, but I'm not allowed to go past the block, and if I go ahead and hit S, well, I'm allowed to keep going downwards, but that adds the collision in place for the bottom side of our block. That is how we're going to want to add that in. So now we just need to do the same thing for when we move to the right and the left of the blocks, and also when we move down on some of the blocks. So the quickest way to do this is to copy all of the code above movables.forEach. So starting with this if statement right here, all the way to our for loop. If I go ahead and copy this, and then within our else if, where we're holding down A, paste it in, and save, we're looking to be in pretty good shape. The only thing we have to change right here is when we hold down A, we know we are changing our position.x by 3. We want to predict into the future whether or not we're about to collide when position.x has 3 added onto it. So we want to go ahead and get rid of this +3 for y, and our player should stop moving when we collide with the block when we hold down A. Hold down A, we're no longer colliding on the right side of blocks and the left side of our player. Simple enough. Let's do the same thing for when we hold down S. I'll go ahead and copy everything from if to the for loop, and then within this new else if, where we're holding down S, I'll paste that in, save, and then what do I need to change? Well, our movables are going to be moving on the y-axis by -3, so I don't want to change x here. I want to predict into the future, y, -3, save and refresh, and now when I go down on one of the blocks, we stop completely, which is great. Now I just need the same thing for the very last else if. I'll copy from if all the way to the for loop, and then within this last else if, when we hold down D, I know I'm testing for collision when we subtract 3 from x, so here I'll subtract 3 from x and then save, go back here, and now when I go to the right, I can no longer go past the left side of a boundary. So that's how we're going to add boundaries into our game in which we cannot travel past. And the cool thing is, if we want to hide these boundaries and make our game as realistic as possible, make sure that this is production ready, we can go up to our boundary class, which is going to be right here. In our fill style, we can declare we want this to be RGBA. This is going to take 4 arguments. For red, we can set this to 255. For green, we can set this equal to 0. For blue, we'll set this equal to 0 as well. And this A right here stands for alpha, so if I were to set this to 0.2, you're going to see we get an opacity similar to like what we had within tiled. If I refresh, now we can see everything behind the blocks, but if we want to go ahead and make this as realistic as possible, we'll set this equal to a pure 0. So now the blocks remain in place, but we can no longer see them, but they still function as expected. We can no longer go past those blocks when we try moving off the edge of our map, and that is exactly how we want to add collision detection to this whole map we created. So with that, we can successfully check off player to map boundary collisions. Alright, so let's go ahead and move on to foreground objects. So remember, the foreground objects are those objects we drew out in tiled, so that when we go ahead and move past a building like this, well, our player isn't drawn on top of it. We want to make sure that those foreground objects are layered on top of our player right here, and it's going to give off the illusion as if our player is traveling behind this building rather than on top of it. So you're going to see within tiled, we created a layer for our foreground objects. So if we go ahead and turn off every other layer, so battle zones, collisions, or objects, we just keep going down the list. So let's turn off flowers, plateau, trees, 3, 2, 1, and then island and ocean. You're going to see that this consists of our foreground objects. This is everything that our player should be able to travel behind. So what we want to do is just export this as one large image, but when we export it, we want to make sure that we also zoom in right here at 400% because that is what our background image was exported at. So now that we're zoomed in at 400%, we can go up to File and then Export as Image. So here we want to make sure that we only include visible layers and that we use the current zoom level. Then we're going to want to browse for where we're going to save this. So this is already within my Pokemon game directory. I'll go inside of that and then go inside of image. And then what do I want to save this as? Well, I don't want to save this as Plateau because that is our main background image. Instead, I want to go ahead and save this as Foreground Objects. And then I also want to save this as a PNG. So I'll add a .png to the end of this. And then I can go ahead and hit save, export. And now that's going to export that image into our project. So if I go back to Sublime Text, you're going to see within our image directory right here, now we have foregroundobjects.png. And this is a really large file, so in order to actually see this image, I have to scroll on over to the right and maybe even down, and you'll see this is what the image consists of. So now that we have this image in place, we just need to import it into our game, and then render it as the very last thing within our render queue. So to create this foreground image, we're going to go ahead and do so as a sprite. So if we go ahead and scroll on down, right here on line 91 for me, this is where we are creating a new sprite, which is set equal to our background image. We want to do the same thing, but just using our foreground image instead. So I'll go ahead and copy these lines of code, and right beneath it, I'll go ahead and paste in another instance, and instead of referencing background, I want to reference foreground. So now what do I need to do? Well, I need to assign a new image to this image property. Now, where did I create this image in the first place? It's going to be right up here. So you'll see right now, some of our implementation is getting muddled in with our classes. It's kind of hard to find exactly what we're looking for. So in this case, I want to go ahead and refactor our classes into a separate file. So to do that, we can go to File, New File, and then I'm going to save this as classes.js, and we can just store this within our project root. So I'll go ahead and hit save with that. Now we have a new file in which we can put our classes in. So I'll just go ahead and take both of our classes, this class sprite, cut it out of index.js, paste it within classes.js, and then back within index.js. I know I also have this boundary class. I want to go ahead and take that and paste it within classes.js. So now with both of these saved, I just want to make sure that I import classes.js into index.html. So in order to do that, I can copy the script tag right here, paste it above, and then instead of referencing index.js, I can go ahead and reference classes.js, and I need to make sure that classes is being imported before index.js, or else we won't be able to read those classes within index.js. So if I go ahead and save this and refresh our game over in the browser, you're going to see this still functions as expected because we imported our classes correctly. But now that makes index.js a little more clear for us because this is purely related implementation now, not class design. So previously we were looking for where we were creating our background image, and it was going to be right here. So in order to create a foreground image, I can copy these two lines of code, right beneath it, paste in those two lines, and then I know I'm not referencing just a const of image, I'm referencing a const of foreground image, like so, and then I want to change the foreground image's source equal to our foreground objects.png. So I'll go ahead and select that, foreground objects.png. So now that foreground image is available to us, what I can do is I can copy this, and then where I actually created this new sprite for our foreground, I want to make sure for our image property, I reference our foreground image. So if I save that, now we have a foreground sprite, but I still need to render this out within our animation loop. So like I said, we want to render this as the very last thing. So we're rendering out our background, we're rendering out our boundaries, and then we're rendering out our player. We want to go ahead and render out our foreground as the very last thing by calling foreground.draw. So if I save, I go back to our game, and I start moving, well, you're going to see that our foreground images are in place and they're moving along with us. So if we ever want our foreground objects to actually move, well, we want to make sure that we add this foreground object into our movables const right here. So if I go ahead and add that in, like so, then save and refresh, all those movables are going to stay in place, but the cool thing is, when I go ahead and walk past this house right here now, you're going to see that our player is placed behind the house, giving off the illusion as if we're actually traveling behind it. And this is going to work for every object in which we created within that foreground layer. You'll see right here for the trees, we can now travel behind them. And then there's going to be a tree on the far right over here that we can travel behind as well. It's going to be this tree right here. We can travel behind that. And we can even travel behind some of these fence posts. So that is why we create that foreground object layer within Tiled. It's simply so we give off the illusion as if we can travel behind objects, which are supposed to be laid out in front of us. So now looking at to-do, we can successfully check off foreground objects. Next up, we're going to add in player movement animation. So when we move our player, yes, we can move, but we want to give off the illusion as if our player is walking. So to do this, we're going to be adding some sprite sheet animations, and thankfully we already imported those sprite sheets, so it's going to make this task a lot quicker. To recap, currently we're only rendering out this first instance of our sprite, but eventually what we want to do is take this crop rectangle, move it over to the side by 1, and then render out this instance of our sprite. And we're just going to keep doing this over time. We're going to keep moving this over and over through the sprite sheet until we go back to the beginning, and it's just going to loop through these over and over again to create the illusion as if our player is walking, but we're just pushing this crop mark through our sprite sheet. So to add this animation, we're going to want to go to classes.js, and this is where our sprite class is now going to exist. And we're going to want to hone in on this 0 value right here. This is the second argument of c.drawImage, and this is the x coordinate of our crop position. So this coordinate right here, the x position of our crop, refers to this right here. This is the x position of where we are currently cropping our player. So if we were to go ahead and change this to something like 48, we would push this crop rectangle 48 pixels to the side like this. And then 48 pixels would be the new coordinate right here, which means we're just rendering out this instance of our sprite. So what we want to do is we want to iterate this value through 0 to 48 to 96. And what is 96 plus 48? I'm not sure, but we want to go ahead and iterate this value right here in increments of 48 because our main image over here is actually 192 pixels wide, as we can see right here. That divided by 4, 192 divided by 4 is 48. So we want to go ahead and push our crop mark over to the right by 48 pixels for each frame we actually render our sprite out in. So what I want to do here is track the frame our sprite is currently on. We currently have a framed object, but right now it only has one property, which is going to be max. So if I want to go ahead and add properties onto this while still allowing the user to pass through an argument right here, what I can do is I can assign this.frames equal to an object with frames inside of it, and then I can call the spread operator on top of this. And then any properties I know I want added onto this object by default, I can add next to ... frames. So I'll add a comma right here, and then what property do I want to add onto this .frames? Well, it's going to be val. That stands for value, and it's quite commonly used in frameworks like Vue and React. So our val by default for frames is going to be 0, but this val over time is going to go from 0 to 3. So if I go ahead and reference this .frames, .val right here for our x coordinate, everything is still going to render the same because by default this is going to be equal to 0. But over time, if I go ahead and increase this up to 3, well, we're going to go ahead and change the x coordinate from 0 to 1 to 3. But the first thing we need to do is make sure that we're incrementing this value right here over time. So after we draw out our image right here, I'll go ahead and reference this .frames.val, and I want to go ahead and say plus plus. This just means we're adding 1 onto this for each time we call draw. But I don't want this to go past this .frames.max because otherwise we would just be rendering out a portion of our sprite sheet that doesn't exist. So what I want to say here is if this .frames.val is less than this .frames.max, then I want to go ahead and add 1 under this .frames.val. So over time this should iterate through 0 and 3. But what happens if this .frames.val is actually greater than 3? Well, else I want to go ahead and set this .frames.val equal to 0. So by default, this .frames.val will be equal to 0. That means we render out the first instance right here, but once we go past this draw image code, we're going to say if this is less than this .frames.max, which this .frames.max, in our case, is equal to 4. So 0 is indeed less than 4, then we're going to go ahead and call this .frames.val plus plus, which just means the next time we go ahead and render out this .frames.val, we're going to be moving this over to the side to the next instance of our player. But the thing is, when we reference this .frames.val on the second iteration right here, it's going to be equal to 1. So really, we're just moving over our crop mark by 1 pixel. It would be something like right here. We want to make sure that we multiply this .frames.val by 48, and that'll push our crop mark over by the full amount to render out the next image. So we'll go ahead and multiply this .frames.val by 48, which in reality is going to be the width of our sprite. So this .width. And that should get our crop moving over fully to the right. Then on this iteration, 1 is less than 4, so we'll call it again. Go through the next iteration, where val is equal to 2. This gets pushed over to the right by another 1. And then we go through the next iteration still because 2 is less than 4. So now val is equal to 3. 3 is still less than 4 in this case. So we go ahead and add val again. And then finally 3 is still less than 4, so we'd add val onto that one more time. And then in this case, this .frames.val would be equal to 4. But if we think about this, 4 times 48 is going to be equal to 192. So if we were to go ahead and move our crop mark all the way to 192 pixels, that would be the full width of our image over here. That means our crop mark would be off to the right. We wouldn't actually be rendering anything out. So in reality, we never want this .frames.val to actually be equal to 4. We only want it equal to 3 so that our crop mark cannot go past this very last point in our sprite. So to get that effect, right here, we'll simply subtract 1 from this.frames.max, and then when this.frames.val is equal to 3, we know this.frames.max minus 1 is also going to be equal to 3 as well. So we're not going to call this if statement, we're going to call else, resetting this.frames.val to 0, which means that our crop mark is going to go back to the very first sprite and restart the process. So we go to the end and then come back to the beginning. So if we save all of this code, go back to Chrome and refresh, you're going to see our player is essentially on hyperdrive. They are running super fast. We're looping through all of our animations. There's no stutter. There's nothing missing. But this obviously looks very goofy. We want to go ahead and slow this animation down so that we only move through our sprite sheet for something like every 10 frames rather than every frame within our animation loop. So what we'd do is we'd wait for 10 frames, then we go to the next one, wait for 10 frames, go to the next one, wait for another 10, go to the next. It's going to slow down our animation so it doesn't look like we're constantly running like we are down here. So what we can do is onto our frames object, we can add an additional property, and this is going to be called elapsed. This is the amount of frames that have elapsed over time since the creation of our sprite. And by default, this is going to be equal to 0. Within draw, we want to go ahead and say if this.frames.max is greater than 1, meaning that we have a sprite sheet in place and we should be animating the sprite sheet. Then I want to select this .frames.elapsed and add 1 onto it over time. Then we want to say whenever this divided by 10 is equal to 0, then that is when we're going to call the following conditionals right here. So beneath this, I can write an if statement that says if this.frames.elapsed divided by 10 using the modulo operator is equal to 0, this just means if the remainder of this equation right here is equal to 0, then we're going to go ahead and proceed with the following. I want to call these two lines right here. So if I save and refresh that, now you'll see we have a perfect walking animation in place. And this is much more realistic to that speedrunning effect that we had earlier. So we only want to move our player right here when we're actually pressing down on a key, making our background move. So what we can do is within our sprite class, we can add an additional property called this.moving. By default, this is going to be equal to false, but now whenever we press down on a key on our keyboard, such as WASD, we want to make sure that we set this value equal to true. So now within draw, we can call if this.moving is equal to true. Then we want to go ahead and call all the code within this if statement, which is going to give off the animation as if our player is moving. But right now, we're creating a lot of indentation using these if statements, so a way to clean this up a little bit is to get rid of that last curly bracket and this first curly bracket for if this is moving. And instead of using curly brackets and wrapping everything right here inside of it, we can just return if our player is not moving. So we're saying whenever we call draw, if our player is not moving, if this value is equal to false, then we're just going to call return, which means we do not call any of the following code. This right here is the exact same thing as using the bracket formation we have right here. It's just a little cleaner because we don't have that much indentation, and it's going to make our code a little bit easier to read in the future. So now we just need to set this .moving equal to true whenever we actually press down on our keyboard. So within index.js, where are we actually moving? Well, we're moving whenever we press down one of the W keys, one of the A keys, S, or D keys. So within this if statement right here, I can grab our player and set moving equal to true. So if I save this, and go back and refresh. Now we start off stationary, but if I hit W, we're going to start moving. But if I let go, we're still moving, unfortunately. So we need to make sure that we're always setting this equal to false if we're not moving, and we know we're not moving if we're outside of this if statement. So we can grab player.moving equal to true, and right above this if statement, I can say, by default, this is always going to be equal to false, and we're only going to set it equal to true if we're pressing down a certain key. So if I save and refresh that, if I start hitting W, now we're moving, but if I let go, we stop moving, so perfect. Now we want to make sure that we set player.moving equal to true for each key we're listening for. So with an A, I'm going to paste in player.moving equal to true. With an S, I'll paste that in as well. And then finally within D, I'll also paste that in. So now no matter what direction I move in, we're always going to be moving, and then when I let go, we stop. So we basically created a nice animation that only activates when we actually press down on the keyboard. The very next thing we want to do is switch between our sprite sheets. So when we move in a direction such as left or right or up, we actually change the direction in which our player is facing. So if we look within Finder, we have 4 different sprite sheets for our player already imported. We have player down, player left, player right, and player up. Now all we need to do is swap out our main sprite sheet for our player based on whatever directional key we are pressing. So if we look within classes.js, we're currently only importing one image, but we might want to import multiple images specifically for transitioning between sprites. So within our sprite constructor, I'm going to add an additional argument called sprites. And by default, this will be equal to an array, and then I'm going to assign this.sprites equal to sprites, whatever we pass through as an argument right here. So when we're actually creating our player in our implementation up above, it's going to be right about here. On line 41 for me, now I can pass through a sprites property. What do I want to set this equal to? Well, I want to set this equal to 4 different images to represent our 4 different sprite sheets over here. So I'm actually going to create an object for this, and inside of this I'm going to have up, and I'm going to set that equal to the image where our player is facing up. So I know I need to create this image. I'll go ahead and select where we're creating our first player image, copy that, paste it in, and then I'm going to go ahead and change this to player up image. And now I know this references player up, not player down. So now I have this player up image available to me, which I can now use within sprites up. So I'll go ahead and assign sprites up equal to player up image. And now I want to do the same thing for our 3 other directions. So go ahead and copy and paste this 3 times. And now let's focus on left. We need to create a player left image. So go ahead and copy these 2 lines right here, paste it in, and then say I want a player left image. And this will reference player left. So now I can use this within our sprites object, paste it in, and I just want to do the same thing for these other 2 objects. So I want you to go ahead and pause the video and try filling in these other 2 objects by creating new images and referencing the remaining sprites we have over here. So once you've given that a go, let's go ahead and do it ourselves. Let's go ahead and copy these 2 lines right here, paste them in, and say we also want to reference player right image. And this will reference player right. So now I can go ahead and take this image and say I want a property of right, which has player right image assigned to it. And then finally I have one for down. And this player image down is just basically player image. This is the very first player image we imported into our game. So I'm going to rename this, not player image, but player down image. And then I know this is already taking in player down. So now I can go ahead and use this constant right here to say for our sprites down property, I want that assigned to player down image. So now if we console log out our player, go back to our game, refresh, and open up our console, you're going to see we're getting an error. Player image is not defined on line 55, which is going to be right here. So for our main image, we also need to make sure that we swap this out with our player down image because we just changed the constant name. And I believe that is the only other place in which we need to change that. So if we save and go back and refresh, now our game is back to normal. And we can look within console and check out our sprite and see now we populated the sprite's object with 4 new images. All these images are representative of the 4 images we actually imported into our game. So how do we actually swap between these sprites whenever we move in a different direction? Well, we're going to want to go back to our directional code. It's going to be down here. Let's start off with W and A. So we know we're declaring player.moving equal to true, but right here we can also say that our player.image, this is the image currently being rendered out on the screen. Whenever we press W on the keyboard, we want this equal to player.sprites.up. And that's really all we have to do. So if I save that, go back to Chrome and refresh and hit W, now we're facing up and doing the upwards animation because we're looping through player up instead of player down right here. And since all these 4 images right here are exactly the same width and height, while all of our crop code works perfectly to instill that new animation in place, all we need to do now is change the direction for our other keys. So I can take this line right here, and then whenever we press down A, we know that our player should be moving to the left, so we'll reference player, sprites, left. Then when we press down S, we should be moving down, so we'll reference player.sprites.down. And then finally for D, we know we should be moving to the right, so our player image should be equal to player, sprites, right. I save that, I go back to Chrome, and now if I go ahead and hold down S, we have the down animation. If I hold down D, we have a right animation. If I hold down A, we have a left animation. And if I hold down W, we have an up animation. So that is how we're going to add an animation to our character to give off some realistic movement as if we're in a real Pokemon style game. So with that, we can successfully check off player movement animation. Okay, so now it's time to go ahead and code battle sequences. So these are the battles that occur whenever we walk over some patch of grass, and eventually we're going to stop our character, activate that battle scene, and then we're going to create some fights between some monsters. So we know currently that this battle zone right here is part of our background image, but what we need to do is import from our tiled layers little tiles that fill up these battle patches. Then when we walk over one of these little tiles, well, we're going to give ourselves the ability to actually activate some sort of battle. So how would we even go about creating these battle tiles within tiled? Well, obviously we'll want to go back to tiled, and we're going to want to make sure that we pretty much turn on every single layer that we have here. So I'm going to go ahead and go through my whole island, making sure every layer is turned on, except for this Battle Zones layer. So if you decided to import my map, this Battle Zones layer is going to be here by default, but I want to show you how to do this from scratch, just in case you need this functionality within your own map. So really what I can do here is I'm going to delete this layer. I'm just going to select it, then hit delete, and that takes care of that. And now I want to go ahead and recreate it. So how would I recreate that layer? I'd simply right click on my layers tab over here and hit new tile layer, and I'm going to call this layer Battle Zones. So these are the zones in which our player can walk over to initiate a fight. So in order to create a battle zone, well, all I need to do is draw tiles the same way I drew collisions. So if we look at just collisions right here, we know that all of our collisions are these little red tiles. We want to go ahead and say that our battle zones should also be little red tiles. They could actually be another color to help you differentiate on your map what is a battle zone and what is a collision. But in our case, it doesn't really matter if we use the same color for both battle zones and collisions. So what I want to do here is I want to go ahead and select from our collisions tile set our little red tile right here. Make sure that I have battle zone selected. And then I'm going to select our brush tool up here. And then I can just brush on over every area in which I want a battle to potentially start. So it's going to be these little green patches that I draw on my map. So there's one right here, and then there's going to be one over here as well. So I'm just going to go ahead and cover that whole area with little red collisions, which are actually going to be battle zones. And that is pretty much all we need to do to create these battle zones within tiled. But if we want to go ahead and import these into our game, well, first we're going to have to export this battle zones layer. So remember, to export things, we have to go to File, and then Export As. And before you even go to export as, you're going to want to make sure you save this. You can see I haven't saved it up here, indicated by this little asterisk. If I just hit Command S, that's going to save. And now I want to go to File, Export As. And then remember, we want to go ahead and export this as a JSON map file. So I'll go ahead and say that this is going to be Pellet Battle Zones. And then I'm just going to save this within my downloads folder. That's kind of my temporary folder stuff. So I'm just going to hit save. And now within Finder, I want to go to my downloads folder. And you'll see this is where it is. So I want to go ahead and open this up within Sublime Text. So I'll grab that file, drag it on top of Sublime Text, and now you'll see this is all the data associated with our map. So even though we exported this as PelletTownBattleZones.json, well, it's going to include all the data to our layers. So we need to make sure that we search for battle zones. So I'm going to hit Command F within Sublime Text to open up my search bar, and then I'm going to search for battle zones. So once we find battle zones down here, we want to go ahead and take the data object associated with our battle zones. So I'll go ahead and grab everything where data starts and go on down to where data ends. And if we look within this data set, you'll see all these 1025s. This is where our battle zones are supposed to be placed within our map. So if we copy this, we can now minimize our battle zones. And then within our project, you'll see we already have a data folder which contains our collisions. Now we want to go ahead and create a file specifically for our battle zones. So what I can do is I can go to File, New File. That's going to open up a new file right here. And then I can create a const called battle zones and set it equal to that array that we grabbed from that data set. So now we can hit Command S to save this. And I'm going to save this as battlezones.js. And by default, I have an auto formatter on for my JavaScript, so that went ahead and auto formatted this, so everything is laid on top of each other. It doesn't really matter. This probably isn't the best for file size, but it is okay in our case. Yours is probably going to be laid out next to each other. That's actually better. So ignoring the format of this, now we know we have a const of battle zones assigned to an array. So now what we can do is we can go to index.html and say, right above our data/collisions, we also want to import our battle zones as well, and make sure you get this uppercase Z in there, or else this won't import correctly. So once we save that, we'll head over to index.js, and at the very top, we're going to want to go ahead and console log out the const of battle zones that we created within that file, just to make sure that it's being imported correctly. So I'll go ahead and console log out battle zones like so, and now within Chrome, we can refresh, right click, inspect, Go over to console. Now you'll see we have an array full of data, which is going to be all the data related to where our battle zones should be placed. So to create some battle zones, well, a battle zone is just the same thing as a collision tile. So we're going to want to follow the same steps that we used to parse out our data within collisions into canvas rectangles. So to start, what we can do is we can copy these 4 lines of code right here related to our collisions map. And beneath it, we'll just paste out a new version. But we're going to be editing our const names, and we're also going to be editing our for loop quite a bit to get this working with our battle zones rather than our collisions. So to start, remember, we want to go ahead and parse all of our data from battle zones into a 2D array. So to create that 2D array, we're going to create a const called battle zones map. So this is going to be the root of our 2D array. And then we want to loop through all of our battle zones instead of our collisions. We can go ahead and keep I the same because the width of our actual map has not changed at all. And now as we loop through our battle zone data, we're going to want to go ahead and select our battle zones map right here, not our collisions map, and push into our array subarrays sliced from 0 to 70, which increment over time based on our iterator right here. So if we did this correctly, if we console log out battle zones, map like so, save, refresh in Chrome with our console open, you're going to see we have one array which contains 40 subarrays. But you're going to see we don't have any of these arrays populated. If I open them, well, the array length is equal to 0. So let's go back to our code. And on inspection, we need to make sure that we are pushing in data from our battle zones dataset, not our battle zones map, because by default this doesn't have anything inside of it. So we want to make sure we're selecting the array that actually has data inside of it, which is battle zones. So right here, we want to push in battle zones and then slice I through 70 with this battle zones array. Let's save and refresh again. Now you'll see each subarray is populated with all of our data related to where our battle zones should be placed. You kind of see this creates that exact rectangle in which we want our player to activate battles in. So we did that correctly, and now we're going to want to go ahead and, based off of that 2D array, start pushing in battle zone tiles into a battle zones array. So in this case, what we'd want to do is create a const of battle zones and set this equal to an empty array to start. This is going to contain all the battle zones objects, which are really just going to be boundaries. So we can go ahead and reuse this boundary class and push them into our battle zones array. Now one issue right here is we're trying to declare a const of battle zones, but if you look up at the top, we already imported our battle zones const from our JS file of battle zones. So in this case, it makes sense to either change our battle zones data const name or our battle zones array down here. Personally, I think it makes sense to keep battle zones the same right here so we can use it within our implementation using a name that actually makes sense. So what I'm going to do is, over within BattleZones.js, I'm going to rename this BattleZones data instead, and I think that's a little more representative of what we're looking at here, so I'll save that. Now within index.js, I can console log out BattleZones data, and any place that I just use BattleZones, like right here and right here, I want to go ahead and replace those with BattleZones data, and now I can use the const of BattleZones down here without that interfering with this object up here. If I save and refresh, everything still works and everything is still console logged out correctly. So now we're going to want to go ahead and reuse some of this code right here, where we looped through our 2D collision map and pushed in boundaries based on the indices of our rows and our symbols. So here I can go ahead and copy all this code, and beneath our const of battle zones, I'll paste that on in, and now instead of referencing collisions map, we know we created a battle zones map, and pushed in all the associated data. So instead of referencing collisions map right here, I could say, for each battle zones map, for each row within that battle zones map at least, we're going to loop through each row, grab whatever symbol we are currently looping over, all that is fine, and then we know if our symbol is equal to 1025, which if we look within our battle zones data right here, if we search for 1025, that is the only symbol within this array. Then we want to push in a new boundary, but not into our boundaries array, but rather our battle zones array. And based off of that, our battle zones should be placed perfectly based on the indices of each row and the indices of each symbol in which we are currently looping over. So if everything goes according to plan, we can console log out battle zones like so, and it should contain a bunch of different boundary objects, which it does. It contains 26 different boundary objects in which we can now render out on the screen in their correct position. So to render these out, we'll go on down to our animation loop, which is right here. Now where do we want to go ahead and render out these battle zones? Well, right beneath our boundaries, we can go ahead and reference our battle zones array, and then say, for each battle zone within our battle zones array, what do we want to do? We want to call the battlezone.draw function because we know this is just a boundary object, which is shared with our boundaries up here. So if we save that, go back to our game, close out of our console and refresh, well, we're not seeing anything just yet because if we look at our shared boundary class within classes.js, scroll on down, you'll see that we set our fill style for our boundaries to be 0. So let's go ahead and turn this back on. I'll set it equal to 0.5. Save and refresh, and then you'll see we have our boundaries drawn out. This is what we can and can't run into. So move to the right, can't run into that, can't run into that either. And now you'll see we have our battle zones separate from all of our boundaries. Only issue is right now is obviously this isn't staying in place. That just means we need to put our battle zones within our movables array. So back within index.js, where is our movables array? It's going to be here on line 123 for me. Same thing we do with boundaries, since we want to put all of our array objects inside of here. I'm going to go ahead and create a comma after foreground, and then use ... battle zones to say all the objects within battle zones should be placed directly within our movables array. So if I save that, refresh, now when I move, you're going to see that our battle zones stay in place. So now what we're going to want to do is detect for a collision between our player and these battle zones. So if I were to walk over this right now, well, that's totally okay because our battle zones are separate from our boundaries. But we do want to detect for a collision so we know that when these two are touching, we have the possibility to activate a battle. So to detect that these two are touching, we're going to want to reuse the same functionality we used for when we were pressing down one of our keys, specifically this for loop and this if statement with rectangular collision. And it makes sense to only detect for a collision between our player and these battle zones when we're actually moving, because we should only be able to activate a battle when we're moving in the first place. In the traditional Pokemon games, a battle is not activated if you're just sitting still in a spot. You have to be moving in order to activate that battle, so it makes sense to put this collision detection code also within our if statements that listen for when we're pressing down W, A, S, or D. So here we can keep our collision detection code the same, but we do want to duplicate this for loop, and beneath it, I'm going to paste in a new instance of it. We can keep a lot of this for loop the same, but we are going to want to loop through our battle zones rather than our boundaries, and now we're going to be selecting not a boundary but a singular battle zone as we loop through this. To select a singular battle zone, well, we need to select our battle zones array, and now we can get that singular battle zone based off of this I index. And then we want to detect for a collision between our player. We don't need to predict into the future whether or not we're colliding with a battle zone, so we can go ahead and get rid of the spread object right here and just say we want to detect for a collision between our player and the current battle zone that we're looping over. Now we don't need to set moving equal to false when we're moving through a battle zone because we don't want to stop our player, so we can delete this line right here. We are going to keep a break though, because there's no point of running through the rest of this loop. If we're colliding with one rectangle, that means we know we're probably not colliding with another one, so we'll just break out of this for each frame in which we're actually colliding with a battle zone in the first place. But we do want to start just by console-logging out battle zone collision to make sure that this code works in the first place. So if I save that, go back to our game over here, open up our console, and I'll move it over to the side so we can see things better. Now, you'll see if I begin walking into our battle zone, well, nothing's being console logged out, but if I go ahead and move from the bottom up, you're going to see we have a battle zone collision in place. We know we're only colliding with that battle zone when our player is actually on top of these tiles. So this code does indeed work, but it would be a little tiresome and a little annoying to have to go ahead and copy and paste this into each conditional, because no matter which direction we move, we know we should be detecting for collision between our player and battle zones. We don't need to go in a certain direction. We can go up, we can go left, we can go right, we can go down. This code should be running as long as we're pressing down one of those keys. So rather than copy and paste this code into other versions where we're pressing down a different key, what we can do is, above these if statements where we're listening for key presses, we can say if keys.w is pressed, or keys.a is pressed, or keys.s is pressed, or keys.d is pressed. If any of these are pressed down at any point in time, we can go ahead and call this code right here that loops through our battle zones and say, hey, as long as these keys are pressed, we want to go ahead and detect for a collision between your player, the battle zone, and if so, we're going to console log out this statement right here, independent of which key you're currently pressing. So we'll go ahead and cut this for loop out from where we placed it previously, and now within this new if statement, we can paste it on in here, and we'll go ahead and save, refresh, and now, no matter which direction we move over a battle zone, well, we should be logging out the text battle zone collision. So let's start moving down, and now as soon as I touch this battle zone right here, you're going to see we start logging that out. And if I move to the right, it's still being logged out. If I move to the left, it's still logged out. And if I move up, well, it's still logged out, but only when I'm actually on top of the battle zone. All our other collisions still work, but this code works perfectly for making sure we know whether or not we're touching one of our battle zone tiles. So this is a really good start, but if we were to activate a battle using this code right here, well, one of the issues that would occur is, well, we're still technically touching our battle zone, even though our player is way up here above it. So technically we could activate a battle when it looks like our player is above the battle zone, and it might make the player a little annoyed or confused to know, well, a battle was activated even though I really wasn't on top of the grass. So what we're going to want to do is determine whether or not our player is actually on top of the grass. And to do this, we're going to need to use a little bit of geometry. So here's what we're going to want to do. We're going to want to get the area associated with our player, and also the area associated with one of the tiles of our battle zone's block. After we get those areas, we're also going to want to get the areas of this little intersection that was created by these other two areas intersecting. So we want to say if the area of intersection is something like 25 or 50% the area of our player, then that is when we're going to want to activate a battle. But if our player moves up to something like right here, and the area of intersection right here is minuscule, then we're going to say, well, even though the two are colliding because they're touching, well, a battle should not be activated. So it's really important that we find the area of intersection between these two rectangles and then compare it to the actual area of our player. And based on how big this intersecting rectangle is compared to our player, that is when we're going to want to go ahead and activate a battle. So let's start writing this out. We know whenever our player collides with a battle zone, yes, we want to go ahead and activate a battle, but we only want to do this if some other condition occurs. So what I can do is I can begin writing out that condition with an AND statement that says if our overlapping area is greater than our player's area, which we can get by multiplying our player width by our player height, divided by 2. The reason I'm dividing this by 2 is our player width right here and our player height, when we multiply these two together, well, that's going to give us the entire intersection right here of our player. So if we were to do this without divide by 2 right here, what we're effectively saying is, well, the overlapping area, which is everything within this overlapping rectangle right here, needs to have a greater area than the whole area of our player over here. So this is really small, this is really big. There's a potential that this if statement might not even occur based on how big our player is. But if we go ahead and divide this by 2 as well, we're essentially going to cut our player area in half, which means we're only going to care about this bottom portion of our player down here. So now there's a much greater chance that this overlapping rectangle area will be greater than the area associated with the bottom half of our player and not the top. So that is why we're dividing this by 2, is to give us more of a chance in which we can actually call a battle zone collision. It's going to force our player to be at least halfway over our collision blocks rather than fully on them, and it's also going to make sure that a battle isn't initiated when our player is traveling along the edges of our battle zones. So this code right here will work, but one issue is we need to create this overlapping area constant. Well, we're going to want to start by creating a const called overlapping area. So this is going to be associated with this, and this is going to be equal to the math.max of 2 values. So whatever values we put inside of math.max, this is going to return the one that is the greatest. So what values do we want to put within math.max? Well, to start, we want to go ahead and determine, out of the 2 rectangles we're detecting for collision for, which of them has a greater x value on the left side. Well, if we look at this, the left side of our player is going to be right here, and the left side of our boundary is going to be right here. And if we assign values to these, we'll just say for the left side of our player, hypothetically, this is going to be a value of 0 on the x-axis. And then for our battle zone, hypothetically, this is going to have a value of 20. So which is greater, the left side of our player at 0 or the left side of our battle zone at 20? Well, obviously it's going to be 20, but we do need to test for this for each time our player is moving through these battle zones. So here, within math.max, we want to grab the left side of our player, and we'll get that with player.position.x, and then we want to add a comma and also get the left side of our battle zone. So we'll go ahead and reference our battle zone, and then get position.x for our battle zone. So now we're determining which has a greater value, our player position x, which is this right here, or our battle zone position x, which is this right here. In this case, it's going to be battle zone position x, so we can go ahead and say math.max is going to return 20 over here. Now we're going to want to add onto this a math.min math.min function. Whatever values are within math.min, we're going to go ahead and get the smallest result. So for math.min, we want to go ahead and plug in the right side of our player and the right side of our collision block. Hypothetically, we can go ahead and say that the right side of our player is going to have a value of about 25, and the right side of our collision block is going to have a value of about 40. So which of these is going to be the minimum value? It's going to be 25 right here. So within math.min, to get the right side of our player, we can select our player.position.x, and then add onto it our player.width. This equation right here will give us the right side of our player at the hypothetical of 25. Now we also want to compare which value is smaller, the right side of our player or the right side of our battle zone, which we can select with battlezone.position.x, and then add onto that battlezone.width. So this right here will get the right side of our battle zone, which is going to be a hypothetical 40. So if we compare the right side of our player at 25 to the right side of our battle zone, which is going to have the minimum value? Well, it's going to be 25 in this case. So what we're doing with these equations is we're finding the width of our intersecting rectangle. So if we get the maximum value between these two and the minimum value between these two, well, we're effectively getting the width of our intersecting rectangle. Now, if we look at our code real quick, well, we'll see that this doesn't actually give us the width, even though we have the values which should be able to get us the width. If we want to get the width of this right here, well, we need to go ahead and get our minimum value right here of 25 and subtract from it our maximum value that was calculated over here with our yellows. So all we need to do is reorganize our code a little bit for our overlapping area. And to do that, we'll take our minimum right here, get rid of this plus, and we're going to put our minimum at the beginning of our statement, and then we're going to subtract our maximum. So if we do things like this, we're calculating our minimum, which is going to get this right here, and then we're subtracting from it our maximum, which is going to be this right here. So 25 minus 20 is going to give us a width of 5 for our overlapping rectangle. Now all we need to do is the exact same thing, but to obtain our rectangle height. So at the end of this, we can go ahead and multiply this by a new equation because we know it requires multiplying the rectangle's width by the rectangle's height. So we're multiplying it now by the rectangle's height. We just need to obtain that. And to obtain that, we need to go ahead and monitor for the bottoms of our rectangles. So these two right here. And we want to ask ourselves, well, which is going to give us the minimum value? In this case, it's going to be our player, which if we were to assign this a hypothetical value, we could say the bottom of our player is something like 30. And then the bottom of our battle zone is something like 40. So now within our code, we can say, go ahead and give me the minimum of our player.position.y plus our player.height. And then we want to see what is smaller, the bottom of our player or the bottom of our battle zone.position.y plus our battle zone.height. So this equation right here is giving us the hypothetical 30, the bottom of our player, and this equation right here is giving us the bottom of our battle zone. So the result of math.min here is going to be 30. Now we're going to want to subtract from this the maximum value of the top of our player and the top of our battle zone right here. So we'll give this a hypothetical 0 to start for our player, and then right down here we'll give this a hypothetical of 15. So within our code, subtracting from this math.min, we'll subtract a math.max between the top of our player, which we can get with player.position.y, and also the top of our battle zone, which we'll get with battlezone.position.y. So player position y is going to give us this value of 0, and then battle zone position y is going to give us this value of 15, which is going to be greater. Well, in this case, it's going to be no other than 15. So if we subtract 15 from 30, we are going to get the height of this rectangle right here, which would result in 15. If we multiply 15 by 5 based on these equations, we're going to get an area of 75. And based on the order of operations, well, we want to make sure that we wrap these last two equations in parentheses, and same with our top two equations. So I'll wrap math.min all the way to math.max in parentheses. And that's going to make sure that we don't get the area by multiplying these two together until we get the distances required to calculate our overlapping rectangle area. So now I can't remember what the exact numbers were, but let's just go ahead and say our player width is 20, and our player height is going to be 40. If I multiply these two together, 20 times 40, we're going to get a value of 800. So our total area for our player is 800. Now if I divide that by 2, like we're doing all the way over here, dividing that by 2, we're going to get a value of, not 800, but rather 400. So if our overlapping area down here is 75 is ever greater than 400, that is when we're going to go ahead and activate our battle. You'll see that is just not the case, but if we were to go ahead and move our player rectangle down a bit, such to right about here, well, maybe that would indeed be the case based on the equations we wrote over here. The overlapping rectangle based on these dimensions would have an area of something like 500 rather than 75. As a result, we know our overlapping area right here is greater than the area of our player divided by 2, which is 400. Therefore, we can start a battle. So let's go ahead and save this, refresh, and then we'll open up our console. And now we should only log that text if our player is about halfway over our collision blocks. So if we start moving down and we touch the very tip of our collision blocks, we're going to see we're not actually logging anything out. I can move side to side. That's still not being logged out. And on the edge over here, I can start moving down, and that's still not being logged out. But now if I begin walking over our collision blocks right here, you're going to see we are indeed logging that out because we used that overlapping area code to determine how much of our player is actually on top of one of the collision blocks. And you'll see no matter where I go within our battle zone right here, we're logging this out, but it stops as soon as our player goes about halfway off of our battle zones. So that's going to give us an accurate reading for initiating these battles in the first place. Now essentially, whenever we call this text, this is when we want to go ahead and activate our battle. You'll see when I begin to move over this though, that this is just being called way too often. This should only occur once, and it should happen by random chance in which we activate the battle. So what we can do here is we can add on to this if statement by saying and what we'll write is math.random. If math.random is less than a certain value, let's make it really small to start, such as 0.1, then that is going to be when we want to go ahead and activate our battle. So what does this actually mean? Well, math.random is always going to produce a value, 0 to 1. And by saying we only want to continue if the value produced by math.random is less than 0.1, we're effectively giving ourselves a 10% chance in which we activate a battle. So we save that, go back to our game and refresh. We start walking over our battle zone. You're going to see that this occurs a lot less than it did before. But even now, this might be a little too much to start activating a battle. We want to make sure that the chances of this happening are not too often. So if we want to go ahead and decrease the chance that this happens, we can go ahead and decrease this value right here. Maybe if we go ahead and say math.random should be less than 0.01, save and refresh, and then start walking over this. You're going to see nothing is being activated, but eventually we do get an activation, which means we should be transitioning into the battle state right now. And by walking back and forth, you can see just how rarely this actually occurs. So I think this is a good rate in which I want my battles to occur in the first place. So I'm going to go ahead and leave the code as is, but that is all we need to begin our battle activation. The next thing we need to do is transition to a different scene. Within the traditional Pokemon games, well, the screen begins flashing, and then it swaps you over to a battle scene. So the first thing we're going to want to do is actually activate that transition effect by flashing our screen, and then activate that code for our actual battle sequence. So basically what we're going to need to do here is whenever we go ahead and console log out a new battle zone collision, whenever that may be, we're going to want to stop our player from moving altogether, and we're going to want to go ahead and activate some sort of animation that flashes our screen black. So let's go ahead and stop our player from moving whenever we activate a battle. So we know we activate a battle right here, and we can even say, before this if statement, this is when we activate a battle. So how do we stop our player from moving? Well, we know all our movement code is down below, right here, but we're also listening for keys up here. What we want to do is activate some sort of boolean, so that when we set it equal to true, we can no longer call any code that is listening for what keys are pressed. So when we actually activate a battle, and I'll go ahead and rename this console log to activate battle right here to help us indicate what this is better. When we're actually down here, we'd want to call some sort of battle object, and on top of that, get a property called initiated. So by default, this is going to be equal to false, but when we activate a battle, this is going to be equal to true. So if a battle is initiated, if we actually call this right here, before we listen for any keys, whether it be for activating a battle or actually moving our player, we would want to go ahead and return. So I'll go ahead and call if a battle has been initiated, then we're just going to go ahead and call return, meaning we do not call any of the following code. We're not going to accidentally activate another battle, and we're definitely not going to be able to move our player because we can't call any of this code down here. So if we want this code to work, well, we need to create a battle object with a property of initiated. So right above animate, I can create a new const. I'll call this battle, set it equal to an object, and then I'm going to add the property initiated, set it equal to false by default, so all of our other code works. But now whenever a battle is initiated, that'll be set equal to true, which means the next time we iterate through our animation loop, we're going to go all the way up here, check whether or not battle.initiated is equal to true, which now it is, and then we're just going to call return, which means we're not going to call any code down below. So if we save, go back to our game and refresh, we start walking through our battle zones, eventually we should activate a battle, which now we have, and you'll see I can no longer move our player at all. But one issue is our player is still walking even though it's impossible for us to move. So that'll be the next step, is to make sure that our player stops, along with our ability to control where our player is moving. So we know our player has the ability to move, animation-wise at least, whenever player moving is set to equal to true, which we do whenever we press down one of these keys. The thing is, when we activate a battle and prevent our player from moving, well, player.moving is not being set equal to false, and our moving let right here is not being set equal to true. We want to make sure that these are always being called, even if a battle is initiated. So what I can do is I can take these two lines right here, and right above, where we're calling this if statement, I can paste those two in, which sets them to the value that they should be at, even if our battle is initiated and our game is stopped. So now if I save and refresh, and I start walking through our battle patches again, you'll see we activated a battle, but now our player is no longer moving, so we can activate that transition where the screen flashes black, and then actually switch us on over to the battle scene. So I found the easiest way to create a flash transition is to use just default HTML. Thankfully for us, we're creating this game on the web, so we can use really helpful languages like HTML and CSS to make our game even better. We could go ahead and create this animation directly within our canvas, but it's a lot harder to do and it's a lot more time than it's worth. I found if we just do this within HTML, well, it's going to make our lives a lot easier. So to do this within HTML, I want to create a div that covers the whole width and height of our canvas. And then once I create this div, I want to go ahead and fill in the whole thing so that it has a background of not yellow but black. And then I'm just going to change the opacity so that it fades out and fades in over time. So all I really need to do here is create a black background div that is overlaid on top of our canvas. And with that, our player is going to be stopped, but we're just going to be flashing that background on and off to create the effect as if we're transitioning into another screen. So to create that background div, I'm going to want to head inside index.html, and I'm going to want to wrap our canvas inside of a div. So the beginning and closing div tags right here, I'll go ahead and wrap our canvas inside of that. If I save and refresh, well, we're not going to see much of a difference at all, which is okay. This wrapping div is just going to act as a container for not just our canvas, but another div. And this div is what's going to be our rectangle that fills up our entire canvas width and height. Now we just need to style this div so it actually does that. So to style this, we can begin by adding a style tag into our div, and then we can go ahead and say that our background color for this div is going to be black. We save that, we refresh, not seeing anything just yet, because right now this div right here is not taking up any width and height. Even though it might have a background color of black, it doesn't matter, it needs to take up some width and height in order for this to actually show. So if we were to go ahead and give this a width and height, we'll go ahead and declare a CSS property of width, should be equal to 200 pixels, and then a height should also have 200 pixels. Let's go ahead and save, and then refresh over here, and you'll see now our game is pushed down. If I were to go ahead and right click up here, and click inspect, grab this little tool right here, click that, and then hover over the very top, you'll see this is what our div looks like. It's 200 pixels by 200 pixels. So with web development by default, this div is going to be overlaid on top of our canvas simply because it's placed before our canvas. But we want to make sure that this div right here is overlaid on top of our canvas instead. So what we need to do is we need to add a style onto our div right here of position. And we're going to set this equal to absolute and end it with a semicolon just like the rest of our styles. And we save that and refresh over here. And now you'll see this is overlaid on top of our canvas. If I full screen this, it seems to be in the perfect position. But now we want to go ahead and make sure that this div takes up the full width and height of our canvas. So if we go ahead and inspect this div, it's going to be this guy right here, but we want to focus in on the parent div. You'll notice right here the parent div has a width of 1264 and a height of 576, so although the height matches up with our canvas, the width most certainly does not. And this is important to note because divs by default have a position equal to block. So block elements by default take up the full width of their parent container. What is this div's parent container? It's going to be body. Let's go ahead and see the width of what body is. It's going to be 1264. Is it ever so convenient that this div also has a width of 1264? We're going to go ahead and change this div that has a display block equal to, not block, but rather inline block instead. So I'm editing this inline within my browser. This means the changes won't take effect permanently, but we can see what this looks like for debugging purposes. I changed our display to inline block, And now when I hover over our parent div with a display of inline block, you'll see the width is 1024 and the height is 576. That is the exact width and height as our canvas, and now we can use this accordingly to make sure that our background div right here takes up the full width and height of this parent div. So we know our parent div needs a display of inline block. We'll go back to Sublime Text and say our parent div, which is this right here, needs a style tag where we can add a style of display equal to inline dash block. We save and we refresh. Now that's applied by default, and we can see that has a width of 1024 and a height of 576. So now what we want to do is expand the width of our block right here. And we're not going to do so using width and height anymore. We're actually going to turn these off, and we're going to be adding in 4 new properties related to our position absolute right here. So whenever we use position absolute, that gives us access to 4 new properties. They're going to be top, right, bottom, and then they're going to be left. So once we supply these 4 properties right here with 0, you can see even with width and height turned off, well, now our div covers our full screen at a width of 1280 by 426. And what these properties do is they determine the positioning of each side of a rectangle. So when we declare our top is equal to 0, we're saying start our rectangle at the very top of our page. When we give it a right of 0, we're saying start a rectangle at the very right of our page. We're saying the bottom side of a rectangle should start out 0 pixels from the bottom. We're saying the left of a rectangle should start out 0 pixels from the left. Now this is all relative to our HTML tag right here. Why? Because there is no parent div which has a style of position relative. What we want to do is make sure that this div right here is relative to its parent div, because we know the parent div has a width of 1024 and a height of 576. So to make sure that this div right here is relative to its parent div, all we need to do is within Sublime Text, add an additional style to the parent div called position:relative. And once we do that, we're going to want to go ahead and remove the width and the height from the child div right here, which is going to cover our whole canvas, and make sure that we set its top equal to 0, its right equal to 0, its bottom equal to 0, and then its left equal to 0. So now if I save and then I refresh, you're going to see that covers the whole screen, but now if I hover over a div right here, it only takes up 1024 by 576 pixels. And it's even more apparent if I were to change our background color to something like red. If I save and refresh that, you'll see that this is taking up the perfect amount of space, but it's an HTML element laid on top of our canvas, which now we can animate just as HTML element to create the illusion as if we're transitioning to another screen. So we're going to want to go ahead and keep the background color right here as black. And now we can go ahead and add in an additional CSS property called opacity and set it equal to about 0 to start, add a semicolon to the end of that, and you'll see that no longer shows. But one of the issues you may have is even though this has an opacity of 0, if I were to inspect this, you're going to see that it's still overlaid on top of our canvas, and that might prevent us from clicking on any canvas elements that we might need within our game. So to prevent any clicking from occurring on an overlaying div like this right here, what we can do is we can add one more property onto this called pointer-events. And if we set this equal to none, well, that's going to make sure that this div right here never gets in the way of any events that might be required for our actual canvas. So we should be able to click freely without any bugs or issues occurring due to that overlapping div. Now, how do we get our overlapping div flashing? Well, we could create a CSS animation, but in this case, we are going to be using an external library specifically for animations within JavaScript. Why am I choosing this over CSS animations? Well, simply because I find it much easier than creating these within CSS. And plus, we're going to be using this animation library later to help animate our sprites once we're inside of our battle scene. So in this case, it makes sense to import it early, use it for this functionality, and then also use it for the functionality we're about to create later on when we need to animate our sprites. So in this case, we're going to want to do a Google search for GSAP CDN. This is going to be the animation library we're using. And a CDN stands for Content Delivery Network. It's basically an online script tag that we can grab and place into our project so that we can begin using the library immediately. So if we go on over to cdnjs.com, select that, you're going to see right here, GSAP is provided to us at version 3.9.1. You're going to want to make sure that you're on the exact version I am, which is going to be 3.9.1. And then we're going to want to select the very first result right here that has GSAP listed as 3.9.1, get the minified version, and we can just click copy script tag, head back to index.html, and before we import anything else, I'm just going to paste in the script tag that was copied. So if we save this link, go back to index.js, and at the very top of our file, if I console log out, not Battlezone's data, but rather gsap instead, save, go back to our game, open up the console, and then refresh, you're going to see for the very first object we're logging out right here, it's going to have a bunch of different properties we've never seen. This is the gsap library. This is all we have to do to import this into our game and begin animating things using it. So what we're going to want to do is animate that overlapping div's opacity so it flashes in and then it flashes out. And then after about the third time, we're going to stop the animation and activate our new scene. So let's start animating it right off the bat whenever we load index.js just to make sure that this looks exactly as we need to without actually having to activate it by walking over our battle zones. So in order to activate this animation within index.html, we want to look for what we want to animate. Well, we know it's going to be this div right here, but we have no way of selecting this one div because it has no ID associated with it. So within this div, we can give it an ID and call it overlapping div, like so. So now we can grab this ID, make sure you save index.html, go back to index.js, and now we can call gsap.to. And this is going to take a string as the first argument. We want to go ahead and select an ID. So if you're ever trying to select an ID within JavaScript, you want to reference the £, and then whatever ID you put on your HTML element, you're going to want to list that out after the £. So by doing this, we're grabbing our overlapping div, which we set right here. So now this is going to take a second argument, which is going to be an object, and this is going to be all the properties we want to animate over time. So we know one of the properties associated with our HTML div is going to be opacity. If we go ahead and animate this to 1, even though by default in index.html, its opacity right here is equal to 0, and save that, and then refresh, you're going to see that fades in over time. And that is how easy it is to use the gsap animation library. Pretty much you're only going to be using gsap.to, and 2 is just a simple interpolation that says select an HTML element, and then determine what properties you want animated. If you want to go ahead and find out what additional properties you can animate, you can use the gsap documentation, and that'll be linked within the description of the video. Same thing with the CDN link if you just want to grab it from the video. But this is a great start when it comes to activating our battle. So we know when we activate a battle, while this just doesn't fade in, it kind of flashes a few times. At least I believe that's what happens with the Pokemon game. Even if it doesn't, this will still create a cooler effect than just fading to black. So to get this flashing a few times, we're going to want to go ahead and set a repeat property within our object right here. If we set repeat equal to about 3 times, save, and then refresh, you're going to see that flashes about 3 times. Now it's a little jarring because it starts from 0 each time we repeat this animation. If we want this to be smooth rather than just flash from 0, what we can do is we can add a yo-yo property onto this and set that equal to true. And all that's going to do is make sure that it goes from 0 to 1 to 0, but in a smooth manner rather than just repeating the animation with an opacity of 0 to start. So if I save that and then refresh, you're going to see we have a smoother animation, but we might want to speed that up a little bit. So what we can do is we can add a duration property onto this, set it equal to something like 0.4 because I believe the default is around 0.75. Forgive me if I'm wrong on that, but let's go ahead and set our duration equal to 0.4, save and refresh. And I think I like how that looks to start. So now that we like our animation right here, we can grab the animation code, cut it from when we actually start our game, and now we want to place that in the spot in which we actually activate our battle. So if I scroll on down, we know we activate our battle right here, where we're console logging out, exactly that. Beneath battle.initiated, I can go ahead and call gsap.to on our overlapping div. If I save and I refresh, and now if I try to activate a battle, let's go ahead and see what happens. Eventually over time our player should stop, and you'll see now our player is stopped. We activated a battle, we called our animation, but now what you might have seen is, well, we end up on the same screen. We want to make sure that we end that animation so the black screen is still drawn on top of our whole canvas right here, and that way, when our overlapping div covers our whole screen, while all of this is black, in the background, we can swap out our canvas scene to go to a battle view instead of a map view. So we want to go ahead and make sure that this shows whenever this animation ends. What we can do is we can call an onComplete property. This is going to be a function, like so. And now on complete, we can call another gsap.to. Make sure we select our overlapping div. Go ahead and grab that, paste it as the first argument. And then we want to say that the opacity for our overlapping div should be equal to 1 on the end of this animation. We can even make sure that this is the same duration by adding our duration property to the end of this, And now this isn't going to yo-yo back to an opacity of 0 because yo-yo isn't placed inside of here. So now if I save, I go back to our game, and I try activating our animation one more time, you're going to see that activates, and then it ends on a black screen, which is perfect because now behind this black screen, we can go ahead and say we want to switch to our battle view rather than our map view. So to do this, when our animation completes, we're going to want to go ahead and activate a new animation loop. At the same time, we're also going to want to deactivate current animation loop, because it doesn't make sense to call all this animation code that we're calling right now for a battle sequence, because that contains completely different code than what we're working with right now for our map. So we're going to cancel out of this animation loop, and at the same time, we're going to create a new animation loop, but that is more focused on our actual battle sequence rather than our map movement. So how would we cancel out of this animation loop? Well, window.requestAnimationFrame is always going to return an animation ID for each frame we loop over our animation loop. So if I go ahead and say I want to create a const called animation ID and set it equal to window.requestAnimationFrame, well, this is still going to function exactly as before. The only difference being is we're storing the frame ID within our animation ID const. We can go ahead and console log this out, animation ID, save, go back to Chrome, refresh, open up our console, and you'll see this is what frame we're currently on within our loop. And this just keeps increasing over time until we cancel out of this. But in order to cancel out of this, well, we need the animation ID. So now that we have this animation ID available to us, whenever we activate a battle, we go through our flash sequence, we want to go ahead and deactivate the current animation loop right here at the very end of our animation. So what I can say is I want to select window.cancel animation frame. What frame do I want to cancel? Well, our animation ID frame. So to test this, right before we return when a battle is initiated, we're going to want to console log out our animation ID. So if we save that, we're going to see our animation ID increasing over time. And now if we activate a battle down here, well, this should stop technically, shouldn't it? Well, we watch that happen. And why does this keep going? Well, one of the issues is we actually call gsap.to and we call onComplete when we try to cancel an animation frame. We're trying to cancel the frame in which animation ID was when we activated our battle. The thing is, this animation loop is going to continue over time regardless because we're calling this too late. We're calling this after our animation has occurred, and our animation ID is increasing over time. So we're canceling the wrong animation frame. We want to make sure that this is the exact frame that we are currently looping over within our animation loop. So instead of deactivating our current animation loop right here, we want to take this code out of our gsap.to function, because remember, this is only called 0.4 seconds after the fact. We want to make sure that this is called immediately. So whenever we activate a battle, yes, we're going to activate a battle, but we're also going to deactivate the current animation loop. That's still going to show everything within our background. The only difference is if we were to include moving sprites, well, it'd stop them from moving altogether. But we don't have any moving sprites besides our player in this case, so it's totally okay to put window.cancel animation frame right here. So right here is where we deactivate the current animation loop. We save this, try refreshing, and doing this again. Let's go ahead and start moving. You're going to see that this stops altogether. This means we are no longer calling animate within our game. We activated the battle, we activated our animation, now we are ready to transition to that new scene. So to transition to that new scene, we want to go right here to where we activate a new animation loop. And here we're going to call animate battle. So now that we have a new function, we need to actually create it. We can go ahead and create it down beneath animate. So right about here, I'm going to create a new function called animate battle. And inside of this, I want to call window.requestAnimationFrame. What do I want to loop through? Well, this function right here, so animate battle, will go right there. Now I can console log out animating battle to make sure that we switch on over to this animation loop instead of the one we had previously. So I save this, go back to our game, and then I activate a new battle. We activate that battle. This loop stops, but eventually we're going to go into our new animation loop where we're calling animating battle. And now we can show everything we need to begin this battle functionality. So with that, we just transitioned from our map to a battle sequence. So now what we're going to want to do is import a battle background to set the scene for this view. So if we look within the Google Drive link within Pokemon Asset, Images, we're going to see a battle background PNG. We want to go ahead and copy this, so I'll right click, hit copy, and then I want to go over to our web folder where we have our Pokemon game. So I'll scroll on down until I find Pokemon game. And here with an image, I can paste in our battle background. So now it's within our project, now we can begin using it. So over within Sublime Text, right above Animate Battle, I can create a new const called Battle Background Image, and set this equal to a new image object. So now that I have this new image object, I can select Battle Background Image, and set its source equal to what? Well, if I go within image/img, now I can find battle background.png, so I'll type in battle background, not image, but rather just .png, and now we have an image we can use inside of something like a sprite. So here, I can go ahead and declare a const of battle background, and this is going to be equal to a new sprite. So what does a sprite take? Well, we can always check within classes.js, and scroll up above, we know that it takes a position. We added velocity here. We don't really need that though because we're not actually using a velocity property. We can get rid of that. But we know sprite takes a position, image, frames potentially, and then sprites potentially. So really all we need is a position and an image. So I want this battle background image to start at the top left-hand corner of my screen. So I'll declare that its position property should have an X of 0 and also a Y of 0. And now I just need to set the sprite's image. So let's say its image should be equal to battle background image. This is the image we just created. And now I just need to render this out in the scene. So I'll grab our battle background sprite. And now with an animate battle, I can go ahead and paste in battle background and call its draw method. So I save, go back to Chrome, and then activate a new battle. Well, you're going to see, well, our background image showed for a second, but then we faded out to black. We want to make sure that we only show this background image when our black overlay is fully opaque. So we shouldn't have that flash of our background image in place, but once we replace our background image with our black overlay on top, then we're going to fade our black overlay out to give off a smooth transition as if we're actually going into this new battle scene. So we're going to want to go back up to where we're activating a battle, and that is going to be right here where we're console logging out to activate battle. And now we should really only be activating a new animation loop on complete when our overlapping div has an opacity of 1. So at the end of this animation, we're going to want to declare on complete at the end of this animation, then we want to animate our battle. So when this is fully black, we're going to animate our battle. That's going to take care of that flash we just saw, but then we're going to want to call gsap2 just one more time. So we'll go ahead and grab gsap.2. I'll just go ahead and copy all this code, paste it on in. We want to go ahead and say that when we animate our battle, we want to fade out our overlapping div to 0. We don't need to call anything on complete, so we can get rid of that. But this is going to allow us to see what we actually transitioned to by calling animate battle in the first place. So let's try this one more time. We'll save, go back to our game, and then activate a new battle. And now you'll see where we have a perfect transition into our battle scene. So this is a completely new animation loop. We're not calling any of the code we had prior. We're doing this as efficiently and as performant as possible. So now we can begin writing out the code to actually create our battle scene in which we have characters that attack each other, and then we'll transition back to our game once one of the characters gets eliminated. So it's kind of annoying to have to go back and travel over this to get the chance to start a battle animation. I know I got it on the first time right there, but sometimes it might take a while to actually activate that. So if you're tired of doing that, what we can do is where we call our initial map animation, it's going to be by calling animate right here. This is on line 319 for me. I can go ahead and comment this out, and then right beneath animate battle, I can simply just call animate battle. If I save that and refresh, then we're going to start out on our battle scene, which allows us to focus in on this rather than having to activate this each time directly from our map. And with that, we can go ahead and say that we drew out our battle background. Okay, so now let's go ahead and add our battle sprites. What are battle sprites? Well, they're essentially just going to be moving sprites that represent our monsters within this battleground. So if we go ahead and look within our Finder right here, you're going to see that I included two sprite sheets. They're going to be Draggle Sprite and MB Sprite. So Draggle and MB, these are the names I chose for these sprite sheets. I got these from the Ninja Asset Pack over on itch.io. Really great free pack that you can use for any of your games. But I decided to choose the dragon-looking monster for our enemy and this flame-looking monster for ourselves. So if we want to go ahead and place these within our battleground right here, well, the first thing we need to do is actually copy these into our project directory. So these are available within the Google Drive link. If you go on over there, go inside the images folder, you'll see that there is Draggle Sprite and MB Sprite available. So what we're going to do is we're going to select these two sprites, and then I'm going to go ahead and hit Command C to copy them. Now I want to go over to our project folder, which is within web, and then I'm going to scroll on down till I find Pokemon game, and now I can go ahead and paste these within our image folder. So once those are pasted in, we'll head back to our game over in Sublime Text, and within our image folder we should see dragglesprite.png, which is this, and then we have an mbsprite.png, which is this. So now that we have these within our project, we can actually make use of them within our game, specifically within index.js. So we're going to want to go ahead and go to where we are calling animate battle. It's going to be right here on line 335 for me. So what we're going to want to do is create two new sprites using our sprite class, but this time we're going to go ahead and use these Draggle and mbsprite images instead. So what we're going to do is, right above animate battle, I'm going to go ahead and create a new const, and I'm going to call this Draggle, like so. This is going to be our dragon monster. Now I want to go ahead and create a new sprite, which comes from our sprite class. So what does a new sprite take? Well, we can reference the sprite above to find out, and we know that it takes a position and an image. So for our position, we're going to have an X, and we're also going to have a Y. What should these be equal to? Well, we want to go ahead and position these somewhere down here. So our X would be something about 100 from the left, and our Y would be a little greater, probably something around 400. So I already did the calculations for this. Our X position to start is going to be 280, and then our Y is going to be 325. Now we need to go ahead and assign an image to our Draggle sprite. So what should our image be? Well, we need to create that HTML image to make sure that it loads into our class correctly. So to create an HTML image, we can reference these two lines up above. I'm going to go ahead and copy these two. And right above where we're creating Draggle, I'll paste those in. And now we know we don't want to create a new battle background image, but rather a Draggle image instead. And this is going to reference that sprite sheet that we just imported into our image directory. So instead of referencing battle background.png, what we're going to do is find Draggle sprite.png right here, and that is within our image directory. So now that we have a source assigned to Draggle image, we can go ahead and put it into our sprite class, save, and we're not going to see anything just yet if we refresh, because we need to make sure that this new sprite is being rendered out onto our scene. So where we're calling animate battle, we also want to call within it our Draggle const, which is now a sprite, and since this is a sprite, we can go ahead and call the draw method on top of it. So if we save that and refresh, we now have our Draggle sprite on the screen. But one thing you might notice is this Draggle sprite is facing us. It doesn't really make sense to put it in our player position if the sprite sheet is actually facing towards us. In this case, we want Draggle to be our enemy, so if the sprite is facing us, we're going to go ahead and move him to this platform over here. So the coordinates for that platform are actually going to be 800 for X and 100 for Y. So if we change the position right here, save and refresh, now Draggle is going to be in the correct spot, but you might have noticed we have 4 instances of Draggle right here. We want to go ahead and change this to 1 instance and make sure Draggle is animating accordingly based on the sprites next to it. So similar to what we did with our player class, we can go ahead and start cropping our sprite sheet right here by adding in a property of frames. And this frames property is going to take a max property inside of it. What are the max amount of frames we want to go through within our Draggle image? Well, if we inspect this, you'll see we have 1, 2, 3, 4 frames within the sprite sheet. So for frames max, we'll go ahead and declare we want this to be 4 frames max. So if we go ahead and add that in, save and refresh, you're going to see Draggle is reduced to just one portion of the full sprite sheet, which is great. But now we want to go ahead and move that crop mark through all of our Draggle frames to give off the illusion as if Draggle right here is animating. So why isn't this animating by default? Well, we're going to have to inspect classes.js to find out. So right here, this is going to be our sprite class, and we know within draw, well, we're going to be drawing our Draggle image, and all this right here is our crop code. All this is functioning correctly because we prepared things very well in regards to getting sprite sheets cropped. But if we go down below, we'll see, well, if this .moving is not equal to true, then we are just returning. We're not calling any of the following code, and we need this code in order to animate our sprite sheet. But we were using this .moving to make sure that our player sprite only moves when we press down on the keyboard. But by default, any sprite we create is going to have this .moving set to false. So when we go ahead and create a Draggle sprite, it has this .moving equal to false, which means right here, we're never actually calling any of the code responsible for animating our sprite sheet. So how do we change this? Well, what we're going to want to do is pass through an argument which says whether or not the sprite should animate by default. So instead of calling this .moving, well, moving, we can go ahead and refactor this so that this .moving is actually this .animate. If this .animate is set equal to true, that means call the following code and actually animate our sprite sheet. But we might want this to change based on which sprite we're creating, so we want to make sure that we set animate equal to an argument called animate, and we're just going to pass this through up above within our constructor function. So go ahead and add animate inside of here, and by default we can say this is equal to false. So we want to make sure that we save this here, but now we're going to have to refactor some code within index.js, specifically for our player. So if we search for new sprite, eventually we're going to come across our player, which is right here on line 73 for me. And we know by default when creating our player sprite, well, our player should not be moving right off the bat, because when they're spawned on the screen, well, we only want our player to have that movement animation when we're actually pressing down on one of our keys. So we don't need to do anything right here where we're actually creating our player sprite, but we do want to look for other instances of player, specifically for player.moving. So since we changed moving to animate, what we can do is we can find all instances of player moving. And it looks like we have about 4 instances, and I'm just selecting these by selecting that term right there and hitting Command D within Sublime Text. That'll select all instances of the text you want to select. And now that I have all this selected, what I can do is I can delete those instances and say, actually, I don't want to reference player.moving, I want to reference player.animate instead. So what we're doing right here is within our animate function for our map, we're declaring by default our player should not be animating. That's going to be equal to false for every time we go through our animation loop. Then eventually, when we press down on one of our keys, right here in the functions responsible for moving our player, you're going to see that we set player.animate equal to true, which means when we press down on one of these keys, well, we want to activate that sprite sheet animation. So that's all we're doing, but this is also going to allow us to use .animate to actually animate our Draggle sprite right here. So since we just declared within classes.js that we have a new property that we can pass through called animate, now we can go ahead and declare that property where we're actually creating Draggle, so animate, and set that equal to true. This is going to be a sprite that should definitely animate. So now if I save that, go back to our game, and refresh, you're going to see now our sprite is animating simply because within classes.js, well, now this is equal to true, we're no longer returning, and we're calling the rest of the code, which is dependent on the amount of frames our sprite sheet has. So with just that, we have Draggle bouncing up and down, but this animation is kind of fast when our hold on the animation is 10 frames. So this value right here, if we go ahead and increase this to something like 30 instead of 10, save and refresh, you're going to notice that animation is slower. But if we increase this from 10 to 30, well, that means when we go back to our map, well, our player animation is going to be a lot slower and might not be exact to what we wanted it at. So what we're going to want to do is add a new property to our sprite class that determines the max frame hold we should have. So instead of calling this 30 or 10, we're going to say that this is going to be equal to this .frames.hold. How many frames should be held until we go to the next iteration of our sprite sheet? Well, since we're adding this in right here, we're also going to need to add it in above. And we're going to do this by declaring a default argument for frames. So right now, frames is equal to a max of 1. And then we want to say that the hold for our frames by default is going to be equal to 10. So that's a good start, especially if we're creating a sprite where we don't want to pass through a frames object in the first place. Well, the thing is, for our player sprite, if we were to pass through a frames object that just had a property of max and not hold, well, the hold property just wouldn't work. It would be overwritten because we're passing through a completely new object. So if we go back to index.js, we're going to want to go ahead to where we're creating our player. So we'll search for player equal. That's going to be right here on line 73 for me. And we want to make sure that we update this frames object to also take into account the hold for our frames. So we know when we're creating our player, the hold should be 10. We're going to add that on in. And that should make sure that our player is stable when we go back to our map. But now, if we go to new sprite, specifically where we are creating Draggle right here, we can go ahead and declare that the hold for our frames is going to be a little greater. We're going to say that this is going to be equal to 30. So we save that, go back to our game and refresh. You'll see now this maintains that 30 frame hold. But we also want to make sure that when we go back to our map that our player has the correct hold on it as well. That hold should be 10 frames rather than 30. So if we ever want to go back and test our map, all we need to do is right here where we're calling animate battle, we can either go ahead and copy this, just call animate instead, and comment out animate battle, or you can just go ahead and delete battle and call animate. It doesn't really matter. But if you go ahead and save and refresh with just animate right there, we're going to go back to our map. And now we can test whether or not our player animation is correct. So if I start moving, it looks like that is indeed correct with a frame hold of 10. So you just want to make sure that this works before you keep on going with development of the battle scene. So we'll go back to our code, and we know that worked. So we'll go ahead and comment out animate, and go back to animating our battle. So we save and refresh, we're back over here. All we really need to do now to get our sprites on the scene is add MB, which is going to go right here. So I actually want to go ahead and challenge you to add MB yourself. Basically, you're going to go ahead and use the same code that we used right here for creating Draggle. You're just going to create a new instance, but using the MB sprite sheet. So go ahead and pause the video and give it a go on your own. Once you think you have that down, let's go ahead and do it together. So what I'm going to do is I'm going to copy all these lines right here responsible for creating our Draggle sprite. And then I'm going to paste them down below. So I know that I want to use a different image than Draggle. I want to go ahead and use our MB image. So here, I'll go ahead and select these 3 instances of Draggle image and say, no, this is actually going to be MB image instead. And now I just need to make sure that I reference the correct sprite from our images folder. So instead of referencing Draggle sprite right here, I can look for MB sprite instead. So I'll go ahead and delete Draggle and add in MB sprite instead. And now I don't want to create a Draggle const, but rather an MB const. And now that I have MB created, what I can do is I can go into our animation loop right here for animate battle, and then call MB.draw. That is going to call our sprite class specifically on our MB sprite. If I save this and refresh, you're going to see, well, it looks like these two are dancing or maybe doing something else we should not talk about. So instead, we want to change the position for MB. What we want to do is change it so MB is down here, not macking on Draggle. So X is going to be around 280, and then Y is going to be 325, as mentioned earlier. If I save that and refresh, you're going to see MB is in the perfect spot and ready to battle Draggle. So with that, we can go ahead and say we added in our battle sprites. Next up, we want to go ahead and add in our attack bar interface. We're not going to add any functionality to this, but we do need to make sure that it's appearing on our screen before we add that functionality. So for our attack bar, I kind of want to replicate the original Pokemon games. What I'm going to do is I'm going to go ahead and start our bar right about here and draw all the way across our screen right beneath our player. And then we can go ahead and start adding attacks right here, and then over here, this will list the type of attack we are selecting. So what we're going to do here is actually use HTML to add this in. Since we're developing our game on the web, well, we are able to use HTML, and what this is going to do is allow us to start inspecting our HTML elements. It's going to make production of this way easier than if we were to just do this within Canvas. So if we have HTML and CSS available to us, why not use it? So that's how we're going to go ahead and add in our attack bar interface. So let's go ahead and start. What we're going to want to do is head on over to index.html for a change. So now that we're inside of here, I'm going to go ahead and auto format everything. I want to go ahead and right beneath our canvas, I'm going to start creating this interface. So to create this interface, I'm going to start with a simple div. And a div, you can kind of just think of this as any generic rectangle. So this is going to act as the rectangle that goes across our screen right here. So since this is our container, I know I want to style this up quite a bit. So the first style I'm going to add here is going to be background-color. We used this previously up above. And this is going to be equal to white. This is going to have a full white background. And now I want to go ahead and add a width. Just to start, I'll say this is equal to 200 pixels, and then I'll add in a height, and this is also going to be equal to 200 pixels. So if I save that, and I refresh, you're going to see this is going to be the start of our attack interface bar. So I want to go ahead and get this overlaid on top of our canvas. Right now it is within the document flow because all divs, by default, are going to be within the document flow unless you declare otherwise. So to get this out of the document flow, we need to go ahead and use position absolute, similar to what we did with our overlapping div prior. So I can just go ahead and copy position absolute right here, and then paste it into our interface div right here. So if I save that and refresh, well, it still looks like it's within our document flow. If that's the case, we just need to make sure that we set either a top, a left, a right, or a bottom property to make sure that it's overlaid on top of what we want it to be. So what is the parent div of our interface div right here? Well, it's going to be this div at the very top, the same parent div we're using for our canvas, and the same parent div we're using for our overlapping div that covers the whole thing. And we know this has a position of relative, so basically when we start declaring top, bottom, left, or right properties for this div right here, we're basically saying that we're going to place this rectangle relative to our parent. So if I go ahead and declare a bottom property right here of 0, I save and I refresh, you're going to see now this is 0 pixels from the bottom of the parent element. So basically what we said was find the parent element, which is going to be our huge canvas rectangle. So this red rectangle is equal to this div right here. This is our parent. And then since our child right here has a position of absolute, we told our child div, which is this rectangle right here, that we want it to be 0 pixels from the bottom of our parent element, so the big red rectangle right here. So that's kind of how that works, but if we want to go ahead and make sure that our child div right here expands the full width of the parent element, we can also go ahead and add in a left property and a right property, both set equal to 0. So that way, when our rectangle right here has a left of 0, we're starting it on the left side of the parent div. And then if we go all the way to the right, we're going to make sure that the right side of the rectangle starts all the way on the right side of the parent div as well. That's going to make sure it expands the full width of the parent with a position of relative. All we need to do here is delete our width, so we'll go ahead and get that out, and then we're going to add on left and right properties. So let's go ahead and do that now. So to delete our width, well, delete our width, easy enough. But we want to go ahead and add on a left property equal to 0, and also a right property equal to 0 as well. If I save that and then refresh, you'll see now that takes up the full width of our parent container. So that's looking great, but now we can't really see MBs, so we want to go ahead and decrease the height for our height property right here. I'm going to go ahead and decrease it to something like 140 pixels. Save and refresh that, and that seems to be pretty darn good. We still have a lot of room to list out our attacks, but we can also see our character right here. So now I'd say it's kind of hard to see where our white rectangle right here differentiates from our actual battle background, simply because we have a white colored element on top of white colored and really light blue elements. They kind of blend in together, so we want to make sure that we help separate this from our background right here. To help separate this, we're going to go ahead and add in a border property. So for a style, what we can do is, right beneath where we added right 0, we can add in a property called border. And this is actually going to take 3 separate entities within this one border property. They're going to be the width of the border, so how large do we want this border to be? I'm going to go ahead and say I want this to be 4 pixels wide. The second entity we can add for a border property is going to be the color of the border. So I know I want this to be black to make sure that this contrasts really well from the background. So here, I'll add in black. And the third entity is going to be, well, what type of border do we want? Do we want a dashed one? A wavy one? I think wavy is a property, maybe not. But pretty much, we're always going to declare our border is going to be solid. This is required for our border property to work. So if we go ahead and save and refresh over here, you'll see our white box now has a border around it. But one thing is, we might only want the border on the top side right here, because it doesn't really make sense to add border for the left, right, or bottom of the screens, because we don't need that contrast in place. Our background is already black, we don't need to add in additional contrast. So if we want our border to only take effect for the top right here, what we can do is we can declare we don't want to reference just a standard border property, but rather a border top property instead. So if we change that, save and refresh, you'll see the side and bottom borders were taken away, and now only our top border remains. Next up, we want to start adding in attacks and an attack type. So our attacks are going to go over here on the left side of our screen. We're not sure exactly how we're going to place them just yet, but on the right side of the screen over here, in this little box, we're going to have a type. So we definitely want to go ahead and separate our attacks over here from our types on the right-hand side. So to do this, we're going to create 2 divs inside of our main div right here. Our first div is going to take up just this amount of space, and our second div is going to take up this amount of space. So we know we need to create 2 divs within our parent div, and then we need to go ahead and style them so they only take up the correct amount of spacing. So this div right here is our parent div. This is the red div that encapsulates our whole bar. We know inside of this we want 2 more divs. So I'll create 1 div, and then I'm going to go ahead and create a second div. Let's go ahead and focus in on this first div. I know within here I'm going to have quite a few attacks, and I want these to be clickable, so I'm going to go ahead and use the HTML semantic element of button, and then I'm going to call this attack 1, and within this left-hand side div, I want to create about 3 to 4 attacks. So I'll duplicate that button 3 to 4 times, and if I save and refresh that, you'll see these are going to be our attacks on the left-hand side. But we also need a type on this right-hand side over here, so I'll go back, and the second div is going to act as our attack type. So here, I don't want this to be something you can click, but I still want it to be semantic within our HTML. So if I read this, I know, well, this is just going to be some sort of display element. For display elements, you can either use a paragraph tag or some sort of heading tag. I think it kind of makes sense in this case to use a heading tag, so I'll just go ahead and use an H1. I'm going to call this attack type. So by default, an H1 is going to be much bigger than other elements. So if I save this and then refresh over here, now we have attack type in place, but it's not where we want it. We want to make sure attack type is over here on the right-hand side. So right now, our divs right here are laid on top of each other. This is going to be our first div. It's going to represent the container for all of our attacks, and it's going to extend the full width of our parent container. And then this right here is going to be our attack type div. It's also going to extend the full width of our container. You'll see our red container right here is on top of our yellow container for attack type. And that's just the default way div elements work because they have a display of block. But if you want to go ahead and make sure that these are placed next to each other rather than on top of each other, you need to go over to the parent div and add a display of flex. And by default, any child elements inside of a parent div that has a display of flex, the elements are going to be next to each other rather than on top of each other. So let's go ahead and do that. For our parent div right here, I'm going to add in a display property, and this is going to be equal to flex. So if I go ahead and save that and refresh, now these are actually next to each other rather than on top of each other. Now it might look like attack type is still beneath our attacks over here, and it kind of is, but this is just dependent on this element's margin. One of the nice things about using HTML instead of making this interface within our game is we can go ahead and right click our element, hit inspect, and then we can go ahead and see what styles are applied to our element right here within our inspector. So if I go ahead and hover over H1, we'll see that it has some orange bars on the top and the bottom. The orange bars mean this is the amount of margin applied to the element. And by default, H1s have a specific amount of margin on them because that is what browsers like Chrome, Firefox decided should be a default. Now for our game, we do not want this default at all. So if we want to go ahead and change the default for all of our H1 tags, we're going to want to do this within our style tags up above. So right beneath body, we'll add in an H1 and say for all H1 tags, we want to select our margin and make sure that they have a margin of 0. So now all of our H1 tags will have a margin of 0. We save and we refresh. Well, now that margin is gone, we can hover over our H1 and there are no more orange bars, meaning we did this successfully. But you can really see right here when hovering over the H1's parent div, and also hovering over this div right here, that these are placed next to each other rather than overlaid on top of each other like they were prior. So now we want to go ahead and put attack type on the right hand side and make sure that these attacks right here extend most the width of our bar. To do this, we're going to go ahead and focus in on our first div that contains all of our attacks. We're going to want to add in a style attribute, and then the style we're going to add on is going to be width. And here we can begin using percentages to determine what percentage of our full parent div should we take up with this one div right here. So I'm going to say that the width should be 66.66% of the parent div. If I add that, save, and then refresh over here, you're going to see, inspecting this block right here takes up 66% of our full parent div. See if I hover over that, it only extends all the way over there, and this over here is going to be around 33%. And that's pretty much all we need to do to make sure that these are placed next to each other in the correct format. The next thing I want to do is center attack type right here, right in the middle of its container div. So to get attack type centered, we're going to want to go ahead and apply a display of flex on top of this one container div. And then you'll see how adding on subproperties work so that we can get this thing centered. So we know for attack type, we want to reference this div right here that surrounds attack type. So here I'll add on a style, and this is going to be equal to a property of display, and we're going to set this equal to flex. So I save that and refresh. Nothing's going to change, but what adding a display of flex allows us to do is use subproperties that only work if we have a display of flex in the first place. So the first property we're going to add on is going to be align dash items. And this is going to be equal to center. So I save this and refresh. Well, that's going to center our H1 vertically. And this only works if we have a display of flex. You'll see if I get rid of display flex right here, save and refresh, this just goes back to its original position. We need to make sure that we have this display of flex right here in order for that to work. The second subproperty of flex we're going to add on is going to be justify content. This is also going to be equal to center. Let's save that and refresh. Well, things aren't looking like we expect them to. We would kind of expect this to already be centered within its parent container. But if we go ahead and inspect this, you'll see if I select the H1 right here, it's not taking up the full width of the container. And the container, well, the container itself isn't even taking up the full width of what it should be. We need to go ahead and add on a specific width for this div right here to make sure that it takes up the amount of space on the right hand side. So for our attack type container, we can go ahead and add on a width of what? Well, 33.33% to take up the additional percentage that was missing when we added on a width of 66.66% to its neighboring div. So we save that, refresh, and then we inspect our div right here. You'll see it takes up that remaining width. And since it takes up the remaining width, justify content center is actually going to work on H1 to make sure that this H1 is centered within the containing div. So in summary, align items right here is going to say for any children within this container div that has a display of flex, I want to go ahead and take those children and along the y-axis, I want to place them right in the middle of the y-axis. And what Justify Content Center does is the same exact thing, but it says take all the children elements, and on the x-axis, also place those in the center. That is how these two subproperties work, along with a display of flex. So that's looking good, but maybe we want to go ahead and separate attack type over here from our attacks on the left-hand side a little better by adding a border to the left-hand side of the attack type parent div. So we want to add a left border to our div right here. What we can do is add in a border dash left property. This is going to be equal to the size of the border, which I want it to be 4 pixels to match our original border up here. I also want this to be equal to black, and I'm going to say that this should be a solid border. If I save and refresh that, now we have some differentiation from our attack type and all of our attacks on the left-hand side. Now our attacks on the left-hand side are buttons, and they're kind of small, they're kind of hard to click. I think it makes a little more sense to make sure that these buttons take up all the remaining space that we have in this div over here. That's going to make them super easy to click so that our player has the most enjoyable experience possible. So to get our buttons taking up the full width of this container right here, we're going to want to go ahead and add on a property of display grid to this parent container. And when we do that, it's going to allow these elements to take up specific portions of the parent container. That way we can have an attack right here, an attack right here, an attack right here, and then finally an attack right here. All these little sections right here are going to be clickable. It's going to make our game really easy to play since we have a nicely set up user interface. So to get this layout, we're going to want to head on over to the parent div of all of our buttons. And here we're going to want to add on a display of grid to this parent div. If I save that and refresh, well, these are already laid out a lot better than they were prior. By default, the display of grid property says take all the children elements and align them in some sort of grid format. But the nice thing about display grid is we can go ahead and add sub-properties onto that that'll affect this even more to get the exact layout we're going for. The additional property we're going to want to add in here is going to be grid-template-columns. So this right here is going to determine how many columns we actually have within our container div. So if we go ahead and set this equal to 2, well, we're going to have 2 columns, one on the left, one on the right. But once we have more than 2 elements, well, we might want these to stack on top of each other. So if we tell grid template columns to repeat, well, once we go ahead and loop through 2 elements within our grid, we're going to have one right here, and then we're going to repeat into a new row to say a new element should be placed here, and a new element should be placed right here. So to get that effect, we're going to want to go ahead and call something called repeat, and the first argument repeat takes is going to be how many columns do we want. So here I'm going to go ahead and say we want 2 columns, one on the left, one on the right for all of our buttons. So if I save that and refresh, nothing going to happen just yet because we need to add in the second argument right here, which specifies how much space should each column take up. Well, we're going to go ahead and say that this should take up the full amount of width of each column. So here to get the full width, I'll add in 1FR, which stands for fraction. That just basically means 100%. If I save this and refresh, now you see we have the perfect layout for our attacks. And the nice thing about this is, if I go ahead and get rid of these last 2 attacks, say we only want to deal with 2 attacks right here, if I save and refresh, well, now these automatically fill up the remaining space, and all of our attacks text is already perfectly centered. So this is looking really good, but you'll notice if I zoom in here, well, these buttons have borders, and it doesn't really make sense in this case for them to have borders. So what I want to do is just get rid of that. And I want to apply this to all buttons I create. So I'm going to go up to our style tag and say, select all buttons. And here I want to go ahead and say, all of our buttons should have a border of 0. I save and I refresh and that border is completely gone. But by getting rid of the border, well, now we got rid of that hover effect for our buttons, which was actually pretty nice on the button. It helped indicate what attack we were selecting. So we want to add that back in, and we can do that within our CSS. We can select our button element one more time, and if we add a colon, hover, and then some brackets, now we can determine how our button should look whenever our mouse hovers over this element. So I know I want to go ahead and select the background-color of our button, only when we hover over it though, and I want to go ahead and change that to a very light gray. So here I'm going to use a hex code, and to get a very light gray, we can go ahead and select something like CCC. That should give us a gray we want. We save and refresh, we hover over this, and that is going to give us a nice light gray in which we hover over one of these. If we want to go ahead and make this lighter, well, we'd go ahead up to the next value within the alphabet, up to something like DDD or EEE. I'm going to go ahead and select DDD right here. But if you want to go ahead and make it darker, you would go earlier on in the alphabet towards A. And if you want to make it super dark, well, you would go ahead and select something like 000, because the closer you go from 9 to 0, the darker the color is going to be within hex codes. So if I save that and refresh, that seems to be a light gray in which I can tell I'm selecting this element. It looks really nice in my opinion. Now, one additional thing here is when I hover over these elements, you'll see our cursor remains the same. We can actually change this to indicate that these are clickable elements on the screen. To change that, we're going to go back to our CSS and say we want to reference a cursor property and set this equal to pointer. If I save that and refresh, you'll see right now we have a default cursor, but as soon as I hover over one of our buttons, well, it turns into a pointer instead. So just a nice little added benefit to indicate that these are things that we can click on when we're playing our game. Now, the very last thing I want to do for our interface down here is change our font type. Right now we're using the default font I have on my system. I want to go ahead and change this into something that actually looks like a Pokemon style game. So to get some sort of new font for completely free, what we can do is head on over to Google Fonts. So I search for Google Fonts, I'm going to click the first result. It's going to be at fonts.google.com, and now I can go ahead and find the exact font I want. So by default, this is what your screen is going to look like. You can go ahead and search through all these fonts, choose whichever one you'd like, but I already know I want something that matches our game style, and I already searched through this quite a bit, so the font we're going to use is going to be called Press Start. So we'll type that in right here, and you'll see that automatically filters all the fonts. We have some 8-bit lettering. What we want to do is select this just by clicking on it, and then we're going to go ahead and select the style right here. So it should look like this for you. Select this style. I want to go ahead and click it. And then if I click this right here, view your selected families, it's going to give me some code in regards to how I actually set this up within our website. So right here it says how to use on the web. To embed a font, copy the code into the head of your HTML. So all we need to do is copy this code right here, these 3 links. I'm going to go ahead, select that, right click, and hit copy. And now that I have that copied, I can go back to Sublime Text. Within index.html, I just need to place these within our head tag. But if we look, we don't actually have a head tag specified. Our head tag is typically one of the first things within our HTML file, so let's go ahead and create that. It's going to look like this, just simply head. And now, where does this head tag end? Well, it's going to end at the end of our style tag right here. So anything related to the initialization of your HTML file, whether it be styles, external scripts, typically goes within the head of your site. Everything else beneath it typically goes in the body tag, but to get started, all we need to do is make sure that we add head tags around our style tag right here, and then we want to go ahead and paste in those fonts. We're going to want to go ahead and paste them in as the very first thing within our head tag, because if we do that, then we can go ahead and use them within our style tag. Basically, the styles from these links we paste in right here are going to cascade downwards into the rest of our styles. That is why it's called cascading style sheets. So if we go ahead and paste that in and save it, well, now we can begin making use of this new font. So if we go back to Google Fonts over here and we scroll down a little more, now we have a property that tells us how we use this font in the first place. So what I can do is I can select this property, copy it with Command C, go back to Sublime Text, and now I can paste it on whatever element I want this font to take effect on. So I know I want this on pretty much every element within our game, including our body, our H1, our buttons. So rather than paste this in individually like so, this is just duplicative code. Instead, what we can do is say, right above body, we want to select all elements with an asterisk, add some opening and closing curly brackets, and say our font family for all elements is going to be Press Start 2P. Save that, I go back to our game in index.html, and I refresh. Now you'll see our new font is uploaded into our game. So the last thing I want to do is just make sure that these are all the same size. You'll see this H1 over here is huge, and the only reason I'm using H1 is just so I can see within our HTML, well, this is going to be more of a display label rather than a paragraph or some sort of button. But I do want the H1 size to be the same as these over here. So what I'm going to do is add in a style tag and say that the font size for this element right here should be 16 pixels. That is going to be the default of most elements within HTML. I save that, I refresh, and that is definitely smaller, but if you look really closely, well, this is smaller than this over here. So the default font size of our buttons is going to be 13 pixels, while the default of this element right now is going to be 16. What we want to do is select our button element, and say for all of our buttons, we'll select a font size, and also set that equal to 16 pixels as well. We don't want to do this on all of our elements because sometimes it makes more sense to give different elements different defaults, but in this case, we do want all of our buttons to have a font size of 16, so we'll save that, refresh, and now our buttons are the same size as our label over here. I think this is looking really good to start for our attack bar at the bottom. So with that, we can go ahead and check off add in an attack bar interface. So now we're going to go ahead and add in our health bar interface. And basically what we're going to do here is we're going to draw in 2 rectangles. One's going to be right here on the top left-hand corner of the screen, and one's going to be down here on the bottom right corner of the screen. So this rectangle is going to correspond to MB, and this rectangle is going to correspond to Draggle. Here we're going to list out Dragel's name. Let's go ahead and call that his name. And here's going to be MB's name. And then within both of these, we're going to draw small little rectangles using divs. This is going to represent our health bar. And eventually, as MB or Dragel lose health over time, these are going to shrink. And once one of them hits 0, well, we're going to go ahead and remove them off the screen. But in this video, we're just going to go ahead and get these interfaces on the screen before we add any logic. So let's go ahead and start recreating this little box on the top left-hand corner. To do this, I'm going to find our parent div that has our canvas element. It's going to be this div right here. And right above our canvas, I'm going to go ahead and create a new div. And this is going to represent the top box up here. So within this new div, I want to add a style tag. And I know I want the background color of this div to be white. So if we want to be able to see this, well, we need to give it some width. I'm going to give it a static width of 250 pixels. And to start, we'll say its height will be around 100 pixels. Probably going to change that later on. But if we save this, go back over here and refresh, you're going to see this is representative of our health bar and what we're going to put on the screen. So we want to go ahead and overlay this on top of our canvas. Whenever we overlay something, we're going to go ahead and add on a position of absolute. And we know this is going to be relative to the parent div because the parent div has a position of relative. So if we save that, go back and refresh, now it's on top of our canvas, which is great. We want to go ahead and move this over to the right a little bit, and from the top a little bit as well, to make sure that it has an adequate amount of spacing. So here I can say I want this new div around 50 pixels from the top of the canvas, and also 50 pixels from the left of the canvas. So I save that. Refresh. Now it's looking to be in a pretty good spot, but it's hard to differentiate from our background because we're blending in a light white with a light blue over here. So we want to make sure we give it some contrast with the border. To do this, we'll add in a border style, and here we need to specify the width of the border, so 4 pixels. What color should this border be? I'm going to say black, and then what style? Solid. Save that, go back, and looking to be in really good shape. So the height of this div right here is actually going to be determined by the content inside of it. So going back to our code, I don't actually need the height set to anything because I want to make sure this is determined by the div's contents. So inside of this div, if we look back at this, we need some text that represents the name of the character that is placed on one of these platforms. So inside of here, if I want some sort of descriptive label, that's probably going to be the biggest thing within the element. I like using h1 tags personally. And within this h1 tag, I'm going to put in the name Dragel. Save that and refresh. And now the height of this div is dependent on the actual height of the text inside of it. So this text is just way too big. Let's go ahead and shrink it by adding a style tag under h1. Here we'll say that our font dash size is equal to 16 pixels. Pretty standard for anything within HTML to set it to 16 pixels. Looking pretty good with that, but we do want some spacing around our text and the box to make sure that this is completely legible. So to add spacing on the inside of a box, well, we want to select the box first off. And within that box's style tag, we want to use a padding property. And here, I'm just going to go ahead and say our padding should be around 12 pixels for this box. Let's go ahead and save that and refresh. And that looks pretty good. We have 12 pixels on the top, left, bottom, and right of our text now to make sure that it has the adequate amount of breathing room. So now let's go ahead and add in a health bar. The health bar is going to go right beneath our text, and it's going to be green rather than the red I'm showing in that example over here. So to create a health bar, all I need to do is create a div. Whenever you need some sort of rectangle, it's pretty safe to use a div. Within this div, we'll add a style tag. And now we want this div to take up the full width, which it already does because divs by default have a display of block. Whenever you have a display of block, it's going to have a width of 100%. But we do need some sort of height associated with this, and we can hard code this in by specifying the height of this div is equal to 5 pixels. So now we have a width of 100% and a height of 5 pixels. But we need to go ahead and declare a background color for this div. Here I'm going to set our background color equal to a hexadecimal of pound DDD. I save that and I refresh. And you'll see now we have some sort of health bar in place. But this gray is a little hard to see. So if we want to darken this gray a little bit, we'll just go ahead and say instead of DDD, we want to go down to CCC. Save that. Refresh, that definitely darkened up a bit, and this is basically going to represent the full potential amount of health that a character has. So we do want to separate our health bar from the text up here, and we can do that using margin. So within this health bar, we'll go ahead and say the margin top for this health bar should have around 5 pixels of margin. So if I save that and refresh, now we have a little bit of space. Might even want to go a little further by saying the margin top should be 10 pixels instead of 5. I think that looks pretty good. That's enough breathing room between our text and our actual bar right here. But I said the bar should be green. This gray bar is just representing the full amount of health, but not the actual health that a character has after being attacked. We want to go ahead and create 2 bars. So to create a second bar, I can simply copy this gray bar we just created, paste it, and then we're going to need to reference a background color of not this grayish, but actually a green color instead. I save that and refresh. Now we have a green color in place, starting to look pretty good. But what I want to do is overlay this green rectangle on top of this gray one, and then as we begin shrinking the width of this green rectangle, it's going to show us how much health we have left over after an attack has been made. So to get that overlaid on top of this one gray bar right here, well, we need to make sure that both of these divs are wrapped inside of a parent div. So I'm going to go ahead and do that. I'm going to wrap these 2 in a div, and then for this parent div, I want to give it a style of position relative. Because I know I want to set one of these child divs to have a position of absolute, which means I can move it around relative to this parent div right here. So for our green bar, if I go ahead and give this a position of absolute, meaning it's out of the document layout, and then I give it a top of 0, let's go ahead and save that and see what happens. I save and I refresh, and now our green bar seems to be completely gone. Well, where to go? Well, thankfully, since we're using HTML, we can debug this pretty quickly. We can simply right-click our HTML element, and then hit inspect, and then we can hover over our green bar right here. So it looks like our green bar does exist, but if we look on the left-hand side, we have a width of 0 and a height of 5. So since we made this a position of absolute, well, it kind of takes it out of the document layout, which does away with its width completely. So here we want to say that the left of this bar should have a left of 0, and the right should be 0 as well, and that's going to make sure that it takes up the full width of whatever parent element has a position of relative. So I save that, refresh, and now it takes up the full width, but it's not necessarily positioned correctly. Let's continue inspecting over here in the browser. So if we hover over our green bar, you're going to see it has some orange bars associated with it, which means margin is applied to this element. And you'll see right here that is indeed true. We have a margin top of 10 pixels. Now that margin top of 10 pixels should only be applied to whatever element is actually within the object flow. And that is going to be the gray bar right here. We never applied a position of absolute, which means other elements are going to be pushed down relative to this one element that has height and width associated with it. So here, this is our position absolute. It is not in the document flow, therefore we can remove margin top to make sure that it's overlaid directly on top of our gray bar. So let's go back to our code, delete margin top 10 pixels for our green bar right here, save and refresh, and now that is indeed on top of our gray bar. You'll see if I hover over right here, on both our green and our gray bar, they are laid on top of each other directly. And if I change the width of our bar right here, and I can do this directly in the browser by saying width should be equal to 50% on the green bar, you're going to see this would be representative of when Draggle has been hit and he only has around 50% of his life bar left. So that is how we're going to create the interface for Draggle right here, but we need to do the same thing for MB. We need to basically duplicate this and get it on the bottom right hand corner. So I want to challenge you to pause the video and see if you can do it on your own. So let's go ahead and do it together. I know this div right here, and I'm going to comment this out, represents health bar of Draggle, basically the enemy. So basically what I can do is copy everything from right here up until that div, and then beneath that, I'm going to paste it. And here, this is going to represent the health bar of MB, which is us. So all we need to do here is basically change the top and the left positioning and then the name of the character. So let's go ahead and do that now. We'll change Draggle to MB, and now we just need to change the positioning right here. So our top is going to be 330 pixels from the top of our canvas, and then let's go ahead and say not our left, but our right is going to be 50 pixels. So we're placing this container 50 pixels from the right side of our canvas. I save that, and I refresh, and now this is already placed in the perfect position. It looks great, because all we did was duplicate the code up here, placed it in a new spot, and changed the positioning. So this is looking absolutely awesome, and that's going to set us up for success when we begin adding logic into our game. So now we can go ahead and check off Add Health Bar Interface. So now let's go ahead and move on to our attacks. First, we're going to go ahead and handle tackle. So what is a tackle attack? Well, a tackle attack is simply going to be when we take our player or the enemy up here, and we're going to move them back to the side a little bit. Then we're going to move them forward, and then we're going to go ahead and cause an animation on the enemy, the recipient of the attack, we're just going to push them back and forth a little bit to show that they have been hit. This is a pretty standard attack within the Pokemon games, so I think it makes sense that we cover this one first, plus it's going to be the easiest to code. So I suppose the first thing we want to do is change one of these attack names right here to tackle. So to do this, we'll head on over to Sublime Text, and we know we can do this within index.html. So we'll head on over there, and if I were to start from the top of this file, I would scroll on down until I find one of our attacks, and it's going to be right here. We have attack 1 and attack 2, so let's go ahead and say that attack 1 should actually be tackle. If I save that, go back to Chrome, refresh, now we have a tackle label. So now when we click this, we want to activate that attack. Then we also want to subtract damage from Draggle's health bar. So how would we go about doing that? Well, the first thing we need to do is listen for events, specifically when we press one of these buttons. So we need to make sure that we're adding an event listener to both of these buttons. To do this, we'll head on over to index.js. We're going to find our battle animation code. So if I go ahead and search for that, it's going to be down here at animate battle. So right beneath animate battle, I can start adding in event listeners specific to our battle. So what I want to do is something along the lines of add event listener. And then the first argument here is going to be what event do we want to listen for. I want to listen for a click event. And then we're going to call an arrow function that console logs out clicked, just to make sure that this is working. So if we were to just call this by default, well, we'd be adding this onto the window object. This is the same thing as calling window dot. When we call add event listener by itself, it automatically adds window on top of that. But we don't want to listen for when we click on our whole window. If I were to save this, go back over here and start clicking, even if we were to click over here, this consists of a browser window. So you'll see whenever I click on this while we're still logging out, the text clicked. We want to make sure that we only listen for when we click on one of these specific buttons. So we don't want to attach this to a window object, but rather a button element object. So how do we get our button in the first place? Well, to get our buttons, what we can do is we can call document.query selector. And then we want to go ahead and add all onto the end of that. So what this does right here is it searches through index.html, and it's going to go ahead and find whatever element we specify, but it's going to find multiple instances of that element because when we call this function, we added all to the end of it. So what element do we want to find within our index.html? Well, I think it makes sense to put button right here. So if I were to go ahead and just console log that out, let's go ahead and wrap all of that within a console log statement like so. Save and then refresh over here, open up your console, you're going to see that that outputs a node list full of our buttons. Node list is basically an array. It's a little different of a data type. We don't have to worry about it too much, just know that it's very similar to an array. So in newer versions of JavaScript, what you can do is on top of this node list, you can call a for each statement on top of it. And here we want to say for each what within our buttons array. Well, for each button within our array, we want to go ahead and call the following. So let's go ahead and console log out each button we're currently looping over just to make sure that this works. We save, go back and refresh, and you'll see now we're looping through our buttons. We have the index.html versions of our button elements. That is perfect. That is exactly what we need to start adding events onto these. So now that we're looping over these, what we can do is we can call the HTML button element, and then we can add an event listener on top of it. So what do we want to listen for when we click one of these buttons? Well, of course we want to listen for a click, but then we want to go ahead and call an arrow function to say this is how we're going to respond to that click. So if we go ahead and move this console log right here into our button.addEventListener code and get rid of that old add event listener right here, save and then refresh. I'm going to have to move this over to the side. So if I refresh and I start clicking around, we're not going to see that text logged out anymore, but now if I click on one of these buttons, you're going to see we're logging that out, specifically because we added an event listener only to our button elements. So whenever we click on one of these buttons, what do we want to happen next? Well, I think code-wise, it makes the most sense to select one of our characters, such as MB, and then to call an attack method on top of them. So we'll do that with mb.attack. We don't currently have this attack method, but if we were to go ahead and think beforehand, what does an attack method need? Well, the first thing we're going to need is some sort of object that contains all the data related to whichever attack we're calling. So things such as the attack name, things such as how much damage does the attack do, what type of attack are we launching. We need all that data passed through within this method right here. So that'll be the first argument, data related to our attack. The second argument is going to be the recipient of the attack. These attacks should be interchangeable. Whether or not our own character uses them or whether or not our enemy uses them, we need to be able to reuse these attacks for scalability purposes within our game. So let's go ahead and add these arguments in. And I'm going to do so using one argument, which is an object that contains properties, pretty much the same way I've been doing this throughout this whole tutorial. So I'm going to call enemy.attack, we call an object, and now the first property is going to be what kind of attack we're passing through. This is going to be equal to an object. So let's go ahead and say that the name for this attack is going to be tackle. And then an attack needs damage associated with it. So we'll say tackle has about 10 points of damage associated with it. We can add a type to this. I believe the type within the games are normal for tackle. And that is going to be our first argument. Well, the first property we pass through, the first argument at least, is going to be an attack property. So we have that set up. That specifies the type of attack we're calling. Now we want to go ahead and call the recipient of this attack. So we'll add a property called recipient. Now who is the recipient? Who are we fighting over here? It's going to be Draggle. We created that sprite right up here. So we can go ahead and say our recipient is going to be our Draggle sprite. So now that we're calling attack, well, we need to refactor our sprite class to make sure that it has this attack method inside of it. So we can go back to classes.js, find our sprite class, it's going to be right here, and beneath our draw method, we can add in an additional attack method. It's going to look like this. So we know attack is going to use one argument, which is just an object, but within this one object, we can go ahead and pull properties individually. So what properties do we want to pull in here? Well, we're going to pull in attack, and we're also going to pull in the recipient of the attack as well. So that's how we're going to go ahead and get those arguments, and now we can begin using them within this method. So as I mentioned, for this attack, we want to go ahead and pull MB back a bit, launch him forward, and then move him back to his original position. In order to get this effect, we're going to go ahead and use GSAP, the animation library we pulled in earlier. So within attack, what I can do is I can simply call gsap.to. Now what do I want to animate? Well, I'm going to go ahead and select this dot position. What this does is it gets the position of whatever instance we created using our sprite class. So now that we have our sprite position selected, we can add a comma and then add some opening and closing curly brackets to specify what specific properties within position do we actually want to animate? Well, we want to animate the x-axis of our position. Now, what do we want to animate this to? Well, I want to animate this to this .position.x. So that's going to be our current position on the x-axis, and then I want to subtract 20 from it. That's going to make sure that our sprite moves 20 pixels to the left. If I save that, and then refresh, and then select either one of these buttons, doesn't matter right now, we're going to make sure it only works for tackle later on, but if I select one of these, you're going to see that our sprite moves 20 pixels to the left. It's that easy to get this working with GSAP. So we know we don't want MB to just move 20 pixels, we also want him to move forward around 20 to 40 pixels to give off the illusion as if he's actually going forward and tackling the enemy. So if we need to create animations in succession, meaning that we know we want to call an animation directly after this one, but not at the same time, what we can do is use a GSAP timeline. So that's going to look like this. If I go ahead and create a const of TL that stands for timeline, and set this equal to gsap.timeline, with some opening and closing curly brackets, it's going to create a timeline object. So this is really cool. This still works the exact same way as gsap.to right here. So if I were to replace gsap with tl.to, save, refresh, and select tackle, you're going to see that we still animate to the left, but the difference is now if we were to call .to on top of this, select this .position again, and then say for x, we don't want to go -20 from our original x position, but rather we want to go +40 from it. So what this does is it says we're going to activate this animation first, where we move 20 pixels to the left, and then we're going to go ahead and activate this animation, where we move 40 pixels to the right. So really cool stuff using the timeline object right here. It'd be a lot harder to do this if we were just using that simple GSAP object like we were prior. So let's go ahead and save this, and refresh, and now select tackle, we go to the left, and then we go to the right, so we're beginning to create that tackle animation. Now we do know we want to go back to our original position once those two animations fire and complete, so at the end of this .to, we can add in another .to, and it's a lot quicker to just copy these three lines right here and paste them on at the end, kind of chaining these together. We can say, finally, we should return back to our original X position by removing the +40. That's going to make sure we return to our home position. So I save that, refresh, hit tackle, go forward, and then we eventually move back to where we were previously. Now, running this animation, it doesn't look like a true tackle, simply because MB is doing it really slowly. We want to make sure that when he goes back and launches forward, it's kind of elastic. He snaps forward to really give off that tackle effect. So in order to give off more of a tackle effect, what we can do is, within our second animation right here, where we're moving MB forward, we can specify how long we want this to take. And if we reduce the duration on this to something like 0.1, which is really fast, it's going to look like as if he's charging in and really tackling the enemy. So we can go ahead and say that our duration right here is 0.1. I believe the default is 0.5. I can never remember that. But I think 0.1 is going to be pretty good for what we're looking to do. So I save that and refresh, hit tackle. You can see we launch forward, and that looks pretty good to me. And eventually we go back to our original position. So great, I like the way that looks. But now what we want to do is midway through our animation, when we launch forward, we also want to create an animation on Draggle to make sure that he wobbles back and forth to create the illusion as if he has actually been hit. So we know we want this to occur after we launch forward. That's going to be this .to statement right here. So what we can do here is we can add in a property called onComplete. This is just going to be a simple function. Here we can specify what we want to animate when this one animation completes. So we want to call gsap.to again, and then what do we want to animate? Well, we want to animate our recipient sprite. So our recipient is going to be the Draggle sprite we passed through. Therefore, we can just grab recipient.position because we know we're going to be moving the x-axis right here. And then we can add in a second argument, which is an object, and say on the x-axis, we want to go ahead and animate this about, let's just say, 10 pixels forward. So if I were to save that and refresh over here, tackle, you'll see, well, Draggle's position actually went 10 pixels relative to our canvas right here. So what we need to do is make sure that we're not just referencing 10, but rather our recipient position plus 10. That's going to make sure that he stays over here, and we're only going to be moving him forward by 10 pixels from this exact location. So I save that and refresh, hit tackle. Well, you're going to see now he's removed from the game. So just a little bug, it looks like. And yeah, right here where we're referencing recipient.position, we need to make sure we also add in .x to refer to the x-axis. So I save that and refresh one more time, hit tackle. You'll see that now he moves to the right by 10, so that's looking good. But we might want him to go back and forth over and over again. So now what I want to do is add in a yo-yo property, set that equal to true, and then I want to add in a repeat property, which I'll set equal to 5. So what this is going to do is, if I refresh and hit tackle, yo-yo is going to allow this animation to go back and forth from its original position, and the repeat is going to say how many times do we want this animation to occur. So each time Draggle goes back or forward, that's going to count as one repeat. So if I go ahead and refresh, you'll see if I hit tackle, we go up 1, 2, 3, 4, 5. And that's going to be the end of the animation as we go back to our original state. But that does happen kind of slowly. To give off the effect as if he's actually been hit, we want to decrease our duration. So for these animations, I'll decrease their duration to 0.08. That should be pretty quick. I save, refresh, hit tackle. And you'll see that definitely looks like he's been hit over there. I like the way that's looking. But we can make this even more convincing, and we're going to do that by changing the opacity of Draggle when he's been hit. So we're going to turn the opacity on and off, make it look like he's blinking as if he's actually been hurt. So what we can do here is we can add in an opacity property and set it equal to 0. So what we want to do is select a new gsap.to, which means that this is going to occur at the same time as this, since we're not using any timeline object. Now what do I want to animate? Well, our recipient opacity. That's what I'm going to want to animate, which is why I can't just plop opacity in here, is because opacity needs to be a subchild of whatever object you're about to pass through as the first argument. Since we're passing through recipient.position right here, well, the children property of position are going to be x and y. That's pretty much all we can animate if we're to set things up this way. So we do want to call recipient, but for our second argument right here, we're going to say we're going to animate our opacity down to 0. So if I were to save and refresh this, hit tackle, well, nothing's going to happen because even though we're editing opacity right here, well, we never actually set an opacity property on top of our sprite class. So recipient doesn't actually have an opacity associated with it, and we never told our sprites how they should react when opacity is set on top of those objects. So within our sprite class, we want to go to the top, and then here we're going to go ahead and add in this .opacity. Set it equal to 1 by default. That means the sprite is always going to show by default. And now if we want to go ahead and edit out how our sprite is rendered on the screen, using this opacity property, right within our draw method, we can add in c.save. And at the end of draw image, we're going to add in c.restore. So the reason I'm adding these two in is because I want to use a global canvas property. And if I'm going to use a global canvas property, well, it's going to affect everything on our canvas. What save and restore does is, it says if you're about to use a global property within save and restore, it's only going to affect all the other code inside of it, not everything within your canvas. That is why I'm adding in c.save and c.restore. So after c.save, I can call that global property, which is going to be c.global alpha. And I'm going to set this equal to this opacity. So if we did all this correct, we save and refresh, everything still looks the same. Our opacity is taking effect, but if I decrease this opacity right here to 0.2, save and refresh, you're going to see that all of our sprites now have some sort of opacity associated with them. We can see behind them. Really cool stuff, but we know we only want this to activate when we actually hit an enemy. So I'm going to make sure that our opacity is 1 by default. That is totally okay. And now back underneath attack, we know we are interpolating our opacity down to 0. So let's watch what happens with just this code we already have. Save, refresh, hit tackle. You'll see he eventually fades out over time. That's great if we eliminate the enemy, but we don't want to eliminate him unless his health bar is actually down at 0. So instead, what I'm going to do is, I'm going to go ahead and say, I want this to repeat over time. Let's go ahead and say this should repeat 5 times, and I want this to yo-yo as well. That way we end up back at 1, which we started out at. So I'll say yo-yo equal to true, and I want this to happen pretty quickly. The same speed we called this animation right here, so I'll grab this duration property and add it in to where we're fading out our opacity. So I'll save, refresh, and then hit tackle, and you'll see that looks really good for our receiving animation on getting hit. So now we need to actually decrease Draggle's health bar whenever he gets hit by that attack. To do this, we're going to head on over to index.html and we're going to find Draggle's health bar. So if I scroll on up, we made some comments right here that says this represents the health bar of Draggle. That is perfect. So what I want to do is find the green health bar section. That's going to be this right here, which we can tell since background color is equal to green. I want to go ahead and add an ID onto this and say that this is going to be enemy health bar. So if we go ahead and set an ID right here on top of this div, now if we go back to classes.js, we can select that ID directly and then animate it. So now that we have that ID in place, how do we actually decrease the width of our enemy's health bar? Well, we know right here with incomplete, this is where enemy actually gets hit. So within here, we can call a gsap.to on top of an element that has an ID as indicated with a # of enemy health bar, the same ID we created within index.html. So now that we have this element selected, what do we need to do? Well, we need to go ahead and select the element's width and then decrease it. So let's go ahead and just say by default this is going to be equal to 50%. Let's save that, refresh, hit tackle. You'll see that goes down to 50%. That is perfect. That's exactly what we want. But we do want to declare the width of this health bar should only go down by the amount of actual damage we pass through within this attack object right here. So looking back within index.js, remember, we pass through an attack object that has a damage property associated with it. We want to select that damage property and then use that to decrease our enemy's width right here. So instead of referencing 50%, what I'm going to reference is attack.damage, which we pass through right here. And then I want to make sure that I add onto this a percentage string so that this knows our width should be some sort of percentage and not some static value. Refresh and then hit tackle. You're going to see that goes down to 10% because that is actually what attack.damage is. What we really want to do is get our recipient's health, which is going to be 100 to start. And then once they get hit, that's when we're actually going to subtract 10. That's going to give us a more accurate result compared to how much damage tackle should actually give off. So if I want some sort of health associated with our sprites, what I can do is I can go up to our sprite class and say this dot health is equal to 100. And then later on, if you want to scale your game, you can assign different healths to different enemies. So if you have a really strong enemy, you can give them a health of 1000, 2000. Doesn't really matter. However you want your game to go, you can go ahead and increase this by passing it through as an argument. But for our case, it's okay to leave this as just 100 for a simple game. So I'm going to go ahead and say that both our player and our enemy's health should be 100. And now when I'm animating our health bar, right about here, what I want to do is I want to subtract from our health. So this dot health, the damage that's coming from our attack, and then I'm going to add on this percentage right here. Now, if I'm going to use this dot health, when I call on complete, I can't use this syntax because this dot health is going to be within the scope of this function right here. If I want to go ahead and get this dot health outside the scope of this function, I need to make sure that on complete is actually an arrow function, like so. So now I can get this dot health from our class. That is perfect. And now I'm going to subtract attack.damage from it. So if I save, refresh, hit tackle, you're going to see that only goes down by 10%. That is perfect. So that's going to take care of the beginning for this tackle animation and responding to it with our health bar. But we also want to make sure that our enemy can tackle us. That way we're making our game as scalable as possible. And that way we can just reuse attacks, whether it be for us or the enemy on the other side of the platform. So if we want to go ahead and reuse this for our enemy, what we can do is head on over to index.js. And instead of calling mb.attack, we're actually going to call draggle.attack. So we know we want a tackle animation, but our recipient in this case is going to be MB. So we just want to replace those two. So let's go ahead and save and refresh and see what that looks like. If I hit tackle now, well, you'll see that almost actually lines up, which is pretty awesome, honestly, for how much we've actually coded. But we do know when we call tackle, we want draggle to line up in the other direction and then launch forward. So we just need to edit our code a little bit within classes.js. Basically, the code we're going to be editing is going to be this 20 right here and this 40 right here. So we're going to want to create a let called movement distance. This is going to be equal to 20 to start. Now what we can say is if we're using an enemy by declaring this dot is an enemy, then we want to go ahead and change our movement distance to a negative value. So movement distance in this case would be equal to negative 20 instead of 20 like it is right here. So now what we can do is we know right here, this declares how far back do we want to move. We can replace this with this let that is going to be determined on whether or not we're using an enemy. And here we want to go ahead and replace that with movement distance times 2 because we know that was supposed to be a value of 40. So 20 times 2 is going to be 40. We move forward 40 pixels. We save and refresh. Tackle still looks the exact same because draggle does not have an isEnemy property associated with it. So we scroll on up, go up here. Here we can declare this dot is enemy is equal to, well, it kind of depends. I think this is something we'll actually have to pass through as an argument up here. So this dot is enemy is going to be equal to is enemy. Now we can go ahead and add this to our argument constructor list right here. Say is enemy by default is going to be equal to false. And now all we need to do is find draggle in index.js, which is going to be right up here on line 333-ish for me. And now I can add in that property that says is enemy, set it equal to true, and that should change our distance code within our attack animation right down here. So if I save, refresh, hit tackle, now he's moving back, and when he goes forward, well, we still get the same reaction from MB right here. Really cool stuff. But something else we need to take into account is when we run this animation, while we shouldn't be subtracting draggle's health, we should be subtracting MB's health dot here. So we need to do basically the same thing we did for our movement distance. We just need to say that let health bar, so the health bar element, by default is going to be equal to what? Well, enemy health bar. So I can go ahead and say that this is equal to a string with an ID of enemy health bar. But if this is an enemy, then I want to go ahead and set our health bar equal to what? Well, our player health bar, which we can get with an ID of player health bar. Now, if we're going to go ahead and reference our player health bar, we need to make sure that we're setting this within index.html. So we know right here, this is our enemy health bar, but if we go on down, this right here is going to be our player health bar. So I can go ahead and right here, where the background color is green, I know this is going to be our player health bar. So once I add that ID in, I can go back to classes.js, see that that matches up. So now that health bar is assigned based on whether or not is enemy is equal to true, we want to make sure where we're actually animating our health bar that we're referencing the correct ID. So we'll go ahead and get rid of this down here, the static value of enemy health bar, and then reference health bar instead. So I save that, refresh, hit tackle. You'll see now that subtracts from MB's health bar rather than draggles. And we want to go back to index.js and just switch within our event listener, draggle and MB one more time to make sure that all this code works in reverse. So MB is going to attack draggle instead. Save, refresh over here, hit tackle. Everything looks great, and we do subtract from draggle's health bar. Now, one more thing that I want to do before we finish up tackle is, you'll see if I hit tackle again, well, this just isn't subtracted over time. It just stays in place even though we damage draggle one more time. We want to make sure that this subtracts for each instance we call tackle. So this is a pretty easy fix. Right here, when we're assigning our health bar's width to this.health minus attack.damage, we're never actually setting this.health to a new value for each instance we call attack. We need to make sure that we do exactly that. So what I'm going to do is I'm going to take this statement right here, right beneath where we're calling our timeline, I'm going to go ahead and say that this.health is equal to this.health minus attack.damage. This is going to make sure that this updates over time so that when we go ahead and call, well, this.health right here, it's going to animate downwards for each instance we actually call attack. And if you want a shorthand version of this, well, this right here is the exact same thing as minus equal attack damage. Just a little way to clean this up in your code a little bit to try to make it as readable as possible. So I save that, refresh, hit tackle one more time. That decreases. If I do it again, continues to decrease, and it'll continue to decrease until we hit 0. And that's just not going to show anymore. We're going to add some logic in there that ends this battle as soon as that happens, but I think this is a pretty good place to go back to do and then check off attacks tackle. Alright, so now we're going to move on to our fireball attack. So how's this going to work? Well, essentially, here's what's going to happen is on top of MB, we're going to create a new sprite right about here. And then we're going to go ahead and animate that sprite over to Draggle's positioning. We're going to go ahead and subtract from his health, make him shake a bit. But that's essentially the gist of it. The main thing you need to know is we're going to be creating a sprite on top of MB and then animating it to give off a realistic effect. Now, before we do that though, you might notice over here, we're still using attack 2 for this button. Let's go ahead and start changing that over to fireball. So within index.html, we're going to want to find attack 2, and I'm going to go ahead and change this to fireball. Save and refresh, and now we have an option for fireball, but you'll notice once I click this, we're currently activating tackle. So now we're going to want to go ahead and find some sort of way to make sure that when we click fireball right here, we activate a fireball animation, and when we click tackle right here, we activate the tackle animation. So we want to differentiate between the two. To do this, we're going to go into index.js, and we're going to find where we are creating our event listeners for our battle. So I'm going to scroll on down a bit till I find animate battle. It's going to be right here. And then down below, you'll see that this is going to be our event listeners for our buttons. You can go ahead and list that these are our attack buttons. So this is where we're going to want to determine what attack are we currently clicking. So what we can do here is within our actual event listener, we can pass through an event object. So if I console log out our event object, it's going to give us tons of different properties associated with the actual click of one of these buttons, but I already know on top of this one event object, I want to reference the current target. This is the current HTML element we're clicking. It's going to give us our button HTML. And once I get that button HTML on top of that, I can call inner HTML, and that's going to give me the text inside of our button HTML. So if I go ahead and save this, and I refresh and make sure I have my console open, and then I go ahead and click fireball, you're going to see that is giving me the contents of this button right here, simply the text fireball. If I do the same thing for tackle, you're going to see that gives me tackle. So we want to go ahead and select the event object for the current button we're clicking on, get the current target, that's the HTML element, and then finally we want to call inner HTML to get the text. So now based on this text right here, we want to go ahead and get a data object associated with the attack we chose. So this is a data object associated with tackle, has a damage of 10, and a type of normal. We want to go ahead and do the same thing, but get the data object for our fireball. So the name would be something like fireball, have more damage, be a type of fire. So basically what I want to do here is not reference an object directly for attack, but I'm going to go ahead and take this on out. I'm going to cut this current attack object, and I want to go ahead into our data folder. And here I'm going to hit Command N to create a new file. So I'm going to go ahead and create a const and set this equal to an object. And then I'm going to save this by hitting Command S within data. I'm going to save this as attacks.js. So what this is going to be is a comprehensive list of all the attacks we can use within our game. It's good to make this organized, separated from our game logic, because now we know we can change this in one specific location, but the rest of our game is still going to work because we're separating our data from our view. So inside of this const, I'm going to go ahead and say, well, what was that first attack that I had? It was called tackle. That is going to be the property name. This is going to be equal to the tackle object that I just cut out from index.js. And you'll see I actually forgot the const name right here. This should be attacks. So make sure you put that right there when you're declaring a const. Obviously, const needs a name. But within this attacks object, we have our first attack listed out. It's going to be tackle. So now that we're here, we can duplicate tackle and then add a comma to the end of this, and we can begin creating our next attack. You can think of whatever you would like, create whatever attack you want right here, and then you can implement the associated animation to create the effect you want. This is going to be really scalable and really cool. So instead of tackle, I want to go ahead and reference fireball. And I know the name for this is going to be, well, fireball for fireball. The damage for fireball should be a little higher, so I'm going to say that it should be equal to 25, and then the type for this is going to be fire. So now we have the two attacks we want within our game. We need to make sure that we import this into index.html. So we have our data/battle zones, we have data/collisions. We're also going to want data/attacks.js. So this right here just references data attacks.js. And we want to make sure that we call this before classes in index.js, because since we're importing this the old school way, well, we need to make sure that this is loaded before we can actually use it within classes or index.js. So make sure you save right here within index.html. Now back within index.js, we should be able to select that attacks const. So when I go ahead and click, I want to log out the current inner HTML, but I also want to log out attacks. And since we're importing this the old school way, this is going to be available to us by default. We imported it within index.html, and within attacks.js, we call it const attacks. So this is what we're currently selecting, is the const of attacks, and that's what we should see when we console log this out. Let's go ahead and comment out this code right here, save, refresh, and then hit fireball. And you'll see right here, we console logged out that object that contains all of our attacks. So now if you think about this, we're logging out the button we currently clicked on, which is fireball, and now we have two properties inside of this main object, which represent our attacks. How do we select just fireball right here? Well, this is how we're going to do it. We're going to select our attacks object, which we already have, and we know we want the fireball object, which has a name of fireball. So what we can do here is add some brackets, and then take this right here, our current target inner HTML, paste it inside of the brackets, get rid of the first console log, save and refresh. So now we're going to be using this text right here to select within our main attacks object the attack we want to use. So if I go ahead and select fireball, you'll see now we are grabbing the data specific for fireball. But if I go ahead and select tackle, now we're getting all the data associated with tackle. And this is a really nice way to get things, because within attacks.js, since we're assigning this to an object, well, we're basically using some hash map functionality to really quickly grab the data inside of these. We're not using an array, so we don't have to loop through all of our data set to find what we're looking for. We're just immediately getting the attack we want. So we're also keeping performance in mind here. We're using a hash map, which is very quick for selecting whatever data you would like to grab. So this right here is going to give us our selected attack, and if we have trouble remembering what this actually does, it's probably a pretty good indicator that we want to create a constant or some sort of variable. So I'm going to go ahead and cut this out of the console log, delete the console log, and then say this const that's selected attack is going to be equal to this right here. This is the attack we're currently selecting. So now we can uncomment this code right here and say for attack, the attack we want to use, we're going to set that equal to attack we just selected based on the click. So if we save and refresh this, well, using fireball is still going to have the same effect. Same thing with tackle. They're just both going to activate the tackle animation. The only difference being is when we use fireball, it's taking into account the fireball damage. So that's already set up, which is great. But we do want to make sure that we're activating a different animation specifically for fireball. So here's what we're going to do. We're going to go on over to classes.js, and right within attack, we want to go ahead and call a specific animation based off of our attack's name. So right here, I'm going to use a switch statement to say I want to switch out our attack name with specific cases. The first case is going to be tackle. So this way, when we call tackle, we only want to activate the following code between our case statement and this break statement right here. That means all this code right here is associated with our tackle animation. So I'm going to cut that, paste it in between our case and break statement, and now whenever we call tackle, we're going to activate all this code right here, responsible for our animation, but now when we call fireball, this is no longer going to fire. So if I save that to refresh, we hit tackle, tackle still works, but if I hit fireball, no more animation in place, which is great. Now we can go ahead and create a new case right above tackle that says what happens when our attack name is equal to fireball. Well, if that's the case, we want to call the following code between this case statement and this break statement. So what's the very first thing we want to do here whenever we call fireball? Well, we want to create a new sprite, which is going to house the image for our fireball animation. So to get this fireball animation, we want to go into our Pokemon Assets folder within Google Drive, go inside of Images, and then we're going to want to get fireball.png. So I'm going to go ahead, hit Command-C, and then I'm going to go back to our project directory, so Pokemon Game, Image, and then paste that on in. So now I have Fireball in here, and you'll see this is just a simple sprite sheet for a Fireball, also obtained from the Ninja Asset Pack for free. So now that that's in place, I can go ahead and begin creating a new sprite within this case statement. So I'm going to declare a const, set it equal to Fireball. This is going to be equal to a new sprite. So what does a sprite take? Well, it's going to take a position with an X and a Y. So where should this be spawned? Well, our Fireball should be spawned somewhere where MB is placed. So we know we can get MB's position with this dot position dot X, and then for Y we can get MB's Y position with this dot position dot Y. And then we need some sort of image associated with this new sprite. So I'll say our image should be equal to a new image element. That means we need to create this new image element. We can do so right here. So I'll say const fireball image is going to be equal to a new image object, like so. And then I need to set the source for this. So I'll say fireball image.src is equal to what? Well, we're currently within classes.js, so we can hit dot slash. We know we want to go within our image folder, so we'll hit img, and then finally we want to select fireball.png, which we just dragged in. So I'll grab fireball.png. And now that I have fireball image and have the source attribute set, right here, when we are creating a new sprite, I can go ahead and set that image equal to fireball image. So if I save, refresh everything, it's still going to look the same because now that we have a fireball sprite created, we need to actually render it out within our animation loop. How would we do that? Well, within index.js, we're going to want to go ahead and make sure that we push this newly created sprite into something that renders out within animate battle. Currently, we're rendering out our battle background, Draggle, and Emby, but we need to render out things that are dynamic, such as newly created attacks. So what I want to do here is create a const, and this is going to be called rendered sprites. So I'm going to set this equal to an array, but I already know what I want to do with this. So right here, I'm going to start looping through this with rendered sprites, .for each, and then I can say for each sprite within this array, I want to call that sprites draw function. Now this isn't going to change anything, but what this allows me to do is push new sprites into this array, and by default they're going to be rendered out because we're going to be calling the draw method just based on this loop right here. So what I want to do to be safe with my code is I want to push this through as an argument whenever we actually select an attack. So I'm going to copy this right here. When we call attack for whichever sprite is actually attacking, here we want to go ahead and put through the rendered sprites array. So basically we're going to grab this, push it into our class, and then we're going to push a sprite into this through our class, which is going to go back here and draw out the sprite. But now within classes.js, all we need to do is grab the rendered sprites that we passed through attack right here. And then we'll say for our rendered sprites, we want to push in the new fireball sprite we just created. So this is our fireball sprite. We're pushing it into rendered sprites, which we're getting through our argument right here. So by doing this, we should see the sprite rendered out on the screen. Let's go ahead and save, refresh, hit fireball. You'll see our sprite is indeed rendered out. That is perfect to start. Now we want to get this animating, so we know we need to add a few more arguments when we create this sprite. The first one is going to be frames. We know frames is going to be an object with a max. What is the max amount of frames with this sprite right here? Well, we can count them. 1, 2, 3, 4. Simple enough, right? So max is going to be 4. And then how long do we want these to hold for? I think it makes sense by default to say 10. So we'll just put 10 right there. And then finally, we know in order for this to animate without us moving, we need to say that this animate property should be equal to true. So if we save that and refresh and then hit fireball, now we have a moving fireball on top of Emby ready to be launched onto Draggle. So let's get this thing moving from Emby over to Draggle. So to get our fireball moving, what we're going to want to do is call gsap.to. Now what do I want to animate? Well, our fireball sprite, specifically its position. So now that I have its position grabbed, I could say for the X position, I want this to animate to our recipient's position on the X axis. So our recipient is going to be simply Draggle right here. And now we want to do the same thing for Y. Say we want to get the recipient's position on the Y-axis, so Draggle's position on the Y-axis, and on save and refresh, we hit fireball, and you'll see that travels over to Draggle. So once this travels over to Draggle, the next thing we want to do is remove our fireball from our render array, because we know we no longer need it. We're just going to take it out of our animation completely. So what we can do here is, when we call gsep.to, we can call on complete. And we're going to set this equal to an arrow function. And whenever we complete this animation right here, we're going to grab our rendered sprites array. And we know that we just pushed in a new fireball. And since this was the last thing pushed in, we can simply call pop, which just removes the very last element of an array from the very end. So if I call rendered sprites.pop on complete, refresh, hit fireball, as soon as it touches Draggle, it's removed from the scene. Perfect. So now let's go ahead and make sure that when the fireball hits Draggle, well, he still shakes left and right and has that opacity effect. So this is going to be quite simple. We already know we did this within Tackle. So what we can do is find where our enemy actually gets hit. It's going to be right here. We want to grab all this code related to our enemy getting hit, copy it, and then paste it into this on complete when our fireball actually hits Draggle. So if I go ahead and add this in here, we're going to go ahead and animate our health bar. We're going to go ahead and animate Draggle's position and also Draggle's opacity. But right here, if we're trying to animate our health bar, you'll notice up above, health bar isn't actually declared before any of this code. So we know health bar is declared within Tackle. We want to grab this right here. We know our health bar is going to be global and used within every attack we actually call. So if I grab these two lines, take them out of Tackle, and paste them right after attack, That's going to make them globally accessible within each of our case statements right here. That is what we definitely want. So now that health bar is available to us, you'll see that we can use it within our onComplete right here for whenever we call Fireball. So I save that, and I refresh, I call Fireball. We're going to get the animation where he moves left and right, and the opacity fades out, but you'll notice our health bar did not actually decrease over here. And that's because we need a little more refactoring. You'll see right here, within width, we're using this .health, but let's see, where is this .health available to us? Where are we actually changing it? Well, the only place this .health is being changed is currently within tackle, but we know this .health is going to be changed for each instance we actually call an attack. So we can take the code right here, cut it out of tackle, and same thing we did with our health bar. We're just going to go ahead, paste that code on in, and say for whatever attack we just used, we want to subtract from this current sprite's health the attack damage that was passed through right here. So I save that, refresh, use Fireball, we subtract 25 damage from Draggle. If I use Tackle, now we're subtracting 10, so it works for both Tackle and Fireball. Now another thing we might want to do is make sure that our Fireball spawns in front of MB, not behind him. Just give off a little bit of realism for our game. So to get this rendered out in front of MB, we need to determine the z-index of where this Fireball is rendered out on our screen in relation to MB and Draggle. So to start, we're going to want to go over to index.js and focus on animate battle right here. So we have our rendered sprites array, but currently the only thing inside of this is going to be our actual attack sprites rather than things such as Draggle or MB. What we want to do is actually put Draggle and MB inside of this array to start. So to do this, we can grab Draggle, put him within rendered sprites, and then also grab MB, put him in there too. And now that we're putting these inside of rendered sprites, well, we're going to loop through those sprites and then call the draw method on top of them. So this code is duplicative. We don't need to call these two lines right here. Might even be a little cleaner just by starting with this. Make sure you save and refresh and that these two are still being rendered out, which they are. And now when we create a Fireball sprite, when we click this right here, we're going to create that sprite and we're going to place it right in between Draggle and MB. So we're going to draw Draggle, we're going to draw our Fireball, but since we're drawing our Fireball before MB, it's going to make sure that the Fireball is drawn in front of MB rather than behind him. And it's a good thing that it's drawn after Draggle because we want to make sure that the Fireball actually shows on top of Draggle rather than goes behind him. So that's why we're going to be placing our Fireball in between the two rather than before or after. So whenever we push into rendered sprites, which is going to be within classes.js, specifically right here, we don't want to push into it anymore because push means place the sprite at the end of the array. So to get this effect, what we can do is we can call rendered sprites, but we're going to use a splice method instead. So the first argument for splice is going to be the index in which we want to go ahead and either place something or take something out. So the index in which we want to place something, if we look within index.js, is going to be 1, because Draggle is going to be 0, MB is going to be 1. We want to place our attack actually where MB is and push MB to the right. So we're going to put 1 right here for a destination index. And then how many elements do we want to remove after this index? Well, 0. We don't actually want to remove anything. We want to keep MB where he is, just push 1 to the right. Then finally, what element do we want to add here? Well, it's going to be our Fireball. So now that we have this splice code here, this is going to function exactly the same, but put Fireball right before MB within our array. We can delete push, save, refresh, and watch closely where MB is. You should see the Fireball spawned in front of him rather than behind him. I hit Fireball, that is indeed spawned in front of him, and then it is spawned on top of Draggle, which is great, but in the end you'll see MB disappeared, because if we look at the very end of our animation, well, we're popping off the last element within render sprites, which is now going to be MB. So instead of calling pop, what we want to do is we want to call splice, and then we want to determine from what index do we want to take out an element. Well, the first index, because that is where we put Fireball right here. And then how many elements from this first index do we want to take out? Well, simply just 1. And that's all we need to call here to make sure that we're removing our Fireball rather than MB. So I save and refresh, I hit Fireball, you'll see the Fireball is removed perfectly. Now another thing I want to do to our Fireball is make sure that it's rotated correctly. Right now it's currently facing up, it is not rotated in the correct direction to actually hit Draggle. So I want to make sure we give off as much realism as possible by adding in some rotation to our sprite sheet right here. So to add rotation to our attack sprite, well, we know our attack sprite uses our default sprite class. Here we can add in an additional property called rotation, and this should be equal to whatever rotation we pass through as an argument right here. So I'll add in that argument of rotation, and by default, this is going to be equal to 0. We should not have any rotation by default. But if we do pass through a property of rotation, well, we need to edit how our image is actually drawn out on the screen. So rotation is also going to be a global canvas property, which means we need to use this within save and restore to make sure that it only affects this image right here and not everything within our canvas. Now, rotating elements within our canvas is a pain in the butt, but here is how we're going to do it. We're just going to assume that we're rotating MB rather than our fireball for illustration purposes. So when we call a global function like c.rotate, by default it starts on the very top left-hand corner of the canvas, and then it goes ahead and rotates from this one point up here. We want to make sure that we're rotating from the center of whatever sprite we wish to rotate. So what we need to do is we need to translate this point right here to the center of whatever sprite we want to rotate, which means we need to call some functions like c.translate to get this point right in the center. So that's what we're going to start off doing, is translating our point to make sure that we can rotate this correctly. So right after save, I can call c.translate. This is a global canvas translate function, which is going to move that rotation point. So by default, this starts at 0, 0, which is going to be the very top left-hand corner right here. Now, how would I get this moved from the top left-hand corner to the top left-hand corner of our actual sprite? Well, the top left-hand corner of our sprite right here is going to be defined by this dot position dot x and this dot position dot y. That is going to give us the top left-hand corner of our sprite. But we want to rotate from the center of our sprite. So our point is currently right about here. How do we move this point to the center of our sprite? Well, we're going to want to add onto the top left corner our sprite's width. So this dot width divided by 2. We want to do the same thing for position.y, but instead add on this dot height divided by 2, and that's going to make sure that our point is moved into the center of MB right here. So now that the point is moved right here in the center of MB, we can call c.rotate, which is going to give us the perfect rotation on whichever element we edit the rotation of. So after we translate that point, we can call c.rotate, and rotate is going to take degrees but in radians. So radians is a whole nother topic. I definitely recommend checking out my circular motion video to learn a bit more about them. But to give you an idea of what rotate takes, the value 0 is going to rotate our sprite by, well, 0 radians. But if we want to go ahead and rotate this by a full 360 degrees, we go ahead and say that that should be equal to 6.28 math pi times 2. So we only want to rotate this by about 1 radian. I think that should be right. So let's go ahead and call c.rotate by 1, which is going to be 1 radian. That should rotate at about 45 degrees, I believe. Let's just call that, see what it looks like. But now that we call rotate, we want to translate that point, which we moved on top of MB right here. We want to translate all the way back to the beginning of our canvas. Otherwise, canvas is not going to render this out correctly in the correct positions. So to translate that back, we can simply call c.translate again. All this code right here, we're just going to call it after we call c.rotate, and then we're going to make these negative values. So let's say we want to translate back by our current position, and we want to subtract from this our width divided by 2 and our height divided by 2. So all that's doing is moving our point from here back up to the start of our canvas, where all of our canvas elements are drawn relative to. So if we save this and refresh, you're going to see everything is indeed rotated. But these are all the things we created using the sprite class within our game. So we rotated everything by 1 radian, which is about 45 degrees. You'll see this is about 45 degrees-ish. But we don't want to rotate everything. By default, we're only going to rotate by the actual rotation we set whenever we create a sprite in the first place. So we say we want to rotate by this dot rotation. Well, we declared that rotation by default right here is going to be equal to 0. So since that's equal to 0 by default, if we save that and refresh, everything's back to normal. The only thing we actually want to rotate is going to be our attack coming from MB. So where is our attack being declared? It's going to be whenever we call a case of fireball right here when we're creating a new sprite. So here we can add in an additional property called rotation. And now if we go ahead and set this equal to something like 1 radian, save and refresh, everything else still looks the same, which is great. But if we call fireball, you'll see that was rotated almost perfectly to look like it's actually traveling towards MB. Watch one more time, hit fireball, and that's rotated perfectly and creates a really awesome effect for our fireball attack. Now finally, the last thing we want to do is make sure that this works if we were to receive a fireball from an enemy. So Draggle is a normal type, but let's say we create another fire type enemy. Well, we want to make sure that this animation we just created works for the enemy as well. Makes sense. So in order to do this, we want to go to index.js. And here, where we're calling mb.attack, we're actually going to call Draggle.attack instead, and say that the recipient should be mb, which means it's going to come from Draggle to mb down here. So save that, refresh, and let's just see what it looks like. If I go ahead and call fireball, Well, that looks almost perfect, almost. The only thing I would say we need to change is going to be the rotation of our fireball. So based on whether or not we have an enemy, we're going to rotate that in a different direction. So over in classes.js, we need to change rotation right here based on whether or not we're referring to an enemy. So at the very top, let's just go ahead and say that this is going to be global to start. We can declare a let called rotation. This is going to be equal to 1 by default. So now that we have a let of rotation, we can go ahead and get rid of this equal 1 right here, and just use rotation like so, because this, without assigning it to anything, is the exact same thing as this. If this has the same name as the actual assignment, you do not need the assignment or the colon. This is the exact same thing, it's just shorthand, so it's a little cleaner. So that should still work the same. Save and refresh, hit fireball, and it does indeed look the same, but we want to make sure that we're rotating that based on whether or not this is an enemy launching it. So here, beneath let rotation, we can call if this is an enemy, what do we want to do? We want to set our rotation equal to something else. So let's go ahead and say that our rotation should be equal to -1 for our radians instead. See how that looks? We're just going to do some guesswork for this in order to get this done as quick as possible. Save and refresh. And that looks a bit closer. Let's go ahead and declare this should be -2. Save and refresh. That's pretty close. Maybe we want to touch it up a little bit by saying -2.2. Save and refresh. I think that looks pretty good for our fireball coming from an enemy. So just to make sure this works, we want to go back to index.js, go back to MB, and switch out MB for Draggle right here. Save and refresh one more time. And now this should still be rotated correctly when it comes from MB still. Hit fireball, and indeed it is. So looking great. So we can go between fireball and also tackle now. I think that means if we go back to to-do, we can successfully check off attacks fireball. So the next thing we're going to do is queue up dialogue for our game. So what do I mean by this? Well, whenever we click one of these buttons right here, whether it be tackle or fireball, well, we want to display some text on top of this that shows what attack we just used. Then we're going to want to queue up some dialogue for whatever attack our enemy uses, but we do need that dialogue in place so we understand what exactly is going on within our battle sequence right here. So the first thing we're going to do is we're going to create that dialog container, and basically it's just going to be this large rectangle that's overlaid on top of all this stuff right here. So we're not going to see our attacks, we're not going to see our attack type or anything like that. We're just going to see text overlaid in the top left hand corner right here. So how do we go about developing that? Well, we're going to want to head on over to no other than index.html. And then we need to decide where we want to put this container within our HTML. So I think it makes sense to put it within this div right here. This div right here represents everything within this red rectangle currently. We're just going to create another one that's overlaid on top of that. So we know this one div is our main white container. We're going to create a div inside of it, and I'm going to write some dummy text. It doesn't really matter what you write inside of there. I just want to save, refresh, and make sure that shows up, which it does. So it's showing up, but it's affecting our other layout within our attack box, specifically for tackle and fireball. We're going to want to make sure that this is position absolute. We don't want other items being pushed around by this one container right here. We want this one container to overlap everything within this bottom bar. So to do this, we can add a style tag and say our position is going to be absolute. That's going to take this div out of the layout. Just with that, if we save and refresh, you're going to see it's no longer pushing things around, which is great. But we do want this to fill up the entire width of that container. So to do that with a position absolute element, we can do it with top 0, right 0, bottom 0, and then left 0. So we're saying the sides of this rectangle right here should be a distance of 0 from the top, right, bottom, and left of the parent div that has a position of absolute or relative. So we do that, and now it's going to extend the full width and height of the container, but we can't really tell because we need to add a background color to this as well. So I'm going to add in a background dash color, set that equal to white, refresh, and now you can see that takes up the full width and height of that container div. So this is looking great for our dialog box, but we do need some padding right here, otherwise our text is going to be a little hard to read. So to add some padding here, we'll just add a padding style. Let's say that this should be equal to 12 pixels. So I save that and refresh. Now our dialog box is looking really good. So now that we have this dialog box in place, we really only want it to show when we choose an attack or when the enemy attacks. So by default, you'll see when I refresh, well, it's showing we don't want that. So actually, we're going to add in a display of none to the style tag right here, and that's going to make sure that that box is hidden and we can select elements that would be behind it otherwise. So now we want to go ahead and show that box and populate it with text based on which attack we choose. So if we want to populate this box, we need to give it some sort of ID. And I'm going to give this an ID of dialog box with a capital B. So now that I have an ID here, I can go ahead and select that within index.js, classes.js, wherever we want to select it. So if we think about it, I think it makes sense to actually select this within classes.js and change the text based on which attack we actually chose, whether it be tackle or fireball. So we know whenever an enemy attacks, well, we run the following code, but we're also going to want to unhide our dialog box. So here we can do that with document.querySelector, and we want to select an element with an ID of dialog box, like so. That is how we're going to get our element. Now that we have this element, we can go ahead and reference its style property, and on top of that we can say what style do we want to change within JavaScript. Well, we're going to change the style of display and set that equal to block. That was the default before we set it to none. So we save that and refresh, and now if we choose an attack, whether it be tackle or fireball, now that displays again, but this doesn't make any sense. We want to make sure that this text is legible and actually exhibits what attack we just used. So we're going to extend this a little further. We're going to select our dialog box again, which I can do just by copying document.querySelector, and now I can change its inner HTML with some new text. So if I write in new gibberish right here, even longer, save and refresh, and then use one of these, you'll see now we have that new text in place. So we're going to want to grab the name of the sprite currently using the attack. Right now, if we look on our sprite properties, we don't have anything associated with name. So we're going to want to add that. I'm going to add that with this.name and set it equal to whatever name we pass through within our property right here. So name by default isn't going to have anything associated with it. That is totally okay, but now we can go ahead and use this.name right here when we're setting inner.html for our dialog box. So I want to say our dialog, whenever we attack, is going to be equal to this .name. So this is going to be something like MB or Draggle. We want to say MB used. So MB space used space, what did they use? What attack did they just use? Well, they're going to use the attack we passed through right here, and that attack definitely has a name associated with it already. So basically what we're saying right here is MB used fireball or tackle, but this isn't going to work unless we concatenate it with pluses, so I'm going to add those in between our variables and our string right here. And now if I save that and refresh, if I use fireball, you're going to see we populated the text with undefined used fireball. We're only getting undefined right here because when we created our MB or Draggle sprites, well, we never passed through that name property we just created. So we need to make sure we do that. We can go over to index.js, and then we can go ahead and find our battle animation, which I'll do with Command F and find animate battle. And it's going to be right here on line 364. So now I know above this, well, this is where I created the MB and Draggle sprites. So let's start with Draggle. I'm going to go ahead and give him a name property of Draggle. Now I can go ahead and use that within the actual class. Same thing for MB. I'm going to give him a name of MB. So I save, I go back, and I refresh, and now when I use Fireball, you're going to see it says MB used Fireball, and I can't really go to the next step in this process, which we're going to get to, but I think before we get there, it actually makes sense to refactor our code a little bit. You might have just noticed, while it was kind of hard for me to find the animate battle function. If that's the case and things are getting hard to find, well, that's a good clue that you should probably refactor your code a little bit. So what I want to do is move all of our battle sequence code into a separate file, and that way I can easily differentiate between our battle sequence code and also our map animation code. So what contains everything related to our battle? Well, it looks like everything right here, where we're adding event listeners onto our button, everything from the bottom right here, if we go on up to our battle background image, I believe that is everything associated with our battle. I want to go ahead and cut all that out. Everything else seems to be related to our map, which is perfect. I want to save this file, and then I'm going to go to File, New File, and then I'm going to paste all that code in. So once I paste all this battle sequence code in a new file, I'm going to hit Command S to save it, and then I want to save that within our root directory, and I'm going to call this battle scene.js. So I save that, and now we have battle scene.js within our project, but we do need to import this within index.html. So where do we want to import this relative to our other files? Well, a battle sequence might use stuff that is available within classes in index.js, so I think it makes sense to import this as the very last thing within our current script tags. So I'm going to go ahead and grab this last script, duplicate it, and say for our very last script, we're going to reference battle scene.js. So I save this and refresh, and everything still looks and functions the exact same. But our files are definitely a little cleaner because now we know all of our code related to our battle is going to be within battle scene and then maybe within some of our classes or data files. Now getting back to this, whenever we go ahead and click this dialog box, whenever it shows a new dialog, we're going to want to activate our enemy's attack, and then we're going to want to update this text with the enemy's attack. I'm going to show you how to do this in the most scalable way possible that I'm aware of at least. So the first thing we want to do is add an event listener to our dialog box so that when we click on it, we can react to it in some way. So to add that, we're going to make sure we're within battlescene.js, and here we want to select with document.query selector. We want to select the element with an ID of dialog box. That's going to grab our dialog box over within index.html, and that is right here. Perfect. So go back to battlescene.js, and now that we have this, we can add an event listener on top of this. What event do we want to add? Well, we want to listen for a click event, and then we want to call the following code within an arrow function that says clicked dialog. So we're just doing this to make sure that it works. We save, we refresh, right click to inspect, and then open up our console right here. Now when we click Fireball, we shoot that attack, we have our dialog box, and if we click the dialog box, you're going to see it says clicked dialog. Now it's not completely apparent that when you hover over this dialog box that it's clickable because we never changed our cursor to the pointer. We can do this really quickly. Within index.html, our dialog box right here has a style. We're going to add onto this style cursor pointer. And now when we save and refresh that, hit Fireball, you'll see now when we hover over our dialog box, the user knows that this is something that can be clicked on to go to the next sequence within our scene. So when we click on it, all we're doing right now is logging out clicked dialog. What do we actually want to do? Well, we can start off within battlescene.js by hiding the dialog box. So let's start off with that. To hide the dialog box, well, we know we're already clicking on it with document query selector dialog box. So what we can do is when we go ahead and call this arrow function in response, we can get the event object inside of it, which is represented with E. And then on top of that event object, I can call current target, and that is going to get the HTML element we are currently clicking on. It's going to be dialog box. So once we get this element, then we can call the style object on top of it and say we want to reference our display property and set that equal to what? Well, none. We're going to send it back to its original state. So now if I save, refresh, hit Fireball, and then click on this, you're going to see it disappears, and then we can go on to the next sequence. At least we can. We never actually told Draggle that they can attack, though. It's not really fair if the enemy can't attack. So what we're going to do here is create what's known as a queue. This is a data type that's used in software engineering quite a lot. If you've taken interviews, you might have heard of this, but essentially a queue is just an array. And inside of this array, we're going to have different data types or different functions. In our case, we're going to have different functions, and these functions are going to be which attack should Draggle be using, which attack should our enemy be using. So our attack options are either going to be Fireball or Tackle. So a queue is essentially going to function as a line. The functions in the front of this array are going to be called first, and then once they're called, they're going to be shifted out of the array, and then we're going to call the next item in line. So to give you an example, let's say that Draggle's sequence is going to contain a Tackle, and then it's also going to contain a Fireball attack. So we push these into the array, and then what we're going to do is we're going to call Tackle, and then after we call Tackle, we're going to shift it out of the array. That means it's no longer available to us. So Draggle just attacked Emby, we just used Tackle. Now within our queue, the only thing left is Fireball. So Draggle is then going to use Fireball, attack Emby, all the way over there, and then there's nothing left within our queue because we shifted out Fireball. So our queue is empty. Now that our queue is empty, what can we call? Well, no other than e.currentTarget style display none. Basically, when our queue is empty, we're going to hide this dialog box, which means it is our player's turn to actually initiate an attack, and then the sequence is going to continue. But that queue is great for giving Draggle options in which he can go ahead and use when it's his turn on his side of the field. So to create this queue, right above document.querySelector, I'm going to create a const called queue and set that equal to an array. This is going to be empty by default. Now, whenever we go ahead and select an attack on our end within this event listener right here, we're going to tell Emby to attack, but at the same time, we're going to push into our queue array. So we can do that with queue.push. Now, what do we want to push in here? Well, we want to push in actions that Draggle is going to take. So those actions can be called with arrow functions. We're going to push in an arrow function, and then we want to call Draggle.attack. So I'm going to copy this code right here where we're telling Emby to attack and then push it within this new arrow function. But I know this queue represents when Draggle is attacking, so instead of calling Emby.attack, I'm going to call Draggle.attack instead. We know the recipient for this should be Emby, And Draggle's attack should not be the attack we personally selected, it's going to be something else. So we need to make sure that we're grabbing either Tackle, Fireball, we'll randomize it later, but to get the data object for the attack we want to use for Draggle, what we can do is select our attacks data object. And if you need a quick refresher, attacks is defined within attacks.js. What attack do we want to grab? Well, for Draggle, I think it makes sense to just give him Tackle. So back within battlescene.js, I can reference our attacks object. I know I want to tackle, so I reference that with a dot, capital T-A-C-K-L-E. And now that is going to be Draggle's attack within the queue. So if I were to save and refresh this, nothing would actually happen because even though we populated our queue with what attack is supposed to happen next, well, we never actually called the function within the queue. So we want to call that function when we click on our dialog box. It's going to be right in here. What we can do is we can say if our queue.length is greater than 0, meaning we have items within our queue to be called. Then what do we want to do? Well, we want to go ahead and select our queue, get the very first item within it, and then we're just going to call the function that we passed through. So basically when we call this right here, we're calling this right here, which causes Draggle to attack. Now after this queue function has been called, how does a queue work? Well, you shift off the first item within the queue. So what we can do is select the queue and then call shift, and that's going to delete that item out of the queue, meaning that our queue would soon be empty in this case. So this all looks great, but now we know we don't want to set our eCurrentTargetDisplay equal to none unless this is equal to false. So we can go ahead and just write an else statement right here and pop that right after it. Now that's only going to be called if our queue is empty, meaning it is our turn to attack. Let's get rid of this console log as well, we no longer need that. But now if we save, refresh, use Fireball, that looks great, but now if we click on this, we should see Draggle attack with Tackle. So if I click, we see that Tackle event. Now our queue is going to be empty, because remember, we called queue.shift, that got rid of this function that we just called right here. So now that it's empty, we should hide our dialog box on click. So we click our dialog box, now it's gone. We can proceed with our battle sequence. I can go ahead and use Tackle, and then if I click this again, we have something in our queue. Then Draggle is going to use Tackle. So the really nice thing about using the queue data structure is we can push in multiple attacks for Draggle or multiple sequences in which we want Draggle to respond to. So for instance, if we want to go ahead and push in a new attack for Draggle, meaning that he should attack twice, we can simply copy this code right here, and then beneath it, we can go ahead and call it again, queue.push, but this time, let's say we want to reference attacks.fireball instead. So if we save this and then refresh, use something on our end, MB used Fireball, and click. First, Draggle is going to use Tackle. We go back to our code, we just used this attack right here. So what comes next? Well, it's going to be attacks.fireball, but only if we click. So let's go ahead and click. And now he just used Fireball, and that was subtracted from MB, but now we have nothing left within our queue. So what happens? Well, we're going to set the dialog box display equal to none, and now we continue with our game. So that is going to be a really awesome way to start queuing our dialogue. So now we're going to want to go ahead and populate attacks based on the chosen monster. So what do I even mean by this? Well, our chosen monster is just going to be MB right here. This is our monster, but each monster is going to have a certain amount of attacks associated with them. The thing is, Tackle and Fireball right here are statically placed within our HTML. We need to make sure that we populate these dynamically based on which attacks are associated with each monster. So to start, the first thing we're going to do is head on over to index.html. And we're going to find our attacks. They're going to be right here, Tackle and Fireball. We're going to want to delete these completely because we're going to populate them based off of our monster data. But we do want to add an ID to this div right here. I'm going to call this attacks box. And that attack is definitely plural with an S because it contains multiple attacks, most likely. So make sure you add an ID of attacks box. And now within battlescene.js, right before we call animate battle right here, we're also going to want to populate that div with the ID of attacks box that we just created. So to do that, we can select it with document.querySelector. We can grab our ID with a £, and get that with attacks box. And now we can call .append. If we go ahead and write some text in here, save and refresh, well, we just appended some text inside of that box, but we don't want to append just text. We want to append an actual button element. So to create a button element, right above this, we can create a const called button. This is going to be equal to document.createElement. And then what kind of element do we want to create? Well, no other than a button element. So now that we have a button element created and stored within our const of button, we can select our button and say that the inner HTML of this button is going to be equal to what? Well, let's just say Fireball to start. So we set the inner HTML. Now we want to append this button into our attacks box. So I'll go ahead and do that by referencing our button const, save, go back to our game, refresh, and now we have a button of Fireball in place and it still works as it did before. But we want to populate this dynamically, so we are going to use this code right here, but this is going to be based off of what data we actually have in relation to each monster within our game. So if we're ever using large amounts of data, it's pretty safe to create some sort of data file similar to what we did for attacks. That way we separate our data from our game logic. So we have attacks.js, which references our attacks. Let's go ahead and create a new file, save it, and then call this monsters.js. So this file is going to contain all the data related to our monsters, whether they be MB or Draggle. It's going to contain all that information. So let's start creating this with a const of monsters. This is going to be equal to an object, and we know we are using MB, so as our first property, we're going to declare MB with a capital E, and then what kind of data does MB possess? Well, we know if we look within our battle scene, and we scroll on up, MB's data is everything right here within new sprite. So what we can do is we can grab this object right here we're using within our constructor, cut it out, and then go back to monsters.js and assign it to our MB object. So it's going to look something like this. So this is all of our data related to MB, but you'll see right here for image, we're using a const called MB image. So within battlescene.js, we need to make sure we grab that as well. It's going to be these 2 lines of code. Let's cut them out, save, go back to monsters.js, and then at the very top of our file, we can go ahead and paste those 2 lines in. So this is looking great for our data object, but we do need to make sure, since we created this new JavaScript file, that we actually pull it in via our index.html. So where do we want to place this in relation to everything? Well, I think it makes sense to place it right after attacks because we are going to want to make use of our attacks objects. So right after attacks, I'm going to create a new script and reference monsters.js as well. Now if I go back to battlescene.js, all I need to do here is make sure that when I create a new sprite that I reference the MB property right here within our monsters object to get the exact same result as we had before. So when I create a new sprite, I'll go ahead and reference monsters and then select MB with a capital E. If I save, go back to our game and refresh, well, everything is still going to function the same, which is great. I know it doesn't look like much, but for code organization, this is going to be perfect for what we want to do. So we just cleaned up our code quite a bit within our actual implementation in battlescene.js. Now we can do the exact same thing for Draggle. So I want to go ahead and challenge you to pause the video and create a new Draggle monster type within monsters.js and see if you can get the game working like it was prior. So let's go ahead and do it together. Right here, when we're creating a new sprite, we know that this object right here represents Draggle. I'm going to go ahead and cut this out, head on over to monsters.js, and then I'm going to create a new property inside of here called Draggle with a capital D, and then I can paste in that object I just cut out. Now I know Draggle image right here needs some sort of image associated with it, so I know that was created within battlescene.js. It's going to be these 2 lines right here. Simply cut those out, save this file, go back to monsters.js, and then at the very top, I can paste in Draggle image. So everything looks great within this file. Let's go back to battlescene.js. Everything's looking pretty good here, but when we create a new sprite for Draggle, well, we want to reference our monsters object, and then reference the Draggle property on top of that we just created. So with just this, save and refresh, everything's still working. These are still rendered out on the screen, but our code is much cleaner. This whole battle scene file is only 68 lines of code, which is pretty awesome for how much we've actually done. So one of the big reasons I created this data type for monsters.js was so I could add in an additional property. And that additional property is going to be called attacks. And this is just going to be equal to an empty array to start. I want to make sure that I place this on both MB and Draggle. And all this does is represent what attacks should these characters have. So if we want to go ahead and reference certain attacks, well, we know our attacks are all defined within attacks.js. So what we can do is, within our attacks array for MB, we can grab our attacks const, which is given to us through attacks.js. And then what attack do we want MB to have? Well, we have 2 options right now, tackle and fireball. So we're going to say within this array, we want MB to have an attack of tackle, and that should actually be a capital T. Make sure you get that right. And then MB should also have an attack of what? Well, also fireball with a capital F. And then we'll do the same thing for Draggle down here, and we'll just give him an attack of tackle to start. So now we're populating this attacks array with attack objects, which is great, and we can see that being passed through into our new sprite class right here. The thing is, if we go ahead and check out the sprite class at the very top, we don't actually have any constructor property related to attacks. Now this sprite class is being extended so much to the point where it probably makes sense to extend this class and create a completely new one based off of it. Our default sprites shouldn't do things such as attack. They're not going to have an attacks property in the first place. So it doesn't really make sense to add that onto our default generic sprite class. So let's go ahead and extend this into a monster class. right beneath this class of sprite, I'm going to go all the way down, and right above our class of boundary, I'm going to create a new class called monster with a capital M, and say that this extends our sprite class up above. So by default, when we extend a parent class like sprite, it's going to give us all the methods available within that class. So things such as draw, attack, those are all going to be available within our class of monster. But we did say to ourselves, a generic sprite should not have any method of attacking. So I'm going to go ahead and grab this attack method, scroll all the way down to where that ends. Should be right about here, I believe. And if you just missed a bracket like I did, you can delete that last bracket. But we do want to paste that within our new monster class. I'm going to paste that in, and since I missed a bracket, I need to make sure I add that last bracket in. So this is all great. Now we have an attack method within our monster class, and our sprite class up here is definitely more generic. But we still want to continue refactoring our sprite class to make sure it's as generic as possible. It's only there to animate sprites, not have sprites attack each other. So if I look at our properties right here, what is associated with attacking and what is just going to be generic? Well, I know this name property that we just added in is only for monsters, so I'm going to want to take that out of our class of sprite. And I know when we use isEnemy, well, that's pretty much only for our battle sequence as well. It doesn't make sense to keep that within our generic sprite class. So what I'm going to do is I'm going to copy those two lines right there. I'm actually going to cut them out, isEnemy and name. And then I'm going to go down to our monster and then say I want to add in a new constructor. And that's going to take an object, and then I'm going to paste those two in. And then we need to make sure that this is a function for our constructor just to start, but I want to keep analyzing the code up above for refactoring purposes. So those two properties, isEnemy and name, are also assigned down here. We want to take those two out, but you'll also see we have health assigned to 100. Well, health is only available for our monsters, so I want to take that out as well and make sure that I put that within our monster class. So I'm actually going to grab these three properties right here related to monsters, not generic sprites, cut those out, and then paste them within our constructor function right here. Now, one of the tricky things is with extended classes, we need to make sure that we put all the properties that we want from our initial constructor inside of our child constructor. So we're also going to want to grab all the other argument properties right here, and then paste that within our new constructor. And that looks great. And then finally, if we want to go ahead and say that these should be assigned, just like they're assigned up above with these lines of code right here within our generic sprite, what we can do is within our monster constructor is we can call a super function. And then within here, we can say what properties should be assigned based on the parent. Well, we can declare those with an object, because we're using object syntax within our constructors, and then we know we want everything from rotation up to position dependent on our parent. The only thing that's really different for our monster is going to be isEnemy and name, so we don't need to do anything there, but we do want to grab these arguments right here, place them within super. But when we place these within super, they can't be assigned to anything. Those are going to be assigned based off the parent. So any assignments, we need to get rid of those. And now all these properties right here, all of their assignments are going to be dependent on this code right here within their parent class. So that should be pretty good in regards to creating our new monster class. Let's go ahead and make sure that all this works correctly. So now that we have this class in place, we want to make sure that we save the file with Command S. We'll go back to battlescene.js, and now we're no longer creating a new sprite for our Draggle. We're creating a new monster. And same thing for MB. We're going to create a new monster for him as well. So if we save and refresh, looks like everything went according to plan because our sprites are still rendered out on the screen. Now let's go ahead and test our attack. If I use Fireball, that still seems to work. And the tackle attack for Draggle still seems to work as well. So great, we just refactored that successfully. So now that that's refactored within classes.js, we can begin adding more properties onto our monster class. So another property I want to add onto this, only for monsters though, not our generic sprite, is going to be attacks. So when we pass through an argument of attacks, we're also going to say that this instance should have an attacks property assigned to it based on the actual attacks we pass through right here within our constructor. So to recap, if we go back to Battle Scene, you'll see we are passing through a big object that represents all the data related to Draggle and MB. We go back to monsters, and something we added inside of here was going to be attacks, which is set equal to an array that contains our tackle and fireball attacks. So now that we refactored everything, these are going to be available to us within our class of monster, because we're saying that this.attacks should be equal to the attacks we're actually passing through. We can test that these are in place by console logging out either Draggle or MB. I'll console log out MB. Save and then refresh over here, right click, hit inspect, go to console, and you'll see now we're logging out a monster. If we open this up, it has attacks associated with it. This is data related to Fireball and also Tackle. Now we can go ahead and begin using these to populate this section right here, and later on it's also going to come in handy for randomizing Draggle's attacks on the other end. So now that these attacks are available to us, we know that our character is going to be MB. And the code that we're using to generate a button is right here. So what I can do is I can call MB, select MB's attacks, and then I can call for each on top of this. For each what? Well, for each attack within our attacks array, I want to call the following arrow function. Now, what do I want to do? All I want to do is call these 3 lines of code right here. I'm going to paste them in within that for each. And then I know, well, our button.innerHTML shouldn't always be equal to fireball, but rather the attack name that we're looping over. So if I save that, go back here, now you'll see this is generated dynamically. We have tackle and fireball. And if I were to go ahead and edit one of these attacks over here within attacks.js, whether it be the fireball name, let's just go ahead and type in some gibberish, save and refresh. Now that's populated automatically, and it's really nice because we only have to edit this in one spot that's related to only our attacks data. We don't have to go ahead and search through all of our other code like we would have to otherwise. But in summary, if you want to go ahead and add new attacks for your player or for Draggle over here, here's what you're going to want to do. You're going to want to go ahead and create a new object within your attacks. So if I were to create one, I simply duplicate this, paste it in, and call it something else, determine its damage and its type. Once I have that new attack created, I would go on over to monsters.js, and then whatever character I want to have that new attack, I would add it in as a new item within our attacks array right here. So something like attacks.watershot or something like that. So that right there would go ahead and populate a new button within our button tabs right here. And then finally, what I want to do is go to classes.js, and within our monster class, I would want to go ahead into our attack function and determine how an attack with a name of Watershot should be animated. So I'd add a case of Watershot, and then I would go ahead and create all the code I need with GSAP to create the correct animation of that Watershot. So you want to go into attacks, monsters, classes.js, and then edit your monster class to add any new attacks to your game. But with that, we can go ahead and check off populating attacks based on the chosen monster. Next up, we're going to randomize attacks, specifically for our enemy. So right now, if I were to refresh this, we have tackle and fireball for ourselves, which is great. We use fireball, but right now, Draggle only has one attack, and that is tackle. Maybe we want him to randomly choose fireball with a 25 or 50% chance. How do we actually do that? Well, we're going to want to head on over to battlescene.js, and we're going to want to scroll down to where we're actually pushing into our queue for Draggle. So it's going to be right here within our event listener whenever we click on one of our buttons. So right now we're saying that our first attack should always be tackle, and our second attack should always be fireball. So this is actually pretty easy to do now that we added that attacks property onto our monster's object. What we can do now is we can select our monster, so Draggle, and then get attacks, the attacks array. And within this, we can randomly select whatever attacks are within this array. So to randomly select something, we're going to use math.random, which always selects any random value 0 to 1. And then we're going to multiply this by Draggle.attacks.length. So the length of Draggle's attacks array, which is going to be 2 because we have tackle and we have fireball. So when we call math.random times our attacks length, we're essentially getting any value 0 to 2. But that also includes decimal numbers, and you can't select something from an array using a decimal. So what we want to do is we want to wrap all of this code in a math.floor statement. And that's going to round us down to the nearest whole integer. So now with this code, we can only get either 0 or 1, and it's going to be completely random based on the length of attacks that Draggle actually has within his attacks array. So all this code right here can be kind of hard to comprehend on first glance. So that's a good case in which we want to create a const. And this is going to be called random attack. So I'm going to assign all that code to random attack, and now we can go ahead and push into our queue the random attack that was just selected. So we don't actually need Draggle to attack twice, so the second queue.push, I'm going to get rid of that. But now every time Draggle attacks, it's going to be completely random based off the attacks within his attack array. So we want to make sure that the attacks are available within his array in the first place. So we go over to monsters.js, and we look within Draggle's attacks. Well, he only has attacks.tackle. Let's go ahead and add attacks.fireball in here as well. And now this should be selected on random. So if we save this, make sure battlescene.js is saved as well. Go back to our game, use fireball. When we click, Draggle should use either fireball or tackle. And we want to go ahead and do this a few times to make sure that it's actually randomized, going back and forth between the two. So if I click, that time we got fireball. Great, that worked perfectly. So we go back, we choose, we use tackle. What does Draggle use next? Draggle use tackle. So perfect, we saw both options right there be used. And let's go ahead and make sure that it works one more time. If I use fireball, Draggle use tackle in that instance. So it's completely random. We went from fireball to tackle, and that really creates a lot more dynamic movement within our game to make it more interesting, make it something that people would actually want to play for longer. So thankfully for us, that was really quick. Let's go ahead and check off randomizing attacks. Alright, so now we can go ahead and display our attack type. So when we're over in our game, when we hover over one of our attacks, we want to make sure that we display what kind of attack that is, whether it be a fire attack, a normal attack, water attack, and so forth. We want to display that over here, just so the user knows what we're about to use. So in order to do this, we're going to want to go inside of battlescene.js. So if we go ahead and find our event listeners for our button, they're going to be right about here. So we're going to go ahead and loop through each button that is currently within our button's container right here, and that is perfect for adding more event listeners onto those buttons. You'll see we're adding one right here for click. And we want to go ahead and right after that add event listener for click, add a new one specifically for our buttons. So we're going to go ahead and call the button we're currently looping over, and then we're going to add an event listener. This is going to listen for mouse enters. So when the mouse enters our button, what do we want to do? Well, we want to respond with the following code. So if we go ahead and console log this out and just say go when we enter one of our buttons, save that. Open up our console and then refresh. Now if I go ahead and enter one of our buttons, you're going to see that we log out the text go. And that only logs on each time I enter one of the buttons, which is perfect for what we need to do. So whenever we enter one of our buttons, well, we want to get the attack that we currently hovered over, whether it be tackle or fireball. So if we look within our click event listener up above, we're currently selecting our attack with the following code. So what we can do is we can grab this line and put it inside of our mouse enter event listener. Now if we want to go ahead and use this code, well, this makes use of our event object, so we can go ahead and pass that through right here. So now that we have our event object, we're getting the current target, which is our button, and then we're getting our inner HTML, which is going to be the name that's actually placed inside of the button. And then we go ahead into our attacks object, and from this, we're able to get the selected attack. So now that we have the selected attack, what do we want to do? Well, we want to change the inner HTML of this right here. So let's go on over to index.html and find where it says attack type. I'm going to keep on scrolling down, and it looks like it's going to be here on 152 for me with an H1 that has attack type inside of it. So now that I have this H1 found, I can go ahead and add an ID to it and call this attack type. Makes sense. So once I add this ID to this H1 here, I can go back to Battlescene.js, and now I can go ahead and select that ID. How do I select that ID? Well, I want to reference our document object and then call query selector. And then once I have query selector in place, I need to reference an ID, which is indicated with the pound sign, of attack type. So now I have that H1. Now I can change the inner HTML of that H1 to what? Well, I want to go ahead and change it to our selected attack, which is going to be an object. But what is inside of our attack data objects? If I look within attacks.js, you'll see one of those is going to be type. Well, we can go ahead and grab this type property by going back to Battlescene.js, and then on top of our selected attack, we want to go ahead and call the type property on top of that. So really, that should be all we need to do to get this up and running. If I save that, go back and refresh. Now when I go ahead and hover over fireball, you're going to see the type is fire, and then if I hover over tackle, the type is going to be normal. Now what if we want to go ahead and change the color of this over here based on which type we're hovering over? Maybe a fire type has a color of red, a normal type has a color of black, and then a water type has a color of blue. How do we go ahead and change the color of this over here? Well, inside of our attacks data, we can go ahead and declare a color associated with each attack. So if I want to go ahead and say that our color for tackle should be black, I'll add in a color property and then set that equal to a string of black. Now I can do the same thing for a fireball. Just make sure that I add a comma here, and then paste in a new color property, and then say for our fireball attack, the color should be red. So now that I have a color associated with each attack, I can go back to Battlescene.js, and when we enter one of our buttons, we're not just going to change the inner HTML. I'm going to copy this line right here, paste it. We're also going to reference the attack type H1's style, and then on top of style, we're going to go ahead and reference the color property. So this is going to change the color of our text. So how do we grab the color that we want? Well, we have our selected attack, and we know this is either going to be tackle or fireball, which means we're going to have a color of black or red, and we can reference that color with .color. So now we're going to go ahead and set the style of color on top of our H1 of attack type to either red or black. So I save that, go back, and now when I enter one of these right here, you're going to see fireball is displayed as red, and then tackle is displayed as normal. So just a little enhancement to make sure that a user knows what type you're about to use on the enemy. And that's pretty much all we have to do within our to-dos to display our attack type. Now finally, we need to declare when this battle ends. So eventually, when we go ahead and hit Draggle enough, or when Draggle hits us enough with the correct ability, well, he's going to lose all of his health, and then he shouldn't be able to respond after he loses all of his health. We pretty much just want to say that either Draggle or MB fainted, and then we want to go back to our map. So we want to focus in on where we are queuing attacks for Draggle, which is going to be right about here. We can go ahead and comment this out, say Draggle or enemy attacks right here. And now we only want Draggle to really attack if Draggle has health that is above 0. If Draggle's health is 0 or below, then we don't want to attack. We want to go ahead and push in an event that makes Draggle faint, and then we can go back to our map. So above this, I'm going to go ahead and write an if statement that says if Draggle's health is less than or equal to 0, then we want to go ahead and call the following code. So here we want to select our queue.push. I'm just going to go ahead and grab this from below and paste it into this if statement. And we know we don't want Draggle to attack, so we can go ahead and get rid of this. But instead, I think it would make more sense to call a method on top of Draggle called faint. So when we call faint, what do we want to do? Well, we want to go ahead and pop up our dialog box to say that Draggle fainted. We want to go ahead and animate Draggle downwards, fade him out. That's a pretty classic way to end things within the traditional Pokemon games. But I think that's all we need to get started. We might add some more in as we go. So let's go ahead and call Draggle.faint if Draggle's health is less than 0. And then, we don't want to call any of this code down below. We don't want to push in a Draggle attack. So if Draggle's health is below 0, we're just going to return, which means we don't call any of the following code. But we do need to add in this faint method. So we're going to go over to our classes, and this is going to be specifically on our monsters class. So if we want to add a new method, we just have to find a spot beneath our constructor and above one of our other methods or below one of our methods. Doesn't matter. But we're going to go ahead and add that method in by typing faint, parentheses, and then opening and closing curly bracket. So now if I go ahead and console log this out, such as faint, whenever Draggle's health falls below 0, we should see this text logged out. So now you'll see if I hit Draggle with Fireball, we hit Draggle, and if I click again, well, actually, nothing was logged out, even though we said within battlescene.js that if Draggle's health is below 0, we want Draggle to faint whenever we click our dialog box. So let's go ahead and click this again, and maybe we'll see that he fainted. I'll click it. And we don't get that text logged out that we put within classes.js. We should definitely be calling faint right here. So what is going on? Why are we not calling faint? Why is Draggle's health not below 0? Well, we need to inspect our attack class actually. So if we go ahead and look at properties related to health, they're going to be starting right about here. What we're saying is whenever we go ahead and launch an attack, well, we're actually damaging our own sprite launching the attack. So when I'm controlling MB, this .health is related to MB, not the recipient. But when we launch an attack, we don't want to subtract health from ourselves. We want to go ahead and subtract health from the recipient, the person receiving the attack, which is going to be Draggle. So right here, anywhere where we have this .health, we just want to make sure that we change that out for recipient.health instead. So just a small little bug on our end. It's totally normal to come across bugs as you develop something this big. So wherever it says this .health within our attack method, such as right here within gsap.2, we want to replace the this with recipient. So we'll keep on scrolling down. That's also going to be available within our tackle case. So instead of this .health, I want to reference recipient.health. And I think if I go ahead and search for this .health, well, those are going to be the only locations left within our actual attack method. That's the only location in which we need to change them. So just make sure that you change this .health to recipient.health to get to the correct effect. But let's go ahead and save this, refresh, and see if that fixes things. So I'm going to go ahead and bring Draggle back down to 0. And now on this final attack, we go ahead and hit him, and I click again. You're going to see we called that faint method. So perfect, it works now, simply because we had that small bug related to our sprite's health. So now that we're calling faint, what really needs to happen? Well, we know we need to change the text that's going to be placed inside of here. We want to go ahead and say Draggle or MB fainted. So how do we change the text that's inside of here? Well, we know we're changing that text right about here when we select our dialog box and set its inner HTML equal to the name of our current sprite and what attack they used. So we can go ahead and copy this line, delete our console log, and then paste that in. And now what do we want to set our inner HTML to? So how do we change this up? Well, we do want to reference the name of the monster that's currently fainting, and then all we need to do is change the end string right here to something like fainted, exclamation point. That way, this would say something like Draggle fainted or MB fainted. So that's going to go ahead and give us a start in regards to changing the text right here. But we also want to go ahead and animate Draggle or MB so that they translate downwards and fade out over time. So we can do this right here within faint. We're going to call gsap.to. What do we want to animate? Well, this dot position, the position of the monster we're currently selecting. And then we want to go ahead and animate the y-axis. So I'm going to go ahead and push the fainted monster down by about 10 pixels, maybe 20. So I can do that with this .position.y plus 20. So we're animating downwards from the current y position. And then we want to go ahead and edit the opacity of this monster as well. So I'll call gsap.to again, and then say, for this, I want to go ahead and animate the opacity of this one monster down to 0. So now, if I save that, refresh, and bring Draggle back on down to 0, once I hit him again, it goes down to 0, and if I click, watch what happens to Draggle. You're going to see that he fades out. We display the text, Draggle fainted, and now when we click this, we can either go back to our map, or we can display one more option. I think we're going to go directly back to our map. I think that makes sense. But we do need to take care of the event in which MB faints and not Draggle. So if the enemy wins, we need to make sure that we call that same effect over on MB. So to test whether or not MB's health is less than 0, what we want to do is copy this if statement right here. And you might think that we want to paste this down below, but actually what we want to do is paste this after Draggle attacks, because we don't know whether or not MB's health is actually below 0 until Draggle actually attacks. Therefore, we have to paste this beneath where Draggle attacks. So if I go ahead and paste that in, we're going to attack with Draggle, and then after that attack, we want to monitor whether or not if MB's health is less than 0, and if so, we're going to take our Q, and then call MB faint after that attack occurs. So if I save that, and then use tackle, and he uses fireball on us, you'll see we go down to 0, and if I click, we're going to see MB fainted, we fade out to 0, and now we can proceed on to transitioning back to our map. So that's going to allow us to check off functionality in regards to when our battle ends. So now we're going to want to go ahead and transition back to our map when either Draggle or MB faints. So to do this, we're going to go back to battle.js, and whenever Draggle faints, we also want to go ahead and push something new into our queue. So Draggle's going to faint, and then we're going to push in a new action item. So what needs to happen here? Well, we need to fade back to black. So we know we want to animate that overlapping div, and we can go ahead and do that with gsap.to, and select that overlapping div with # overlapping div. That was the ID we gave earlier on within index.html. Now we can go ahead and say we want the opacity of this overlapping div to go back to 1. So to test that this is working, we'll go ahead and refresh over here, hit Draggle with fireball. That's set to 100, so he goes ahead, has his health bar shrunk to 0. We click, Draggle fainted, and now when we click again, you'll see that now that fades into black. Now one issue is that overlapping div is not overlaid on top of our user interface right here. So to fix this, we want to go over to index.html and find that overlapping div. It's going to be at the very top of our file, or at least near the top. Here it is. It's going to be the first item within our main div. And here we want to go ahead and select the overlapping div styles and set a new style of z-index equal to 10. So we want to make sure that this is drawn closer to us on the screen on the z-axis, and to do that we want to increase the value of z-index. So if we give this something like 10, all the other divs are going to be equal to 1 by default. I believe it's 1, might be 0, it doesn't really matter. As long as it's greater than either 0 or 1, we're going to go ahead and pull that div forward. So our overlapping div should now be overlaid on top of these. Let's go ahead and test that. We go ahead and hit Draggle with fireball, and we go through the process, click again. Now that's overlaid on top of everything. So once this animation completes, we want to go ahead and cancel our battle animation loop. And then once we cancel that, we're going to go ahead and reactivate our map animation loop. So let's go ahead and start by canceling our battle animation loop. That's going to occur within battlescene.js. And we know that we can call on top of our overlapping div animation a property of onComplete, set that equal to an arrow function. And now whenever this animation completes, we can call some additional code. So the code we want to call is going to be cancel animation frame, and this comes from the window object. And since it comes from the window object, we don't actually need to preface this with window. But what animation frame do we want to cancel? Well, we're going to cancel an animation frame with the name of battle animation ID. So we need to go ahead and create this and then populate it with the current frame we're looping over within our loop. So we can go up to our animation loop, and that is going to be right here on line 22 for me, animate battle. And right above this, I'm going to create a new let called battle animation ID. And now within animate battle, I can go ahead and assign battle animation ID equal to the result of this. So this is what's going to go ahead and activate our main animation loop. But when we go ahead and assign it something, it's going to give us the frame we're currently on. So we can go ahead and grab that ID, use it within cancel animation frame right here, and it should stop our animation from running once we fade to black. So we can always test this by console logging out our battle animation ID directly within animate battle. We save that, refresh over here, open up our console. You're going to see we're looping through each frame of our animation, and then once we go ahead, eliminate Draggle, and then fade to black, Eventually that's going to stop because we called, down below, cancel animation frame. So perfect, we canceled our battle scene animation for performance purposes. But now we want to reactivate our map, so we're going to go ahead and do that by calling animate, because that is the function we're using within index.js to actually make sure that our character can move around on the map. So this is the function, we're simply using it within battlescene.js as soon as we cancel our animation frame. So let's go ahead and test this. Save and refresh, hit draggle with the fireball, click a few times, fade to black, and now it looks like we're logging out the animation ID within our animate function on the other side, but we can't see it simply because we still have that overlapping div. If I were to go ahead and hide that overlapping div by selecting it right up above, right here, giving it a display of none, you'll see that now this is running again. I can actually move our player around, which is great. So we just want to make sure that we fade our overlapping div out as soon as we cancel our animation frame and animate our game once more. So on complete, after these two lines are called, we're going to call gsap.to, also on our overlapping div. So I'll go ahead and call that. And then I know I want the opacity of this overlapping div set back to 0. So save that, refresh, let's eliminate draggle, go through the process. And now we go ahead back to our map and we can move around because we're running our animation loop and all the code within index.js. So obviously we want to go ahead and hide our interface as well. This should not display back on the map, so that's another thing we're going to need to do when we go ahead and complete this overlapping div animation. So if we want to go ahead and hide our whole user interface, it kind of makes sense to go to index.html, and anything where we have something related to our user interface, we want to go ahead and wrap that within one main div. So let's go ahead and analyze this. Well, it looks like everything from right here on line 48 for me, the health bar of draggle, the health bar of MB, down to about canvas right here. I want to go ahead and cut that out because I want canvas to be above it. Our canvas should not be within this main div we're about to create. So I'm going to cut those lines out and paste them beneath our canvas. And now everything that I just pasted in and everything below is going to be related to our user interface. So what we can do is we can wrap all of our user interface in a div. So I'll create an opening div, and then I want to keep on going down until I find the very end of our user interface. It's going to be right about here for our last div. I want to end in a closing tag for that div, and then I'm going to format everything. So everything is within that one div, and then I want to add an ID onto this newly created div called user interface. So perfect. Now that I have this ID in place and everything is wrapped within this one parent div, over here, what I can do is I can select that div with document.querySelector, get it by its ID, which is going to be user interface, and then I can select the style on top of that, specifically the display style, and set it equal to none. That's going to make sure that everything is completely hidden from our game and that it is not clickable. So if I save that, refresh, hit draggle with the fireball and go through the process again, we're going to see now the interface is hidden. I can click around, nothing is activated, and we can move about our game as normal. Now something we definitely want to do is make sure that our transition back into a new battle is pretty much foolproof. So if we're going to activate a new battle, well, you'll see there's definitely an issue here. And this is simply because we need to reinitialize draggle, we need to reinitialize our health bars, set them back to 100%, make sure that their display is set to block so they actually show. A few more things we need to do to make sure that we can transition back into these battle scenes. So if we want to reinitialize everything within our battle scene, we need to focus in on battlescene.js, specifically on the parts where we're initializing our variables. So things such as creating draggle, MB, rendered sprites, all that's going to need to be called again, not just when this file loads. So to make sure that this code can be called multiple times, above animate battle, I'm going to create a new function called init battle. It stands for initialize battle. And now, every time I initialize a new constant, I actually want it done with an init battle instead. So let's go ahead and see what we're actually initializing. We're initializing this stuff up here, such as setting draggle equal to a new monster. Let's start by setting draggle equal to a new monster within init battle. If we're setting draggle equal to a new monster within a function, we need to make sure that this is a let up above, not a const. So we'll make sure to change all of our consts right here to let for draggle, MB, and our rendered sprites. And now I can go ahead and set MB equal to a new monster of MB within init battle, which means I can get rid of this right here. And then I want to do the same thing for rendered sprites, make sure that this is being set within init battle. Make sure I get the original assignment deleted. Now each time we initialize a new battle, well, we might have different attacks associated with our character, so we want to make sure that we put this code inside of there as well. where we go ahead and populate our buttons with our character's current attacks. Our battle background is going to stay the same, so we can leave that as is up above. But what else might we want to put within init battle? Well, we might want to reset our queue so nothing is inside of that. So I'll go ahead and move queue up here. Make sure that's a let. Delete its original assignment, and then whenever we init a battle, I'm going to call queue and set it equal to an empty array. What else can we grab? Well, the code that adds our event listeners for each button, we're going to want to grab that as well whenever we init a new battle. So I'm going to grab everything from line 100 up until 46, where we call it document.querySelectorAll for our button. I want to go ahead and grab all that code, paste it within init battle. And then if I scroll on down, we can go ahead and keep this code as is because we only want to add an event listener for our dialog box once. If we were to add this multiple times, we'll essentially be activating more than one click on the dialog box. It's going to activate double clicks. We don't want that. So let's just go ahead and keep this as is and see how things work with this. So now that everything is wrapped within init battle, whenever we go ahead and call animate battle, we need to make sure that we call this before we actually call animate battle. So where are we currently calling animate battle? I'm going to do a command F for animate battle, and it looks like we're only calling it right here when we actually begin our game. So let's go ahead and paste in init battle as well. If I save that and then refresh, it looks like our game still works. So this is off to a really good start. So let's go through the process, get ourselves back to our map. Everything is still working as expected, and then we want to go ahead and activate a new battle to test this new init battle functionality. So if I go ahead and do that, well, still getting the same issue. So although we created an init battle, and when we start our game, we're calling init battle and animate battle, when we reactivate the battle scene, we need to make sure we call init battle as well. So where are we actually reactivating the battle scene? It's going to be within index.js. Let's go ahead and do a command F for animate battle. So whenever we go ahead and activate a new battle, we're calling this code right here. But before we call this code, we always need to make sure that we call init battle at least once. So now if we save and refresh, and go through the process, we activate a new battle, and now it looks like we're even a little worse off than we were before, but I promise you we're on the right path here. Let's go ahead and inspect this to see what's going on. So if I go ahead and look around our canvas, specifically for this element of user interface, you're going to see that its display is equal to none, because when we ended our last battle, well, we set the display equal to none so it wouldn't show on top of our map. But if I get rid of display none, you'll see our user interface is back. That's a perfect start. So when we init a battle, we need to make sure that user interface is going to be showing, and we can do so by setting its display equal to block. What else needs to happen here? Well, we need to make sure that we hide our dialog box, so just our attacks show. We need to make sure that we set our health bars back to 100%. So a few things we need to do here whenever we re-init a battle. So let's start by showing our user interface. We're going to go back to battlescene.js, specifically within init battle. So whenever we init a battle, we want to show our user interface, which we can do with document.querySelector. What do we want to select? Well, # user interface, and then we want to go ahead and select the style, specifically its display, and set that equal to block. So that should take care of that. Let's go ahead and hide our dialog box by default. I can go ahead and hide this by copying this line of code that we just created, pasting it on in, and then instead of selecting user interface, I can go ahead and select our dialog box instead. But I don't want to set this equal to block. I want to set this equal to none. And that's going to make sure that's hidden by default. I also want to make sure that our health bars are completely back to 100%. So to grab our health bars, I'll copy this line right here. And instead of selecting our dialog box, I'm going to select our enemy health bar ID, and then I want to go ahead and select the style.width and set this equal to 100%. It's going to make sure that the green bar fills up the full width of its container, and then I want to do the same thing for our player health bar, so I can simply copy this line, paste it in, and then reference player health bar like so, and set its width equal to 100%. So let's go ahead and test all of this out. Now all of this stuff should show by default, and the health bar should be repopulated. So I refresh, go through the process, we go back to our map, and I start a new battle. We're going to see now all of that is showing. It's not perfect though, because 1, our sprites are missing, and 2, we have duplicate attacks right here within our attack bar interface. So if we want to make sure that there are no duplicates right here, we want to go ahead and select our attacks box. This is another ID we created within our HTML. And then we don't want to call anything regarding its style. We actually want to call a method called replace children. Make sure you call this as a function. So when you call replace children, by default, it's going to remove everything within our attacks box. The only thing within attacks box, if I do a command F within index.html, are going to be buttons right in here. So if we go ahead and remove those each time we init a battle, When we run through our character's attacks, then we can repopulate them with those new attacks. So we're just making sure that we give ourselves a clean slate whenever we call replace children. So now let's go ahead and test this. Save and refresh, fireball, and then reinitialize our battle. You're going to see that fixes that issue. So the very last thing we need to fix is getting our sprites showing again on the screen. Why are they not showing currently? Well, even though we're creating our monster sprites and we're rendering them out with our render sprites array, well, we have a bug within classes.js, specifically within our main sprite class. So sometimes your images won't actually load if image.onLoad is called after you actually set your image's source property. I didn't learn that till just now, so unfortunately this is going to be something we have to refactor. My sincere apologies on that, but it's nothing that we can't handle, and in the end, it actually is going to make our code a little cleaner. So basically, we need to go ahead and move this .image on load before we go ahead and set our image's source. So that means we need to set this .image.source equal to this .image.source. We need to go ahead and pass this through as an argument within our constructor. So instead of setting this .image to the image we're passing through as an HTML element, I'm actually going to set this .image to a new HTML image directly within our sprite class. So here I'll say this is going to be equal to a new image. Then we can go ahead and set the onLoad function, and then after that we're going to set its source, which is going to fix the bug of them not rendering correctly in time. But we do need to set this source attribute, so save this file, and then where are we creating our monsters? That's going to be within battlescene.js, right here. So we know we're passing through monsters.draggle and monsters.mb. These are going to be objects, which means we need to go over to our monsters file, and then instead of setting image equal to the actual HTML image, we're going to go ahead and set this equal to an object that has a property of source inside of it. This is going to be equal to a string, and then what string do we want to use? Well, what is the string of our MB sprite? It's going to be this right here. Let's go ahead and grab that and set our image source equal to MB sprite. And then down here, where we're setting Draggle image, we want to do the same thing. We're going to add in an object with a property of src for source. And then right here, that's going to be equal to our Draggle sprite.png. That means we can get rid of these lines of code up above, and we're just going to be passing through a string instead. And then what we want to do is set this .image.src equal to the image we're actually passing through our constructor. So we'll reference that without the this, and say image.src is going to be equal to our image's source. So we save that and refresh. Now all of our sprites are showing, including our background sprite, because the way we refactored our code is going to make sure that our current way of inserting images is still going to work if we need it done that way. So that's going to be how we reinsert our sprites, by refactoring our code a little bit. So now if I go ahead and use one of our attacks, you'll see that Draggle faints. And let's go ahead and test this out one more time. We restart our battle, and everything looks pretty darn good. Let's go ahead and use a tackle. You'll see that it subtracts 10 health from Draggle. Then Draggle can use tackle, and we can proceed with our queue because we just refactored our code using that init battle function. So now, since Draggle used fireball on me, MB faints. But we do not go back to our map, unfortunately. Right now we're only going back when we go ahead and eliminate Draggle. So we just need to make sure within battlescene.js that we add the code that we use to go back to our scene for when we go ahead and eliminate MB as well. So that's going to be down here when we're calling MB.faint. We also need to make sure that we call this code right here, which activates our overlapping divs. We can either go ahead and create a new function if we want to be as dry as possible, but I don't in this case. I kind of just want to get through this tutorial, you know, not hold you too long since it's already been like 6-7 hours. So I'm going to go ahead and copy this QPush, and then when MB's health is less than 0, I want to also call QPush with our overlapping div that ends our battle, animates our map scene, and then sets our display none for our user interface, and then transitions us back. So save that. Refresh, and finally we should be good to go, even when Draggle goes ahead and eliminates us. So we'll start a new battle, and then I'm just going to keep using tackle until he uses fireball over there, and there we go. So now we should faint, and if I click again, we go back to our scene, and we can go ahead and continue with our game, or can we? So now that this restarted, you'll see if I use W, A, S, or D, we're not actually moving on our map. So one more thing we need to set within this ending code is we need to go ahead and grab our battle object that we declared within index.js and set its initiated property equal to false again. So the battle ended. We want to make sure this is set equal to false because this is what's going to control whether or not we can move within our map animation loop. So we need to make sure we do this right here. We also need to make sure we do it right here because our code is not dry at the moment. We could always combine this into a function if we wanted. But if I save that, go through the whole process, we restart a new battle, and then Draggle's going to eliminate us with a fireball. We faint, we go back to our map, and now I should be able to move. If I press W, I am indeed able to move once more. and I'm not going to initiate a new battle until I step into one of these new battle zones, and that random code activates. So let's make sure that activates one more time, and indeed it does. We can go through the battle process, which is completely reset, hit Fireball, Draggle fainted, and great, we can go back to our map. So with all that, we're going to be able to check off transition back to map. So finally, it is time to add in music and sound effects. So the way we're going to do this is by creating an audio.js file within our data folder. So let's go ahead and do that now. I'm going to select the file right here, and then hit Command N, and then hit Command S. So inside here, I'm going to be automatically put within my data folder, and now I can go ahead and create a file called audio.js. So now that I have audio.js right here, I want to create a const called audio and set this equal to an empty object to start. So once I have this in place, I want to make sure that I import it into our game. I'm going to do so by heading on over to index.html, and then with our script tags, I want to make sure that I import this audio, and I can do this before everything, doesn't really matter. I'm going to import this audio by creating a new line, and then saying that our source should be equal to data/audio.js. So that is perfect. Now within audio.js, I want to begin creating audio objects. But first we need audio to reference. So to get audio to reference, I went to itch.io and I found all the audio that I thought would fit our game the best, all from free audio asset packs. So these are going to be available directly within our Pokemon Assets audio folder, and you'll see these are all of them right here. So what I want to do is I want to go ahead and copy all these audio files. I'll select them all and then hit Command C, and then over in our project directory, now I want to create a new folder by right-clicking, hitting New Folder, calling this Audio, and I want to paste in all of those audio files. So now that those are available within our project, I can begin selecting them and creating actual HTML audio elements, which I can control using JavaScript. So this file right here, map, if I play this, this is going to be our map theme. I figured it would fit. Sounds good. So let's go ahead and get this integrated into our game. So within audio, what I want to do is create a new property within our object right here, and this is going to be called no other than map. And then I'm going to set this equal to have a source of what? Well, from the root of our project, I need to go into our audio folder right here. So I'll open that up. And then what do I want to select? Well, I want to select map.wave. Now, typically I would create an audio object directly here called new audio and then reference that source, but this is kind of cumbersome, and the default audio object that comes with JavaScript is not that great, honestly. So instead of using the default audio object, what I'm going to use is called howler.js. It's pretty much the go-to library for controlling audio within JavaScript. I would highly recommend it for any game you're about to create. So the best way to get howler.js is to go to Google and type in howler.js CDN. This will also be within the video description, but I do want to click on cdnjs.com. And in order for your game to work exactly as mine works, you want to make sure that you're selecting version 2.2.3, and you're just going to grab the minified result right here. You can grab that by copying the script tag. Then we can head back to index.html. And then as the very first thing, we can paste in that new script tag that references 2.2.3 howler.min.js. So one of the nice things about Howler is we don't need to set a source attribute or anything like that. We can just say that our map audio is going to be equal to a new howl. This should be available to us as soon as we save index.html with this new script tag, so make sure you do that. Now back within audio.js, we want to create a new howl, and inside of this new howl is where we're going to declare our source attribute. So what is the new source of this audio file? Well, it's going to be /audio/map.wav. Now before I'm able to use this, I want to add one more property in here, which is going to be HTML5, and I want to set this equal to true. And the reason we're doing this is because if we try playing this audio file right off the bat without the set, well, since we don't have a local web server running, well, our audio just isn't going to play. We're going to get a CORS issue. So if your game is not running on a local server like ours is not, we want to go ahead and make sure we set this equal to true, or else when we play this, it's just not going to work. Now, how do we actually get this playing on our game when we start? Well, let's head back to our game. Well, if we head back to our game, you're going to see we start off in the battle scene. This is not the music that should go with our battle scene, so we need to go to our initial state. We'll head on over to battle scene.js and find where we're calling init battle. It's going to be right here on line 125 for me. We want to comment out init battle and animate battle. And then we want to uncomment out 124 of animate to make sure we start out on our map. So save that. Now we're back on our map, but you'll see our interface is showing by default. We can fix this quite easily by going to index.html, finding our user interface ID, which I can search with for user interface. And I want to go ahead and add a style onto this that just makes sure that this display is equal to none by default. Just a quick fix for that. Now we are back to our original position. And now whenever we start this scene, we want to make sure that our audio is playing. So if we try calling this directly within index.js, such as audio.map audio.play. I save that and refresh. The audio isn't going to play by default. Let's go ahead and inspect within our console over here. I'm quickly going to remove any console logs from index.js. If I refresh over here, you're going to see we're getting an error that says the audio context was not allowed to start and must be resumed or created after a user gesture on the page. So by default, Chrome and other browsers have this thing that can be quite annoying if you're trying to make a game that does not allow you to play any music until someone either clicks or moves on your screen. So what we can do is we can add in an event listener that says whenever we click initially on our screen, that is when we're going to go ahead and start our game music. So let's go ahead and get rid of audio.map.play. And at the very bottom of our file right here, we're going to add in a new event listener that listens for click. So whenever we click on our window, anywhere on our window, we're going to call this new function. And then within this new function, we want to go ahead and call audio.map.play, but we only want to call this once. So what I'm going to do is create a let called clicked, set this equal to false to start. Then I only want to call this line right here if clicked has not been activated. So when we click, we're going to go ahead and play our map audio, but we're also going to set clicked equal to true, meaning we did indeed click. That means this is only going to fire once whenever we click on our page. So if I save that and refresh and then click, you're going to hear our music playing in the background. But if I keep clicking, we're not getting duplicates of that music playing. Without this little boolean right here, well, we just have multiple versions playing, and it would be really chaotic at once with all of them playing at the same time. So good thing we added in that boolean. So that's how we're going to start with our audio. Now, the next thing we want to do is make sure when we start a battle, one, we stop the audio currently playing in the background, and then we activate some battle audio code right here. So where do we actually activate that battle? It's going to be within index.js. We can do a command F for activate a battle. So if we scroll on down, we know when we set battle initiated equal to true, this is where we actually activate our battle. So right here, we can actually call audio.map, and then we want to go ahead and call stop on this, which means we're no longer going to play that music. But we do want to call audio.init battle.play. That's going to be the sound effect that occurs as soon as that battle initiates with the black screen flashing in and out. And now at the same time, I also want to call audio.battle.play. That is going to be our battle background music. So we're going to stop this, and then we're going to play our battle music as soon as we stop that. But we do need to create these properties first before we're able to play them. So I'm going to save this. And back within audio.js, I need to create init battle right here for my property, and this is going to be equal to a new howl. And what properties does new howl take? It's going to take a source. This is the location of the source file. For me, it's going to be audio/init battle.wav. And then I need to make sure I set HTML5 equal to true since I'm not using a server. And then I also need not init battle, but also battle. This is going to be equal to a new howl. And I can pretty much just copy the code up above to save us some time, paste it in. And this isn't going to reference init battle, but rather battle.mp3. And when you're referencing your file name, make sure you get the casing correct. You'll see right here I put an uppercase I for init battle. I actually want to reference a lowercase I instead. And for our properties, well, it kind of makes sense in this case to just make the first letter lowercase as well. So I'm going to go ahead and do that. For all these, I'm going to leave map the same since I already coded that within our actual implementation. But this is going to be a lot better for code maintenance because this property right here is equal to the actual name of the file. It's going to make this a lot easier for us to remember. So if I go ahead and save this, and I make sure within index.js that I'm referencing the correct properties right here, which indeed I am, let's go ahead and initialize a new battle. So when I click, we have our background music playing. And now, when I initialize a new battle, you're going to see now we have that new battle music in place and that new battle initialization audio that played. Now this is very loud, especially if I turn it up all the way. I don't know why the audio file is that loud in the first place, but if we want to go ahead and turn this down, we can do so within audio.js. Basically, we can add in an audio property called volume and set it equal to anything from 0 to 1. So I want to go ahead and set this equal to 0.1 for pretty much everything because every single audio file I have in here is just way too loud for some reason. I'm going to grab the volume property and put it within each howl that I created. So if I save that and refresh and I click, well, you can't even hear our map music until I really turn this up all the way, and that is a lot better, at least for my ears personally. So we just created the audio for our map and also the audio to transition us into a battle. The next thing we're going to want to do is add audio for both tackle and fireball. So I have audio files for both of those right here, tackle hit, and then init fireball. and then also fireball hit as well. Let's go ahead and add these into audio.js. So I'm going to go ahead and copy one of these properties, specifically battle, and paste it below. And now I know to start, I'm going to start with tackle. So this is going to be called tackle hit when we actually go ahead and bump the enemy back. So the property that has tackle hit should be equal to a new howl object with an audio file of tackle hit.wav, not mp3. And all these are already set. Should be good to go on that one. Let's do the same for fireball. Copy this property, paste in 2 new instances. So we start off with fireball hit instead of tackle hit. We'll reference fireball hit right here. We're just going to reference our file of fireball hit.wav. And then finally down here, we have one more, which is going to be a init fireball for when we actually create the fireball attack. This is going to be equal to, in these 2 locations, init fireball. So with all these loaded, now we can actually use them within our game. So when do we actually call tackle hit? When does our enemy actually get hit with the tackle? Well, it's going to be within classes.js, specifically within our monster class right here. So we'll go ahead and find our attack method. That's going to be here. And now if we keep on scrolling down, let's find tackle. Our case of tackle is right here. And we want to find the exact instance in which our recipient gets hit. And that's going to be when the enemy actually gets hit right here. So now that we know this is where our enemy gets hit, we can call audio dot what? Well, tackle hit dot play. So if I save that and refresh, well, now we're back at our map. It's kind of annoying to have to keep starting from here. So really quickly, we can go back to battle scene.js, and we know we want to start from our battle scene, so we'll comment out animate, and then uncomment init battle and animate battle. Save that and refresh, and now we're in the correct location right here. So now whenever Draggle gets hit with tackle, we should hear some audio being played. So I'll go ahead and select tackle, and there is the hit audio. Our background audio is also playing as well, unfortunately, because we started in this battle animation. So really, we know we're not going to have that problem because when you start our game, well, that's going to be the only time we really click on the screen. We're not going to start from this position. So what we can do temporarily, at least to start, is go to index.js, and we'll comment out our map audio just temporarily, so we can go ahead and listen in on our attack sound effects instead. So if I go ahead and click tackle, we definitely get that attack audio. Let's go ahead and do the same thing for when we use fireball. So we know we use fireball within classes.js, and we want to find our case of fireball. It's going to be right here. So we have 2 options for using fireball. One when we actually init fireball, and one when fireball hits the enemy. Where do we init our fireball? Well, as soon as we call the case of fireball. So here I can reference audio dot what? Well, init fireball. And then I want to call play on top of that. Save, refresh, hit fireball, and there is that init fireball audio. Let's go ahead and add the audio for when Draggle actually gets hit. That's going to be fireball hit.wave. Where does Draggle actually get hit? It's going to be right here. So here I can call audio dot fireball hit dot play. Save that, refresh, and now we have 2 sound effects that occur for that one animation, which is really cool. And the nice thing is, since we implemented our code in a way where Draggle can use these attacks as well, he too is going to activate the audio files for fireball hit and also tackle. So I refresh and start using tackle. Yes, it works on our end, but as soon as Draggle uses one, you're going to see we also get that audio in place. So now let's go ahead and add some audio for when either MB or Draggle faints. That audio is going to be victory.wav. So I guess it's not a victory if MB faints, but in this case, hopefully we always win. So Draggle is going to faint. But if we want to use victory.wav, we need to go to audio.js, create a new property. I'm just going to copy the very last one, paste it in, and reference victory for our property. And then I want to make sure that I change the source to victory.wav. That references this right here. So now when should we call victory? Well, whenever one of our monsters faints. So we know that we can faint within classes.js, within our monster class. Here is our faint method. So when we go ahead and translate downwards and fade our opacity down 0, we're also going to call audio.victory.play. Let's go ahead and save that and see what happens. Refresh, hit Draggle with a fireball, and now when he fades down, we get some victory audio playing in the background. I guess that is a nice victory sound for us. So now the very last thing we want to do is when we go back to our game, we want to replay our map audio. So we know that we go back to our game within battlescene.js, and this is going to occur whenever either MB faints or whenever either Draggle faints. So after onComplete, we can go ahead and call audio.map.play. And we want to do the same thing in the other location as well for when Draggle faints. So right here up above, because we are not using dry code for this quite yet. So I go ahead and save that. Refresh, start off in the battle, use fireball. We get our sound effects. All looks good. And we go back to our game, and now we're playing our map music, so perfect. Let's go through the whole process now. We're going to start off from the very beginning. We're going to go ahead and get rid of our map boundaries, and make sure that our game works as cleanly as possible using everything that we just developed. So within BattleScene.js, I know I want to start from our map, so I'll call animate, not init or animate battle. I'll comment those out. And over in classes.js, I want to find our boundary class, which is going to be down here. I want to make sure that I fade our boundaries out. So right here where we declare our fill style equal to a reddish color with an opacity of 0.5, I'm actually going to declare our opacity should be 0 instead. Save that. Go back to our game, refresh. And now all of our boundaries are gone, and it looks like we're actually about to play our game. So the last thing I want to do is back within index.js, I want to make sure that I uncomment this code for our map audio, save, go back, refresh, and then click. And I'll turn this up so you can hear it. And now our map audio is definitely playing, and we can go through these green patches right here to start a battle. So let's go ahead and activate that battle. You see our battle activation plays, our battle music plays in the background, and now we can begin. So let me go ahead and tackle. We get that sound effect in place, and he just straight up killed us, so MB is going to faint, and it sounds like our battle music is still playing. Should not play after someone faints. And when we go back to our map, we need to make sure that stops as well. So you'll see right there that our battle music was playing even though we fainted, and it's still playing even though we're on our map right here. So it's a good thing we're testing this because there are going to be a lot of small edge cases we need to take into account. So whenever someone faints, we want to make sure we stop our battle music. We can do that within classes.js. We're going to go ahead and find out where we faint. It's going to be right here on line 93 for me. So we're going to play our audio victory, but we're also going to stop our audio of battle. So we'll select audio.battle, and then say we want to stop that audio from playing. So to test that out, we want to make sure that this music right here stops whenever we use Fireball and someone faints. So I use that. That goes down to 0. And if I click again, that stops, and now our victory music plays. I click. And now our background music is playing for our map. That is perfect. Let's go ahead and test it out one more time. We'll go back into another battle by walking over one of these green patches. That starts, our battle music starts once more. And then I can use these different effects. And you'll see Draggle used Fireball, eliminated us, and be fainted. And now we can go back to our map, playing that original music, so perfect. Now the very last thing I would do to finish off this game is just heading back to attacks.js, selecting Fireball, and sending it back equal to 25. That way we just don't immediately win the battle, or Draggle doesn't win because they just used Fireball. So obviously there's a ton more that can go into this game, whether it be talking to other characters, entering buildings such as our houses, making sure our attacks have more of an effect on characters who are weak to those attack types or more resistant. But with that, we can go ahead and check off music and sound effects. If you would like to learn more and take this to the next level, eventually on chriscourses.com, I'll have some premium tutorials on conversations with other characters, entering other buildings, traveling to other lands, item collection and inventory, health bars and healing, and then gym battles. And one of the nice things is if you're subscribed to chriscourses.com, you can go ahead and download all the videos within this course, including the premium ones for later. And you can also view all the source code for each individual video so you can see exactly what was changed within the video that I just taught. There are also nice little chapters within each video as well, at least for the Pokemon course. So definitely be sure to check out that premium content. Otherwise, thanks so much for watching. I hope you guys learned a ton in this tutorial, and I'll see you in the next one.